Hi guys, welcome to Learn with W3Schools. My name is Dr. Zeeshan Bhatti. Today we're going to start a new course called C Sharp. Now, C Sharp is a programming language that is actually developed by Microsoft, and it is one of the most popularly used language for Microsoft platforms. Whether you're developing mobile apps or whether you're developing Microsoft apps or whether you're going into gaming and want to learn C Sharp is all there, and it is absolutely important that we understand and learn if you want to become a pro developer using Microsoft technologies. So today in this course, we're going to cover complete C Sharp concepts from A to Z using W3Schools website as a reference website. Now, reference website meaning that since it's publicly available, you can also see the notes. You can also follow along the examples. You can easily refer to the points later on and become a much better developer by having the notes and listening to the lectures and understanding the concepts. That's the whole deal. Quick disclaimer, I'm not being officially sponsored by W3Schools, neither it is an official W3Schools tutorial. I just love using this website, so there's no other intention. Since it's available there, so you can also refer it, makes things a lot more easy, right? Okay, so now go more into it. C Sharp. What we're going to talk about today in C Sharp. So if you have seen the C Sharp course, we're going to cover into all major concepts of C Sharp. Okay, so if I check out the W3Schools website, all of these main concepts will be covered today in this lecture. It's a long lecture. It's going to be have more concepts in it. We'll start from the basic intro, getting started, syntax, everything will be covered. Then we're going to talk about how we generate outputs, comments, and variables, data types, casting, everything we will talk about. How to get a user input using C Sharp. Also, we're going to talk more about how we use operators, math, and string operations to do on C Sharp using these various different methods with different classes, creating our own custom classes and everything, using conditional statements, using while loops, break and arrays, and going into OOP as well. So it's going to be a long lecture. Hold on to your coffees and maybe make sure there's a refill there so that we can learn all through. So follow along. Let me know in your comments what you love, don't like about this, any concepts, any issues. Shoot me a comment and I will try to make a video and explain things in a much better way with more examples. Okay, so let's start coding. And still haven't subscribed though, please do subscribe, leave a comment, like this video if you find it a little bit useful. It helps us a lot, encourages a lot, and supports the channel. Please do that, hit the subscribe, and then let's get coding. Again, if you want to learn programming, if you are into C Sharp and want to learn programming with Java and other courses as well, so don't forget to subscribe. Let's begin. Now, why learn C Sharp? Well, C Sharp is basically a programming language that is developed by Microsoft and runs on .NET framework. C Sharp is used to develop web apps, desktop apps, mobile apps, games, and much many more. Yes, you heard it right. C Sharp is used for all of these purposes. You can use C Sharp for web apps, desktops, mobile apps, as well as games. So if you have heard of Unity, Unity uses C Sharp at the back end to do that. Okay, so this is one major reason. If you go inside the next chapter, you will find that C Sharp is actually pronounced as C Sharp, even though we use this hash sign, but we don't use C hash. In fact, it's primarily pronounced as C Sharp for whatever reason. It's an object-oriented programming language. What exactly we mean by object-oriented, we're going to discuss more in the classes and OOP concepts, but basically everything resides in with respect to an object and a class, similar to Java. Okay, so if you have learned Java, excellent. If you haven't, I have a video of Java already posted on this channel, so do check it out. I will leave link in the description or somewhere on the icon, you can find that. So object-oriented basically means that in this language, everything is considered as object, and we create a class in which we save the data and methods and attributes, and then the object basically is able to represent that method. Okay, just like a car model is just one major car model in the company, then all the cars that are created based on that model have the same thing. So if you take Tesla truck, it has one same coherent design on all of its models. Okay, so all the lineup that comes, so if I build 1000, all 1000 will have exactly same shape, same tires, same GUI, same seats, same blah, blah. But the actual data of how the design is going to be is considered as a class, and then we create these individual objects that run with it. Okay, so it is created by Microsoft and it runs on basically .NET framework. C Sharp has its roots primarily from C, which I don't agree. Okay, for me, I believe its roots come from something called Java. So, and the languages other popularly close to is like C++, but it's more again to Java. In fact, at one point when it came, it was considered as a Java alternative, and many people still argue it's just a Java's copy. And you would find that if you have learned Java, learning C Sharp is quite a breeze, because almost 80-85% basic concepts are exactly same as in Java. Okay. Anyway, the first version did came in 2002, way after Java, and the current latest version is C Sharp 12, which was released in November 2023, sorry, according to W3Schools. Now, C Sharp is used for mobile apps, desktops, web apps, and all these other things, VRs, games, database applications, and much more. So learning this makes you a one more at one more level of understanding how application is developed, especially for your Windows. So Windows again primarily uses .NET and C Sharp to work with their applications. So if you are into Windows programming, you gotta learn C Sharp. So that's why it becomes absolutely important as a programmer, as a developer, to understand how this language is working. And this is what we whole this course is going to be about. So why we use CSS? Again, as I said, it's one of the most important popular languages in the world because it uses and is being used in all of these different technologies. It's easy to learn and simple to use. Again, depends on that, but yeah, it's very, relatively easy if you know already C, C++, or in Java. If you know any of these languages, it's a quite breeze. But I'm assuming that you're going to learn this for the first time. So hopefully throughout this course, I will take you in a very easy and much easier to learn approach. Okay. And again, I'm using W3Schools website just for the reference sake, so that you already have materials and notes, and you can easily come to this free website and reuse it. I just love this website. And just a quick disclaimer before we again go further, I'm not being paid or sponsored officially by W3Schools up till this point. Okay, in near future, never know. But now this is just me loving W3Schools website and using this as a reference material so I can share with you. It has a huge community. So C Sharp has a huge community that you can easily contact. But again, this community is quite active and quite useful, and we will be using these communities in later on other tutorial sessions, and we'll see how we can explore them. C Sharp is an object-oriented language. We already talked about that. C Sharp is close to C++ Java, as I said. You would find it's easier if closer to Java if you follow that long. It makes easy for programmers to switch from C Sharp or vice versa. So if you know Java or C++, it becomes much easier to learn C Sharp. Or if you have learned C Sharp and in the future you want to switch to Java, again, it will become much easy for you to do that once you have covered this course as well. Okay, so let's get started with C Sharp. Now, if you come to this link, C Sharp basically uses VS Studio. Okay, so we will be using VS Studio installer. You can download it from the internet. Again, you can find the link or go on to Google, just search for VS Studio installer, and the link is available. You can download it. Once install it, it's very easy to create projects with it. So you just need to click on the create new project around here. Once you create a new project, it will ask you that what is supposed to be your project details. So for example, if it requires you to install more tools and features, click on that so you can install more features if it's not already available. Once it does that, you need to choose something called a console app.net. For us at beginner level, we will be using that. So do make sure that you select this one once you click on the next and you want to install this feature here. Then create a new project and configure your project. So for example, provide your project name, provide the location we want to save your folders, and other details such as create new solutions and so on and so forth. Once you do that, you just run the Visual Studio Code and you can easily do that as well. I have a tutorial soon uploading that will show you how you can do this in your VS Code as well. So if you are using VS Code primarily, you can do that. You simply need to install an extension called C Sharp Dev Kit, and then it should basically do most of the task for you. Okay, and then once this is done, it should be quite easy to follow it on. Okay, coming back to the main syntax of it. Okay, so I hope you follow this. If you still need more help, let me know in the comments and I will explain exactly how to do that. I already have a tutorial on how to install C Sharp in VS Code. Just follow along and you can do it in VS Code as well. Just need one or two extensions. That's it. It's as easy peasy. So let's begin with the basic syntax and try to understand how this basic syntax is working and what basically we need to do. So the typical syntax of C Sharp or every single code basically will have this default feature for us. This default feature allows us to understand how things are working. So let me just zoom in. Okay, so first thing is we use using system. Okay, and then we use namespace hello world, block start, block close, class, program. This is where our object oriented concepts kicks in. So class basically represents your entire entity and data. Within this, we create our own methods and data, and then we use them. Okay, namespace is just like grouping multiple classes under the same project folder, if you follow that along. Then class program, basically program becomes the class name. Okay, so this is my class name. And again, you can name it any class name as you want. Typically, we give the name which defines the purpose of the class. Then we have static void main. Again, if you're coming from Java, you would find this syntax exactly same. We have a class name, block start, block close. And then Java uses the word public. In this case, the public is by default there. And then static void main, again, exactly same. The only difference is here the main M is capital as compared to Java. And then the strings argument array is passed here as an argument. In Java, strings has a capital S. C# uses a small s. Okay. So block start, block close for this main method. And then we use console.write-ln. Java uses system.out.println. Again, if you have not done Java, I won't talk much about as a comparison right now, but later on I will try to do some comparison to see how similar or different these two things are. Okay. Anyway, so this is basically typical code. Now let's just debug this code and try to understand what is happening here. So using system means that we can use classes system namespace. Okay. So this will allow us to use the system namespace in our system. A blank line is given. For example, the next blank line is completely ignored by C#. It doesn't count these blank lines. C# will look for the semicolons to know that when the statement is ending or the block code starts and block code end, indicating when the system is basically where the code is starting and where the code is ending in the system. The namespace is used to organize the code, and it is a container for classes or other namespaces. Okay, so it's used to organize your code, and it's a container which basically behaves like a folder or a package name, letting us know that hey, this program belongs to this project or this folder. Okay, and so there can be many other classes that come inside this particular folder or a package. Okay, so that we basically have a group or a container kind of a concept. The curly brackets marks the beginning and end of the code, meaning that the curly brackets indicate that my code now starts for this particular project starts from there and ends here. Then we have a class program, so the code for class ends starts from here and ends here. Then we have a method. Okay, we're going to talk more about methods later on, but method is basically a block of code that performs a specific task. You can create your own methods. Custom methods are created to do more advanced functions, or custom functions, or serve a particular purpose. We generally define it as a code or a block of code that performs a specific task. So this block indicates that, hey, the block means that this is a section of code that belongs to this entire one single block. Okay. The class is a container for data and methods which brings functionality to your program. Every line of code that runs in C# must be inside the class. Okay, so this is an important point. Every line of code that runs, that needs to be executed, must be inside the class. So we basically need to write everything inside this class. So project folder is just like a namespace is like a project folder, it's there, but actual code goes inside the class. So everything we write needs to be inside this class method. Class is basically a container for data and methods. This is a method here. Main is a method here, and then data will basically mean creating of variables and defining those variables and then using this inside our methods. Okay, so don't worry if you don't understand the using system, namespace, and class works. Just think of it as something that almost appears in every single program. So you will be using this structure in almost every single structure using system, namespace, and class. Okay, the class name would differ in every single code. We try to give a unique class name for our all class names. Another block is given for the main method. Any code inside this curly brackets will be executed. Don't have to understand the keywords before and after the main. You will get to know them bit by bit throughout this tutorial. Okay. So in general case, console is a class of a system namespace which has a write-ln method. So in this case, when we use a console, this is basically a class name. This exists inside the system. It's like a default library. Okay. We call this as a library, meaning that it holds some built-in functions and we don't need to create them. One of the functions using inside this library is called console. So console is again a class, just like this program class. However, this console class has some specific built-in functions. It has already been created by the good people at Microsoft for us to use. And the write-ln is a method that is used to print this text on our console. So we say console, go on a console and write a line called hello world on our console output. So we see this hello world output here. Console again is a class name that has already been defined and is actually part of this system package. Capish? Excellent. And then we come inside the next part, which is basically this write ln method is used to print the outputs. So if you omit the system using system line, you would have to write system.console.writeln. So do keep a note on that, that if you don't want to use this first line using system, you need to then provide the system keyword in front of the console, letting it know that, hey, there's a system package. Inside the system package, there's a console class. Inside the console class, there's a write ln method. Okay, and I'm going to use that. But again, writing, because we will be using console write and console write so many times in our code, so every time writing this extra word just makes no sense, just adds that bit of extra line. To simplify it, we just use it as a first line and ensuring that this package is automatically inherited and then becomes the part of our code. Okay, then every C# statement needs to end with a semicolon. This is a same rule as C++, and Java. Every statement that we write must be ending with a semicolon, with a semicolon. There's no semicolon here because if there's no semicolon, there's a block of code. Since there's a block of code, meaning curly brackets is there, then there's no need for semicolon. Class again does not need a semicolon because it starts with a block and ends with a block, and then the block does not need a semicolon. The method again doesn't have a semicolon because it again has a block. So if you're using block, then there is no need of semicolon because block serves a larger purpose, means that it will hold multiple lines of code inside it. So actually it means that, hey, I have started a class, but this class contains multiple things inside it. So you actually go and look inside for that single line of code, single line of statement, and that single line of statement has to end with a semicolon. Okay, in C# is a case sensitive language, so my class and my class have different meaning. Do keep in mind. So in this case, write is capital, L is capital. Okay, so write L are two capital words, so you keep in mind on that. If you make them small, this will not run. This will be a completely different thing. Main M is capital, so if you use a small main, it will create a complaint. A string is a small s. If you use it as a capital, it will create a problem. Okay, so do keep a keen eye on the small letters and capital letters, because C# is that. Unlike Java, the name of C# file does not have to match the class name. Okay, so if you have done Java and if you're coming from Java, you know that Java's class name has to be same as your file name. However, in C#, the file does not have to match. Okay, so you can name it differently, but they often do. But often people would use actually the same file name. While saving the file, save it using a proper name and add .cs extension to it. For Java, we use .java. For C#, we use CS as an extension to the end of the file name. Okay, so this would basically create our simple syntax. Now, let's talk more about the output. Let's talk more about how we generate C# output. Okay, so in order to generate C# output, you can use something called write ln method. How do we do that? So here's an example of it. So we write console.writeln to generate output on the console. Now, if you're coming from Java, this is similar to system.out.println. If you're coming from C++, we write cout. If you're coming from C language or Python, we use print functions or printf relevantly. Okay, but in C#, we use something called console.writeln and then bracket start, bracket close, curly brackets. Curly brackets is typical indication that this is a method. Okay, we're going to talk more about methods later on in this chapter. So for now, basically consider this is a method, which is basically a block of code that performs a specific task. Okay, every method in generally every programming language is considered as a block of code or a set of instructions that perform a specific task. In this case, specifically, write ln is a method that performs output or generates an output on the console. And then we are using something called console class. Now, console is a name of class. We talked about a little bit about the classes previously. So this console class contains a method called write ln, and this together will write the output on our console. If you tried yourself, if you click on this one, here's the typical program and here's the output that we get. Now, using system dot a semicolon, again, we have talked about this. Namespace my application, again, creating a namespace like a package, that this entire program belongs to this package. So if you have multiple classes, they can belong to one same package or same folder. Then we write class, program, P capital. Again, it's up to us. This is a class name. Usually any class name would suffice, but depends on what exactly you want to do. The purpose of your class usually is the name of the class. That's what a recommended thing to do. Then we wrote static, void, and main. This is the main function. So your code will have 1,000 lines, but the main function is the first thing your compiler will execute. So when we run the program, the first thing that the compiler executes is this main function. From here, the execution point starts. Okay, and generally take it this way. Okay, so obviously there are other things as well, but in a general sense, in a basic voice, we say that when you execute a code, the first thing that gets executed, or the first point of execution, is the main method. Okay. Then we have string arguments. Again, just that when this code executes, it might take some arguments at runtime before the actual code gets executions. In this case, we are not providing any argument right now, so it's just completely ignored. Do keep in mind that here M is capital, the P is capital. Okay. Similarly, C here is also capital. C sharp is case sensitive. So right L and L both are W and L in both right L and are capital letters. So console dot write ln and method is executed. So this will print hello out. And you can write multiple times as well. So you can write, for example, console dot write line. Okay, again, because I'm writing in multiple times, I usually give again W capital, L capital, and then I usually give these round brackets first, ensuring that this syntax is followed, then inverted quotation double times, and then I can say, for example, please subscribe my channel. Okay. Yeah, let's do some subscription, and then if you run it, basically it should execute these two lines. Now please subscribe my channel, we get these two lines available. Now you can write console.writeln as many times as you want whenever you need an output. Similarly, you can say that you can add as many writeln methods as you want, as just mentioned. So you can have writeln presided by the console. Now, what exactly do we mean by console.writeln? Console, as I said, is the name of a class. Just like program, this is our class name that we have created. Similarly, the good people at the C# backend, they created a class called console that contains all the methods and relevant code to print the output on the DOS command, or console as we generally call it. So when we use writeln, it basically means that this is a method that exists inside this class. Now, because we are using writeln method directly without yet creating an object of this class, so we need to provide or prefix this as a class name is provided. Dot is basically a connection operator that connects this class with this method. So it's like a class contains a lot of methods. So this public static void again is a method. This static void main is a method that belongs to a program class. Okay, so then we can create our own methods as well. As I said, we'll talk about this in methods chapter. But making it static allows us to create, or sorry, execute the code directly without actually creating an object of a class. So in fact, this method has also been declared as static. Okay, we talk more about this later on. So these are just initial concepts that you need to understand, that okay, console is a class that exists by default in C# library. We don't need to import it, it's by default imported, it's already included with this thing. So this is like a library file. It's already, when you execute, this library file is already imported in your system. Okay, so it's already there. So we are calling its method, but because we're not creating an object yet, we are not officially initiating this class. So we are using directly the class name dot writeln. Okay, understand? Hopefully. So you can also output numbers and perform mathematical calculations within the writeln method. So you can use console.writeln 3 plus 3. This would also work fine. So if I come back here and if I write another statement called console.writeln, oops, W-R-I-T-E, right, L capital I-N-A, okay, and semicolon. What happens if I will go further? So if I write a small line, and then if I can say hello, let's say 3 plus 3, what happens now? I have deliberately written a small L. So if I run this code, okay, so let's try to see what happens if we give a small L, or if we deliberately do a mistake in our code. Will our system generate an error? And if it does, what is the error? How does it look? Or will it ignore it and understand that, okay, you're trying to do something, and it will execute the code appropriately? Okay, so now you can see that it generated an error. It says that error CS0117, just a specific code about this error. Okay, and it says system console does not contain a definition for writeln. So they're saying that, hey, you are using system.console, and that console class does not contain a definition for writeLine method. So it says that I am not able to find this method writeln. Okay, so location of symbol related and all these details are there. blah 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 things, but this is most commonly the one we are looking for. So whenever we try to debug an error, we try to read the error and we try to understand. So this basically means that it's not able to find this write ln method. It says that I don't know where it is, and the console that you're trying to use, the class name, actually doesn't contain the write line method. But for us, its write line is there, but because we have used a small l, it's creating a problem. Similarly, semicolon. Remember, we talked about this. If you miss out a semicolon and you run the code, again we get an error, and it will now tell you semicolon expected. So you see, depends on what mistake you make, the errors will change. Okay, and you need to be able to understand what mistakes you are making, and you need to be able to understand the error messages so that you can easily debug the code. So in this case, it's telling us very clear and cut, listen, the semicolon is missing. Okay, so in this case we come here and we say, okay, if I use the semicolon now, I run this code, and if I've made this capital already, hopefully everything should work fine. So we see hello world, please subscribe, and then we get 6 Jan. Okay, so 6 is 3 plus 3. So you can directly do mathematical additions or print a number and print a value within your code as well. Okay, I hope that explains. So if I come back here, then there is also a write method which is similar to write ln. So just like write ln, there is a write method as well. The only difference is that it does not insert a new line at the end of an output. What do we mean by that? If I come back to my code here, so notice every time I write console or console.write a line, it adds a new line as well. Okay, so the word line actually means add a new line as well, on a new line, write this string on a new line. But if you write just something called console.write and brackets semicolon, then I go back, give inverted quotation marks, and I say without line. Okay, and if in fact answer is without line. So now I've ans, I'm missing keywords, so I've given deliberately space at the first. Okay, and then I run this code. So why this space was there, I will just show you in a moment. So 6, and then there's a space here. Okay, so deliberately there's a space, so you can give spaces if you want, and then you see answer is without a line. But now we say, hey, it is on a new line. That's because we wrote these 3 with a line, so it automatically added a new line after this. But this console is on the console write is on string. So now what happens if I write another string? Console dot write bracket start bracket close semicolon inverted quotation start inverted quotation close BECAU because of WRIT write method. Okay, and then now if I run this code, so now we have used 2 write methods, and now you can see that the because of write method is appearing on the same line. So that's the key difference that I wanted to show. First, whenever we write ln, it automatically takes the output on the new line and adds the new line as well. Okay, so in fact it can be considered that after printing the string, it adds the new line, so that the next line automatically, or the next write method automatically goes to the new line. However, if you just write after this write line, you will find that it's going on a new line itself. Okay, but if you just write the second write without the line, now it continues. So here's the thing to understand is, you write line, it prints a string and adds a new line after the string. That's why the next string is automatically printed on the new line. So it prints the string and then adds a new line after it. Okay, and then it prints the string, adds a new line after it. So that's why this method actually appears on the new line. So we assume that wherever we write a write method, it should concatenate with the first line. But because the write line method actually adds the line after the string has been written, so the next write method appears on the new line. However, this write now does not contain the word line, therefore there is no new line added here. Hence, the next write method that precedes this will automatically be on the same line. Okay, so now if I write any other string here, all those strings will be using the write method will be on the same line. Okay, so do keep this thing in mind. So this is what basically it's trying to do. So note that we add an extra space when needed after the hello world. So in this case, they added the space after the hello world so that it appears on next line. Let's just check this output out. So it says hello world, again space, I will be printed on the same line. So hello world space is here, and then it's I, because I starts immediately after the inverted quotation. So whatever you use within the inverted quotations will be printed as it is. So in my case, I previously added another space before it. Okay, so if I run this code now you will notice there are two spaces here. Okay, so there are two spaces here, one here and one here. So these two spaces are here because hello world is there, and here hello the space is here. So if you are using string, do be mindful of it, that the string will include the spaces, whatever the characters are within the inverted quotation marks. Okay, so in this tutorial we use the write ln method as it makes more easier. So throughout the remaining chapters, mostly we will be following the write line method. It will make things more easier to understand that every output is there, but sometimes we need output without the new line, so that's why the write method is always there. So do mind that if you need two strings to appear on the same line but you want to write them separately in a different separate consoles, maybe because of the loops or inputs or whatever case, and you don't need to break it into new lines, there's a write method there always. Okay, and wonderful. Let's move on to comments. Now, comments again are an extremely useful thing within C++ or C, Java, Python, and C Sharp as well, along with every other programming language. So no matter which language you come from, I C, C++, Java, XYZ, every language uses something called comments. Every language has its own unique structure, but most commonly they all follow the double backslash. Okay. Now, what exactly we mean by comments? First, let me explain that. Comments basically are notes to yourself that you don't want the compiler or executioner to execute and compile. These are like notes as a programmer, documentation help, information help, something you don't want to execute. You just comment it out. You basically make them invisible, but you want to make them there in the code, invisible to the compiler and the uh, what we call console output. Okay, so the code will not be compiled by compiler, nor it will be executed, but it will be there as within the code. So it's used as comments, or it's known as comments. So to prevent something in order to execute, or to prevent something that we don't want this to execute, we use these double backslash. So any text between double backslash and the end of the line is ignored by C sharp and will not be executed. This example uses a single line comment before a line of code. So in this case, we wrote the right console.write line, but we use this single line comment. What this now means that if you execute this code, you will now notice that there is something here. This is a comment. This comment is now completely ignored by the browser or by the console, and it's not executed here because it's a comment. This is just an instruction for the programmer, for the developer, for the team of people who are working on certain projects. We use comments to make sure to make our code more readable and executable. Okay, and we can write comment literally anywhere because they are completely ignored by the compiler. So I can write a comment here. Okay, so comment one, this is again fine. I can write a comment here. For example, I can say this is my class name used for test purpose, and then I can use, but I can change the class name. Okay, so what is this? This is instruction. I wrote something that I want to remember, that this is my class name, but I can change the class name, for example, later. So these are what we call comments. These lines will be completely ignored by the compiler and everything. So this comments allows us to keep like a short notes, instructions within our code, which are very useful, very helpful in understanding what we want to do. Okay, so this is what we usually, and these typically are known as single line comments, to keep in mind. This example uses a single line comment at the end of the line of code. So you can write the comment, as I said, anywhere, since they are ignored, as long as you just follow the basic, that make sure you don't write between these things. Okay, between a code, you don't disrupt the code structure. You can write the comments anywhere. So even at the end of the line, you can write the comment, because the compiler, anything that precedes double backslash will be completely ignored. So it doesn't really matter where you write it. There are something called a multi-line comment as well. Multi-line means when you do need to write multiple lines of comments. So in my case, I wrote something in these lines, but I can write into multi-line comments. So to do that, I use backslash static and static backslash. Okay, this is same as in Java as well, actually. So if you use backslash static and static backslash, backslash static would mean that I'm using a comment that goes for multi-line. Okay, so this is my test hello world class. Okay, for the C sharp course on my CH channel learn with W3Schools. I am Dr. Zeeshan. Please SUBSCRIB subscribe. Okay. Capish. Wonderful. So all these lines are now completely ignored by the compiler. They are known as comments. If you need to write multiple comments, we use backslash static and then we end it with static backslash. Okay. If you need to write single line, you can write single line. You can use this as well. So if you want, you can use all of these in a single line, but then that means every line you have to use these double backslash. Some people don't prefer it, but since I use main comment from start to here, even though if I use double backslash inside a comment, this will be completely ignored, because as per compiler, comment started here, comment ended here. Anything you write inside it is just completely ignored. So I can write whatever I want. Okay, so any characters, anything I can write will completely be ignored. That's why we use comments for notes purposes, for information purposes, for asking people to please subscribe as well. Okay, they are a wonderful way of doing that. Okay, let's go forward. So it says single or multi-line comments which you use. So it's actually up to you which you want to use. You can use single line comment or multi-line comment. Some people just use double these quotations even for a one line of code, no problem. Or you can use that. It's completely up to your choice. But make it a habit of commenting your code. Why you need variables? Why you need data types? Which data type is doing what thing? Methods, functions, if else. Wherever we go in our programming, we try to leave these short notes to ourselves so that we remember the purpose and how the code is working. Okay. Moreover, also before, I don't think so this guy talks about it, but you can use comment to comment out certain lines of code. So in this case, if I come here and I have this line, but I don't want to use this line, so I can comment out a certain line of code. Now this means this line is commented out, meaning compiler will completely ignore this line and this line will now not be printed. So if I run the code, I only get hello world. Why I got only hello world? Because I commented out this piece of code. You can completely do that. Okay. So if I come back here, I wrote multiple lines, and if I say, I don't like any of this code, so I can come back here and I can say, let's just use backslash static and come back here and static backslash. Now meaning that all this line of codes are commented out, and I'm just going to print these two lines. We totally do that. That's another purpose of comment. We comment out certain lines of code that is not working, for debugging purpose, for checking purpose, for evaluation, for ensuring everything is okay. If something is not working, we just delete it. Or if you don't want to delete some good lines of code that you have done but it's not serving the right purpose, but you want to keep the code, we just comment it out. Okay, so you can comment out the code as well. So as I said, anything you write inside these comments will be completely ignored by the browser, which includes the source code itself. So even though we have a code, if you comment it out, it's completely ignored. Class. Okay, so that's one thing to keep in mind. Let's move to something called variables. Now let's start a little bit deep diving into C#'s actual code. Now let's get that out of the way. Before we go further, if you want to learn C# in 10 days and still haven't subscribed, then please subscribe this channel. Give us a like, leave a comment. This helps and encourages a lot. So without further ado, let's begin and talk more about C# variables. Talking about variables, what do we mean by variables? Variables are basically containers that store data values. By this we mean that in programming or in general computer science, whenever we want to store data, okay, we need to allocate some memory inside our computer systems. In order to do that, we need a reference point where we can then again refer that memory location and retrieve the data. Okay, for that particular purpose, we use something called a variables. So variables basically behave like a container, like a reference point, like a bridge that hold our value and are stored in a memory and that contain a particular memory location. And hence, by referring to variables, we are again being able to use that variables and access it from within the memory. Make sense? Probably, right? So this is basically primarily the variables do. So in a simple nutshell, it does two tasks. First, it is used for storing data, but it also allows us to access the memory. Okay, it allows us to store the data in a memory, and using variables, we can retrieve the data from the memory. So in C#, there are different types of variables defined with various different keywords. For example, we use something called integer. Now, integer is a data type that defines that the variable that we will be using is of type integer, or integer basically meaning something that is considered as a whole numbers. So whenever we want to save whole numbers in our computer system, in our data, in our programming, we always refer to them as an integer. Similarly, if you want to use the decimal values, okay, we use something called a double. Now double is a data type, not a variable. Be mindful of that. Okay, these are talking about data types. So variables basically are of a particular type. This is the third thing about variables. First, they store data. Second, they store the data in memory and allow us to retrieve the data from the memory. Third, the variables define the type of data we want to save inside a memory. Understand? So these three are key characteristics when we talk about variables. Type of data meaning that if it's a number, it's supposed to be integer, because computers are considered in a way dumb machines. We need to tell exactly what we want to do. So if you're saving in whole numbers, we need to tell them that, hey, it's an integer number. If you're storing decimal values, you need to tell it, hey, it's a double value. Double refers here as a decimal value. If you are using character, if you want to save a character inside a memory, if you want to process character data, then you need to use character data type, and the variable will be of character data type, meaning that it will know that the data I have stored in my memory is of type character. So that's why we say it works like a bridge between data and the memory and the type of memory it's going to require to store that particular data. So a string again stores text such as the complete string hello world or any other information for that purpose. Finally, we have something called Boolean that stores two states, as we call it, two values only, either true or false. At any given moment, it will only have one value, either it will be true or false. Okay, so whenever we use integers, doubles, characters, strings, Boolean, we refer to them as data types. These data types are accessed or saved inside memory using this bridge called variables. How do we use these variables? Well, let's talk about declaring and creating these variables. To create a variable, you must specify the type and assign it a value. So we say we want to assign a type, which we just talked about in a moment. This is what a type basically refers to. And then we specify a variable name. This can be any variable name. So variables are technically any name that you give them. Okay, and then we equals and we give a particular value. So the type C is a C# data type, such as integer, string, double, or boolean. And variable name is the name of the variable, such as X or name or first name or last name or password or email, anything that you want to refer to this particular data type, anything meaningful. Okay, an equal sign is used to assign the value to that variable. So this equal operator is used to assign this value to this variable name. Let's see more practical example. So in this case, let's create a variable name called name, and it has a value called string John. Because this is a string, it contains multiple characters. So this variable needs to know that, hey, I'm storing a string. So inside a memory, we need to specify something called a string. So now in collectively, it is read as that I have a data called John. Because it's of a type string, I have created a string data type and stored this information in a name variable. So now name is considered as a variable that has data John, which is of type string, saved in a memory location. In order to use this John again, I will be using this name variable. So whenever now I use name, it will automatically refer to this John data that has been saved inside my memory. And console.writeln will print that name on our console. Okay, so now we have John printed on our console. To create a variable that should store a number, look at the following example, which is we create integer. So the syntax of this is, you see, is exactly same. The only difference is now we specify the different data type, because we are storing a number in our memory. We want to store a number in a memory. So we say, hey, 15 is a number, store this number in this variable. Because this is a number, we need to specify integer data type. So integer variable name is equals to the value. This becomes a typical syntax. If you're coming from C language or C++ or Java or Python, this syntax 99% is exactly same throughout all these programming languages. Okay, so if you plan to go for example, Python after this course, you would find that the syntax is same. We have a data type, we have a variable name, equal is there, and then we assign a value. Python allows at a certain time that you don't need to specify the data type. It automatically assumes based on what data we have. Java needs you to specify the data type explicitly. In C sharp also, we explicitly specifying that, hey, I have a variable that has a value 15, which is basically an integer number. So a memory would be allocated with a specific size in our memory, and the value will be saved in a memory. And in order to use this value, we will be required this variable. Then to print this, again, we will just simply use this variable. Now, once this variable has this value, I can use this variable in whatever function and values I want. So for example, I can say my num is, then it will print my number. Or I can say my number plus 5. Now what I'm doing is I'm saying, hey, I have a variable, it contains some value, read that value from the memory and add 5 to it. And then whatever is the outcome of this mathematical operation, print that on the console. So if you run this code, you get 20 because my number has 15 value in the memory. So this 15 is read here by this variable. So we are using this variable as an access operator, as something like a middleman that performs the operation of reading the data, fetching the data from memory and storing the data in the memory. And it needs to know that what type of data I have. So the middleman needs some information then, and that's where this integer comes into play. So we ask that, hey, listen, this variable plus, so we read the value and then we added 5. So my num plus 5 becomes 20. Okay, so the answer of this becomes 20. So my num contains 15, sorry, plus 5 values there. Okay, so you can also declare variables without assigning the value and assign the value later. You can create integer my num, and my num can then later have a value on a separate statement. Do always remember, whenever we talk about programming, this is a statement, this is a statement. So on first statement, we could declare a variable. Typically, I would use this as what we call variable declaration. Okay, in programming, we simply term this as variable declaration. Means we have declared a variable, and then here we basically use word called variable initialization. Okay, INITIALAZITIUN. Excuse my spelling. So my num is equals to 15 means variable VARIA. Sorry. Okay, so remembering again, IABLE. Variable makes sense probably. Okay, so this statement is considered as a variable declaration. This is known as variable initialization. So we declared a variable, but there is no value. That's why we have segregated two terms. When you write this as a collective, so for example, if I write integer x is equals to 10, this basically means that in a single line we have performed these both operations together. The declaration and initialization has been done together. So variable has been declared and its value has been initialized. And then you can process this as ever you want. So I can say my num, for example, multiply by x. So now I'll be saying, hey, I have two variables. One is called my num. It contains some value in the memory. Then I have another variable called x. It again contains some value in a memory. So read the value of my num and multiply it with value of x. Okay, this is why the variables become so important. It allows us to process and work on data rather than using the data directly. So each variable will store this value in the memory, and then when we call these variables, it will fetch the value from the memory and then do whatever operations we want to perform on them. Make sense? Good. So now that you assign a new value to an existing variable, it will override the previous value. So do keep in mind that if I have a variable num15, I can override it as well. So I can say, for example, let's just come back to this. I say, let's make it in this case, x is equals to my num, oops, my bad, my num multiplied with x. I can write this expression as well. Now what this basically means that, hey, take the value of my num from the memory, read the value, multiply it with the value of x. Okay, so whatever is your answer, assign that value back to x. So what this will now do is, initially the x value is 10, but because the mathematical operation is there after the equal, this will be performed first. Whatever the answer we get will be now assigned to this variable value. Hence the value of x will be overridden. Now if I print this value, so if I come back here and I say, listen, let's go inside the console dot, and let me use write with capital L, and I want to print the value of x. So I can say x bracket close semicolon. So now in this case, it's going to print the value of x for us. So if I comment this line out run the code, it will use this updated value of x. It will not print 10, it will print the 150 value. Why? Because x initially value was 10, multiplied with num, whatever is the answer has assigned to x again. So we can change the value ourselves. We can change the value manually as well. So later on we can say, listen, I appreciate this thing, but I want to change it. So now I can say my num is equals to maybe 25. Okay. So now what it will do, it will override the value of num and assign a new value here. Okay, makes sense. So other types, the demonstration of how declare variables of other types we can do, right? So the variable declaration can be done like integer num is equals to 5, but because you are using a double, we provide a double variable, my double decimal value with a d sign. So do keep this thing in mind. C# requires you that if you are using a decimal value, you need to use this prefix d. The d basically tells that this is a double value and store it. In terms of technical value, when we store a decimal value, this value is not stored in a single memory location. In fact, the denominator, the decimal value and the after post decimal value, these two values are separated and saved in a two separate memory locations. So that's why a d is basically there to identify that this is a double value stored in a two different memory locations, and that memory location is referred by this double variable. So when we use it, we will use 5.9, but inside the memory management is quite different as compared to integer number. If you want to define a character, we use again character data type. We use any valid name here, making sure that there's no space between the name. If you use a space between the names, now it will start to complain, because in this case, C# will consider these are two different things, two different words. Okay, and because variable name has to be one single word, using spaces will create errors for us. You can use underscore for that matter, not even dot operator. If you use dot, again complicates the things, because dot is used for some other purposes within our code, just like console dot here. It connects a class with its methods. So if you use that, it will assume there's a class called my and it has a method called num, but then the syntax is not correct, so it will throw a bunch of errors for us. So we remove this. So you can use underscore, but you cannot use dot or space as well. Secondly, do always ensure that the variable names are not same as keywords. Now, what do we mean by keywords? I believe we have not talked about certain keywords, yes, but identifiers in here, we'll talk more about them. Basically meaning the words that are reserved by C# for itself, like the word integer, like the word double, like the word character, like the word boolean, like the word string. These are reserved words, so you cannot use integer here. This will again create a problem. Or you cannot use integer double here. A double word has been reserved as a keyword. This is Java C#'s keywords. Okay, so C# consider this as a personal thing that they use for their own purpose. So they say, please don't use it for your names. I'm using it for my name. Similarly, keywords like class. Okay, class is also a keyword. Namespace is also a keyword. The word using is also a keyword. You cannot use this. Similarly, static, void, these are all considered as a keywords, and we will encounter many other keywords throughout this course. So we will be iterating this continuously. So do make sure that variable names are general names, readable, make sense, but they don't have spaces, they don't have full stops or any special characters. They can use underscores though, and they should not be keywords. Okay, moving forward, let's talk more about constants now. Up till this point, we were able to change the variable's value. So if I'm here, integer x is equals to 10, and I can say x is equals to this new value. So what we are doing, we overriding the value of x. We are changing the value of x after it has been initialized. However, there is a way of not allowing to do this in programming, even though you're doing it yourself. But sometimes the values and the can be changed by other programmers, or the value given by a user at the input or something of that sort. So we can restrict our system not to change the value. To do that, we use another keyword called constant. Constant, if you don't want any other values to any other system, any other user to change this value or override it, we use this constant keyword and we put it in front of the variable type. This will ensure that the variable declared as constant, meaning that it cannot be changed. It's a constant variable. Now you cannot change this value here. Again, if you're coming from C or if you're coming from Java, for example, we use the word final there. But if you're directly here, no worries, this is constant, meaning that now if I try to change this value, it will generate an error for me. Constant keyword is useful when you want a variable to always store the same value. So for example, the value of pi, we know the value of pi is supposed to be same throughout the mathematic calculations, no matter what you're doing. So somebody should not be changing the value of pi for their own purpose. So we set it to a constant. Hence, even somebody tries to change it later on in the code, it will generate an error for us. So just proceed it with constant if the variable value you don't want. Honestly, 99% time, whatever code I do, I rarely use it. Okay, but people are there, they prefer it, they like it. Some people tend to use constants a lot, ensuring that the variable values don't change and so on and so forth. So every programmer has its own preferences. I don't tend to use it, but that's why you see it's not a big node, it's just very small. Hey, constant, make it constant, you cannot change it. That's it. Move on. So moving on, now we're displaying variables. The write-ln method that we've already talked about is often used to display variable values to the console window. Now keep in mind, we mean variable values. Okay, up till this point, even though we use console.write-ln, we use the variable here, but it is not using in printing this word. It is using the value that is stored inside this value. Okay, so my num is a variable. This variable name directly cannot be printed. When we print it, actually the value that is stored or is referred by this variable will be used. So this is what a key thing that we want to talk about. To combine both the text and a variable, use the plus character. What do we mean by that? So if I come back here, so see, we have a hello John. So we create a string name, we name it John, and then we go inside console write-ln and we use another string. We say hello, but now we want to see what was the user that logged into my system, or the user that is entered, who has registered, and we want to send him a message. So whatever user has registered, we want to print their name with hello, right? Common thing that happens throughout the world. So we use string, but then we use plus here, and then we use the name here. What does this now signify? This signifies that, hey, there is a name called name string variable. It has a value John. Read that John value and concatenate it with hello. Here, plus operator is doing concatenation operation. Let me explain this a little bit further. Up till this point, in fact, in this example that we did just a moment ago, we did num plus 5. What it is doing? It is doing mathematical operation, right? What if I write a string now? If I write a string, the answer ANSW answer is, and then I give a space, and then I use another plus, and now here. Now what should happen? I've used a string, then I've used the plus, then I need my num, then I want plus, then I want 5. So ideally, we expect that there should be mathematical operation. But in fact, what happened was, it says the answer is 155. And now we realize, hey, why we did not get 20 that we got previously? We should have a number, it contains 15 value, and we say added with 5, it should be 20. But then because we have used string here, what's happening now that this plus operator is behaving as a double role. Okay, this is what we call operator overloading. Probably we will discuss this later on in polymorphism, but this means that now this plus actually has dual roles. It has two roles. If you use this in with conjunction in mathematics in terms of numbers, it will perform mathematical operation. But when you use this plus with a string, now it does joining, or what we call appending, or what we more technically we call it concatenation. Okay, concatenation means joining of two strings. So it will join this string first with this string. So it will say the answer is my num, which is 15. So the answer is first this 15 is joined together. Then because this now becomes a string inside the memory, it's behaving like, hey, this is a string, this variable is a string, because we have this is number, but we need to do concatenation. I cannot add 15 with a string, so it just joins them together, and then the resultant becomes a string automatically because the string is there as the first thing. Okay, so then this string is concatenated with this 5, hence we get 555. Okay, in this case, if you want to this mathematical operation to be performed, we use these brackets. Okay, so we add these additional brackets. These brackets have higher precedence, means the brackets, whatever you write inside the brackets will be executed first. So now if I execute the code, what happens is that it will do this mathematical calculation first and then do this string concatenation. So the mathematical plus operation will generate 20 and then string will be attached with it. So at this same line, we have used plus for two different purposes. Okay, this is called operator precedence, or basically what we say variable display. So in order to display this thing, we use the name. So for example, whenever we use string 1 and string 2 and we want to use the plus operation, it will basically not do a mathematical plus, it will do a string concatenation or joining of two strings. So it will join these two strings together and the answer will be saved in full name, and then when we print the full name, it will print John Doe here. Okay, so the same thing has been discussed here. So for the numeric values, the plus character is doing the mathematical operation. Okay, so whenever you're using integer numbers, okay, it understands that, hey, because this is a number and when I do x plus y, I'm going to do a mathematical operation on them. But if you're using string, I cannot do mathematical operation on the string. So what it does is it does concatenation here. So it's very intelligently deciding if it's a string, either one of them can be string and I will do concatenate, I will join them together. But if both are numbers, I will do addition with that, mathematical addition, simple as that. Okay, so this is how basically it works. Similarly, if I want to do something like this, okay, console.num here, and I want to say the value of, okay, and I want to print this, so I will use inverted quotations because I want to use the string, and I want to say the value of close the inverted quotation marks. Let's just give a space here after the of, so we get a number. We add plus, and I say my num plus, and again string, and plus, we use x, again plus, inverted quotations, added together are this thing. So let me show you the result first and then I will explain what I try to do. So if I run this code and if everything works not okay, should not be okay, I should get one error. It says unexpected symbol compilation failed. So there's an unexpected symbol my num. That's because we have missed out a plus here. So let me explain the plus here. Add a plus, run the code again. Hopefully now everything should work fine. So now see the output. It says the value of 15 and 150 added together are 2250. TOGETHER, if I'm spelling it right, together, probably. Anyway, so again, excuse my spelling. So now what's happening here is I've printed a string called the value of, and I want to print the value of number before I do the addition. So I'm using number multiple times, totally allowed. But because I'm using this string, I need to use plus, and then I used to do add number. Because this is a number coming from a data type as a variable, so I need to close the string, add a plus, and dynamically use this variable value here. Okay, so this is saying that I'm dynamically changing the value. So next time I can say if it can be 25, now it will print 25. I don't have to change any of this value here because whatever is stored inside my number will be printed here. So it will say the value of plus my num. So this string is concatenated. Then we say I need to print another string after this. Because I need to print another string after this value, I add another plus and I added inverted quotations and operator. So what now happening is this string joined with this variable, joined with this string, plus x, joined with the value of x. So and 150 is there. Okay, so plus joined with this string are added together, plus joined with this operation. Now my number is basically 20, again I said 25 and 50 are added together. Okay, control, or let me just re-execute it. I think I changed something. And okay, so we get 6250. Why? Because 25 multiplied by x becomes 25. Now here's another cool tip or cool idea or a problem that needs to be identified. I just said that whenever we use a string and a plus with a number, they concatenate. Then the result becomes a string. So then this string value is concatenated with this end. Then plus, because this becomes a string, this is added with this variable's value. So each variable's value is printed here. Then plus, again this becomes a string. Then plus, I should get my number 25 first. But what happened here is I got 6250, means 25 multiplied by 10 became 6250. Why these two numbers were not printed just like in this case? Which case? Where did that case go? I think I changed the same case. Okay. For example, if I go name plus 10 plus 10 here. In this case, if let me explain this. So now what I should get is, if I execute this code, because John is a string, plus the value 10 plus the value 10. So both values are printed as a string form. Their mathematical operation is not performed. However, when we go on to this value, we see that the mathematical operation was performed, even though this should be a string. That's because multiplication has a higher precedence. That's because multiplication has a higher precedence. In a case where you use x multiplied by 2 plus 3, or even for example we can say 4 plus x multiplied by 2. Now tell me which operations should execute first. Okay, will addition be done first or multiplication should be done first? Because that will greatly affect the result, right? Exactly. So in this case we say multiplication will be done first, then addition will be done, because multiplication has a higher precedence. Even though it's written afterwards, this will be executed first. Okay, that's because multiply and divide have a higher precedence. So in an equation, if you use multiply and plus together, multiplication will always be carried out first and then addition will be done. This is a programmatic law. Okay, I'm not going to debate into mathematics, but programmatically multiplication will be done first and then addition will be done. That is why we get to see this mathematical operation being performed and the value becomes 625, and then whatever is the answer here is concatenated with the rest string. Okay, so this is basically what it's trying to us to do. Let's talk about now declaring multiple variables. What do we mean by declaring multiple variables? Meaning that simply you can declare multiple variables on the same line as well. So you can say integer x is equals to 5, comma, y is equals to 6, comma, z is equals to 50. Means I have declared 3 variables on the same line. This is what we call being extremely lazy. People tend to do it. If I'm declaring it, I always will go for example, x1 is equals to 10. I will say integer x2, for example, or let's just make it y1 is equals to 20, and then integer is z1 is equals to, for example, 30. I always try to declare my variables. This is my personal preferences. I'm not talking about the glue coding, but I like to do it this way because I now know I have integer variable, y1 variable, z1 variable. But you can declare variables in a single line. Some programmers tend to prefer it. This is called the shorthand way. Saves time. That's the only case. Each variable will have same memory size in the memory, meaning that I have x is equals to 5 stored in a memory, y is equals to 6 stored in a separate memory, z is equals to 5 stored in a separate memory. It's just creating 3 variables in a single line, initializing them but declaring them on the same line. You can declare them separately as well, the exactly same way. There's no technical difference. It's just being a little bit lazy for that matter. You need to use comma in between though. Be very careful of that. If you don't use comma, if you use semicolon or any other operation, this will not work. It will give us errors. Okay, so this is what multiple declaration means. So when you use this, basically each variable will have its own independent value, but they all basically belong to integer data type. Okay, similarly you can declare multiple variables on the same line and then initialize them all together in the same line as well. In this case, the funny thing is that all variables will be declared and have a value of 50. So x is 50, y is 50, z is 50, because we have declared, initialized them or assigned a value to all variables in a single line, meaning z is equals to 50. This will execute first. Okay, so we say 50 is a value, we want to assign it to z, so this will execute first. 50 will be assigned to z. Now whatever is the value of this z will then be assigned to value of y. So z has 50 will be now assigned to y, so 50 will also be assigned to y. Then this y value will be assigned to x. Since y also has 50, the y will now, x will also get 50. Hence all three variables will have 50, 50, 50 independently in memory. Remember, x will have a separate memory, y will have a separate memory location, z will have a separate memory location. Inside our memory, each variable will have its own separate spaces. The only difference is because we declared them lazily in a single line, all three variables will have same value, 50 in one box, 50 in second memory, 50 in third memory. And then you can perform whatever operations you want on them. The operations will reflect the value to that. This is what we mean declaring multiple variables. But again, this is very short because most programmers don't tend to prefer to use it, but people do it. Okay, I personally don't tend to use it. I would explicitly declare them separate, making sure I understand the code more easily. But some nowadays people tend to use shorthands to make your code faster, optimize, and short way technically means the same thing. I'm not talking about in terms of fast speed. I have no idea about that. Maybe this is more faster compared to declaring them individually on lines. I have no comparison for that. Maybe it is, that's why they're doing it, to make your code faster, run faster, declaring variables on the same line. Probably that could be the case, or it could be even slower. I have no idea about that, but this is there. So do go for it. It's just a lazy way of doing it. It works fine. Okay, finally let's talk about identifiers, which we talked a little bit earlier. All C# variables must be identified with unique names. By identify meaning that what should be the name of this variable, how should we use variables. In fact, this should have been at the top, but this is most important thing. As I've mentioned, your variable names should not contain keywords, or should not contain spaces, or should not contain special symbols like at the rate, %, $sign, or so. You can use underscore. This is perfectly allowed. You can use numbers as well. So I can say minute 3 per hour. This work fine, but do not use space, because when you space, now they become two separate characters. If you use a full stop, this becomes it. C# will consider this as a class. Dot means a connection operator and connects with its methods. Moreover, console.writeLNV. So console is the name of a class. So it will consider that. So we don't use dot here as well. Okay. Third rule, make sure your variable names are not keywords. So integer is a keyword. Console is already a name of a class. So we try to avoid it. Static, void, these are keywords. Class is a keyword. Namespace is a keyword. Using is a keyword. And throughout the course, we will encounter multiple other keywords. So try to, and that's why we use the word keyword, keyword, keyword again. Whenever we say it's a keyword, means it's a word that has been reserved by C# for its internal use. And you cannot use it for your own class name. So when you give a class name, make sure the class name also does not belong to a keyword or is not same as a keyword. If you create a class name static, C# will complain. If you create a class called void, C# will complain. If you create a class integer, C# will complain, because keywords are not allowed class name. Okay. Finally, in terms of variable names, make sure you don't start with a number. That's fourth main key rule. Variable names cannot start with a number. They can start with a character and then have as a second. So I can, for example, say, let's have integer x2. This works fine. Okay. So this is a completely fine variable. I don't mind that. C# would say perfect, no problem. But if you put a number in front, now it starts to complain. It said, hey, what's 3? A variable name needs to be name. Name always starts with a letter. So make sure you start with a letter and then you can have a number, no problem with that. So these are standard 4 rules we say, talking about same things. So names can contain letters, digits, and underscores. So it contains letters, digits, and underscore character only. Name must begin with a letter or underscore. So you can use underscore as well as a starting character. So if I come here, I can say, for some strange reason, underscore x2. Okay. But again, I don't use it personally in my programmings, but people have it. It's an option that you can do. So it's there. Name should start with a lowercase letter and cannot contain white spaces. Again, we've talked about this. Names are case sensitive, so my variable and my var are different variable names. So make sure you are always aware that, hey, case sensitivity is a huge thing within C Sharp, and I try to follow that. Reserve words like C Sharp's keywords, integer, double, character, string, byte, public, static, void, all these other names we will be talking about throughout. You cannot use them as your keywords. Okay, dokie? Wonderful. So these are some basic rules that you need to follow whenever declaring your own variable names. Finally, one general rule is that make sure your variable is always representing the purpose it's trying to serve. So if my variable is supposed to contain minutes per hour, I give it a name that makes more sense rather than writing M. This is a very, 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 very lazy approach. Unfortunately done, I believe around more than 80% of programmers around the world, we use X, Y, I, very just being lazy. But typically it's recommended that you use a proper variable names so that it understands. Probably because in the software houses, when you work in the large corporate productions, there are multiple teams of people working on your same source of code and then sometimes access the same data. So the naming would be a huge help. And if your all variables are named as x1, x2, y1, m1, m2, m3, m4, it just confuses the code and kills the purpose, and debugging issues are there. Which variable is trying to serve which purpose and why it's being there doesn't really make sense. This makes much more sense. There's a variable that holds minutes per hour. Understand? Perfect. Excellent. So now moving further, let's move on to the new chapter called data types and explore this integer, double character, boolean, and string a little bit more in depth. So let's talk about data types. Now, data types, as explained in the previous chapter, are basically connected with variables, and they tell our variables that what type of data is being stored with you or within you and inside the memory. Okay, so data types are basically defining the type of data that is stored in the memory. So when we talk about data types, basically we are telling our computers that either I'm storing integer in form of a whole number, or I'm saving a decimal number which is considered as a floating values, or I'm saving a character, a boolean, or a string. These are known as a data types in C sharp. Integer being a whole number, double being the floating value or the decimal value, character being a single character with single apostrophe, whereas boolean is just true or false, any one value at the same given time. Similarly, string being a multiple number of characters in a double quotation marks. So the difference between a string and a character is quite important to understand, that a character is a data type that only stores one single character at a time. If you give two, it will complain. It only is able to store one character within a single quotation marks. Whereas when we use a string, we basically give double quotation marks and we enter a bigger number of characters here. Okay. So typically data type specifies also the size of the type of variable we are going to have. As we have discussed, the data types and variables also represent how data will be saved in memory and how much space is required by that variable or needed by that variable to store that particular data. So when we say integer, it basically means that it requires 4 bytes of memory space. It will store a number, but it will take 4 bytes of memory space. Inside your memory, whenever you declare an integer variable, it will take 4 bytes. Because it's going to take 4 bytes, the amount of data or the value that can be stored here is between this range. Okay, if any number, which is again quite huge, but still it has a limitation. If you any number bigger than this value, the system will crash and it will give us an error that the number is too big to fit inside 4 bytes of memory. This is how the memory internally works. Similarly, if in that case we will now use something called long. Now we haven't talked about long before, but long again is a type of number, or again is same as number. The only difference is it takes 8 bytes in memory. So now it occupies double the memory size as compared to integer. And that means that now it can host a very, 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 very large number of integer value from minus to positive. Okay, so if you are storing and if you are creating a program that is a huge number, for example, you all have heard that at one point the YouTube like button and the views button crashed. Sorry, not the like button, the view count crashed the YouTube system to a certain point, because a one particular video took so many views which was not able to hold in a particular variable data type, which was again a size Gangnam style video. That video got so many views across the world that the maximum value of a views that was allowed in that variable to hold was exceeded, and the system was not able to run. It generated error at runtime, and that's how we consider the YouTube crashed. Anyway, then they fixed it and then they used a different factor for them. So if you need a bigger number, we go for long. Then we have something called float itself for the decimal value, which take 4 bytes in memory. Again, it saves decimal number. However, we also commonly use a double, which takes actually 8 bytes. Okay, so if you are using decimal number, if you just know using a small values, we recommend using float, or if it's a whole number, we use integer because it holds a smaller number of memory size. The larger the number, the larger the type, the larger the memory occupied, the slower the system will be. For example, if you have 10,000 variables, or let's say even 1,000 variables in your entire application, imagine how much bytes it would occupy. So every variable will occupy that much memory space. So that's how the memory space is determined, along with other factors as well. The variables alone will occupy a certain memory space. Similarly, we have a Boolean, which actually takes just 1 bit. This is the smallest memory unit. 1 bit, it either be 1 or 0. That's why it is only able to store either true or false. The smallest unit of memory inside of a computer is known as bit. Okay, 1 bit, it holds either 1 or 0. So it only has true or false. Character, because it only contains the single character, it has 2 bytes in memory, and because it only has 2 bytes in memory, it can only contain one single character. Okay, similarly, we have a string. String is 2 bytes per character, so it's basically combination of character. So depending on how many characters you have used in your string, it will determine how big the string is. So size will vary, because you can have hello, you can have hello world, or you can have an entire paragraph here of multitude of characters. So the size is actually varying depending on how many characters you have. Okay, so that's why we say a general rule is that 2 bytes for each character, and then determine how many characters you have, you just simply multiply it. So do keep this in mind whenever we talk about data types. It basically is using memory space as well. So that's why we say whenever we're talking about data types, it's talking about the memory allocation as well, and we use this word continuously. Let's talk a little bit more about numbers. So numbers are divided into 2 groups. Integer types stores whole numbers, positive or negative, such as minus 1, 2, 3 or minus 4, 5, 6, without the decimal values. The valid types are integer and long. So these are 2 types that we use, integer and long. Which type you need to use depends on the value that's going to be stored here. If the value is just like within a small range, we always go for integer, because we know it's integer, it holds a number and it occupies less memory size. But for certain situations, if you have to have a big number, go for long. Okay, so integer is just simply created as integer. My number, any particular number, whole number that you give is basically assigned to it. We already talked about this. But when you use long, now you need to tell your system that I'm going to create a long. So for example, if I have a program long, my number, this is a bigger number, but then you need to use a capital L at the end. This is an indicator or identifier that identifies that this value will be stored in a variable that is of type long, and it needs 8 bytes in memory. Okay, even though if you are using, for example, if I create another variable called long, x is equals to 10, but I want to make sure this is a variable of type long. Okay, I will make sure I make it L. Only then it will properly allocate 8 bytes to it. If you just use 10, internally it will be considered as an integer, because this is just the 10 value. Okay, so system will say, hey, it's 10, only 10, so I'm just going to give it 4 bytes. Okay, so internally it will be considered as an integer having 4 bytes. So that's why we use this L for a specific reason, letting it know that even though I'm just using a 10 value, which is very small, but I want 8 bytes for it to be reserved, because in future this value will be multiplied, and the number can exceed to a very large number. Okay, and then floating point again is considered as a decimal values. Whenever we need to use decimal numbers, we always go for a float or a double. The same rule applies, because by default the data type for decimal values in C# is double. For a float, for a smaller value of 4 bytes, you need to use F more commonly, letting it know that do not occupy 8 bytes, occupy 4 bytes for this only. Okay, and then we declare a variable, behaves like a container. If it is double, we use a D here, letting it know that, hey, I'm creating a double, now occupy 8 bytes. Okay, so use float or double, which one we should use? The precision of floating point values basically indicate how the digits and the values can have effect can have after the decimal points. The precision of floating point values indicate how many digits the value can have after a decimal point. So the precision really depends on how many digits the value can have after the decimal point. The precision of the float is only 6 or 7 decimal digits. So do keep this in mind. So this means that after the decimal, how many digits you need. If you need only 6 to 7, we go for float. If you need a more value, okay, so we use a double, because double has almost 15 digits that you can use after a decimal value, and that is how they determine whether we go for a float or a double. So for example, if you are printing a complete pi value of pi, which is again, if you bigger value 3.1.555 blah 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 numbers, so 3.1.33, I think something is that, right? And you want to print the whole value, so we go for double, because we want to ensure that the maximum digits after the decimal are there. So it's always safer to use a double for most calculations. That's one major reason. Okay, you can use scientific exponential notation with float and double as well by using this e symbol in between. So a float point number can also be a scientific number with e to indicate a power of 10. Okay, so we say, for example, 35 exponential notation 3 means e to power 3, and then we provide f again if it's f, or if you are using double, then we use e 4 power d. Okay, this indicates that this number is 12 power 4 in this case, and 35 power e, and then you get that value represented here. If you print it, it will solve and print the actual answer for that. Understand? So this is again one very useful feature if you are going into mathematics, creating a mathematical programs for some reason, and you want to put data in exponential notations. This works fine. Okay, Boolean, as we said, is a very simple thing, true and false. Why we need them? Actually, we have a Boolean data type. It only stores true and false. Understandable. But actually, Boolean is a very, very important data type that is more prominently used with if-else looping conditions, because it holds a value called true and false, and this is the value that is needed by if-else, switch, and while and for loops. We're going to talk more about this in this section. But do remember, whenever we do a simple calculation in our system, the data type matters, even though you don't specify. So for example, if I come back to this code, or let me just say in this code, for a simple reason, I have my number and I do plus, for example, 10. Okay, so now what happens is that the system will read my number, add 10 to it, and the answer is actually saved in the memory again before it is printed on the screen. So when we have that thing, that when we want to save that answer, even though we are not doing anything with the answer here, we just want the answer to be printed, it is not directly printed on the screen. That answer is actually stored in the memory somewhere, and the system needs to know that what is going to be the type of this answer. So in this case, the answer will be of type long, because we are using long, right? Similarly, integer, byte, float. In that way, and where there are certain expressions that we will be using, and I will talk more about that in operators, they need the value in form of Booleans, and they need to tell our system that this is a true or false value. Okay. Then moving on, we have character data type. Character again is a data type that holds a single character in a single apostrophes. Okay, single quotations as we call it. Any character, any number, any value will be behaving as a character occupying 2 bytes in memory, and they are used inside single quotation marks. Again, quite useful in various different situations. A string, one of the most commonly used data types, is basically containing multiple characters, alphanumeric, escape characters, special needs, special characters, anything that are written in words inside the inverted quotation marks. So do note that whenever I use this string here, this is printed in form of string. If I come back here, I have a string. When I use even the system, the print inside this console.write ln, I use hello. This again behaves like a string, and if I add plus to it, now basically what we are telling that this is a string. So this string is again stored in memory before it gets printed, because everything is processed inside by processor, and then it's stored in the memory before it gets printed on the screen. So this string also needs to be told to the system that, hey, I'm printing a string. So the system or the compiler needs to know what type of data this is, And for that, there's a specific understanding within a system that I'm using a string data type. Okay, so even though you may not directly use it, but internally systems always use these data types as well. So any number of characters in and double quotation marks behaves like a string, and we're going to talk more about the string specifically within the strings chapter, where there are various different ways, methods that are available that we use to operate on this string. Okay, so this is a data types. Now connected to a data type is an important topic called casting, which is absolutely essential that we associate with our data types. Okay, casting means converting data from one type to another. Okay, that's the common way of dealing it. So typecasting is when you assign a value of one data to another type, i.e. you assign a value for float to an integer. Now float is a decimal, integer is a whole number. How can I assign a decimal value to an integer data type that can only store what we call a whole number? Or in that case, for example, a character can be stored inside an integer. Can I do that? I don't know, maybe. So this is what typecasting does, and it occurs regularly in our coding, especially when we're taking inputs from the user. Usually we don't know what values they enter and we need to process them, and we need to know the type of it. So typecasting is a phenomena that deals with assigning value of one data type on another data type. Okay, so in C# there are two types of casting. One is known as implicit casting and another one is known as explicit casting. Implicit casting is known as casting that is done automatically. In other words, the assignment of data from one variable data type to another variable data type is done automatically, and we don't actually have to worry about it. But we have to know that this is happening. Okay, so converting a smaller type of data to a large type of data is considered as automatic casting. What do we mean by smaller type? Remember, we discussed about the data types memory size. So this is where we determine a smaller type to a larger type. So character is the smallest type. It occupies only 2 bytes. Because it occupies 2 bytes, the character can easily be assigned to an integer or a long or a float or a double, a larger memory size. Because it occupies 2 bytes means it has only 2 value. A 2 value can easily be adjusted into a larger memory size. Okay, so this is where our automatic casting takes place. So it shows you here, character can easily be assigned to an integer, and this automatically done because 2 can easily go inside the 4 spaces are available, we have 2, can easily adjust. Similarly, integer can also be assigned to a long, meaning integer is of 4 bytes, long is of 8 bytes. I can easily automatically assign 4 byte value to an 8 byte value. And then similarly, a long can easily be assigned to a float or a double. So this is a hierarchy that we follow: character, integer, long, float, double. However, what if we reverse it? Now double is 8 bytes, float is of 4 bytes. So what happens if a larger memory size value is assigned to a shorter memory? Similarly, long is of 8 bytes, integer is of 4 bytes. What happens when I assign a larger memory size to a smaller memory size? And then goes from integer 4 bytes to character byte. That also means, again, this is not the exact sequence, it's just letting us know the hierarchies, meaning that I can have long assigned to a character as well, but long is 8 bytes, character is 2 bytes. So what happens now? Where the remaining 6 bytes of data supposed to go? So this is the problem. So that's why it does not happen automatically, and we need to do something called explicit casting. Okay, let's see a few examples of implicit casting first. For example, I declare an integer, my integer 9 value. So this my integer has been declared. We know integer occupies 4 bytes in memory. Then we go to double, is an 8 byte variable. So my double, and I assign the value of my int to double value. So this is a variable. This will have a value of 9 in its memory, occupying 4 bytes. So now what we did here is we said, hey, read this value and assign that value to this double data. Because double is 8 byte, this is 4 byte, this is automatically done. Automatically casting is done here, and I don't need to worry about it. Okay, so this is what we mean. We can easily assign integer to a double value without any problem. And then when we print the value, my integer will have value 9 and double will also be 9 because we have assigned the value of integer here. Explicit casting is when we explicitly need to tell C# that, hey, you need to do this conversion. And the way we do it, there is, for example, I declared a variable double. I have a 9.78 value. I create an integer, my integer is equals to, I use the same technique that I did with implicit casting, but this time we use parenthesis integer. These parenthesis integer is a very simple way of doing explicit casting. Means now we are telling that the value of this double, which is 8 bytes in memory having 9.78 value, needs to be converted into a 4 byte value and then assign it to that 4 byte variable. This is a very simple way of doing casting. So we just use parentheses and the data type in which we want to cast to. So when we print the value, again, the first double will print 9.78. The integer, because is only supposed to be whole number, it will remove the later part. Okay, the decimal values are lost and we just get the 9 value. So there are various different methods to do that. Okay, so type conversion method. So it is possible to convert data types explicitly by using some of the built-in methods, such as convert to Boolean, convert to double, convert to string, convert to integer 32, integer, and convert to integer 64. So for example, if we have integer, double, and a Boolean variables, you can use convert. Again, note C is capital. To string, T is capital, S is capital. C# is case sensitive, so we need to be aware of it. So now what we're doing is we are using built-in methods to convert integer value into a string form, or an integer value into a double form, or a double value into a 32 bit integer, or 32 bit basically means 4 bytes. Okay, so I hope you know this from programming. From general computer, 8 bits is equals to 1 byte. So 4 bytes would be actually 32 bits. Okay, so this is where the 32 bits actually come into play. And then we can say convert to string my Boolean. So my Boolean will be now converted into a string value. Do remember that this convert represents a class name dot a method that exists inside this class name, and then we are passing it an argument of this value. So this is known as an argument, passing a value by an argument to this method that exists in a dot convert class. Understand? So we have a class that's already doing all these tasks for us, just like class program. So this is a class that we create on our W3Schools website called program. Similarly, there's a built-in class called convert. It's automatically there. We are already using it. We don't have to tell anything to our program to do what. It's by default imported. So this convert class contains a methods called toString, and we are using that method to convert our integer into a string form. Okay, so this is what we say, that there are built-in methods that you want to do that. We would talk about how to create our own custom classes and custom methods later on in methods and classes chapter. So do stick around. Okay. Okay, so once we have done this, let's do some real world examples of this thing. So let me just close everything else. Close. Okay, so for example, if I reopen this, we have the basic program already written for us. Once we do that, let's talk more about what kind of programs we can do for that. So for this, I have already created a simple program list, which is, these are some programs I'm working on, and I will hopefully by the end of this course I will share these programs with you so you can do these practice tasks and submit the code or discuss with me if you are having any problem with that. Okay, so once okay, let's just start with this. So first of all, the first program is write a C# program to input two sum of numbers. Very simple, very easy, very basic. How do we do that? The idea is very simple, as we all know. I'm going to use Word here, and my idea would be that I create an interactive manual where you actually save the code with each task yourself. So it will be like a worksheet kind of a thing where you solve it on the paper. You can use the W3Schools editor, or I will share a link of another editor called C# Online Compiler. If I open it, you can use this one as well. This is also works perfectly fine, no problem with that. So let's just use again this one compiler and try to create this simple program for us. So it says that the basic idea is again here that we need to write a C# program to print two numbers. This is our exercise number 1. Let me just copy this and let's just go to our online compiler and comment places. So this is our exercise task number 1. We need to do that. How we supposed to do? Well, the basic idea is very simple. We need to take two numbers and add them together. As simple as that. But you need to write something called using system. Okay, so as we know that every code has to begin with this thing, so we need to write this, such as using system. Okay, and then we use something called namespace, and in this case I'm using let me just use my name as my project name, C sharp, block start, block close. Every code needs to have that. Then we need to write a class name, so we write a class name, and we can say, for example, exercise 1, block start, block close. Okay, so this becomes our basic boilerplate. Then we need to write something called, oops, not stack, sta, static. We need to write void with capital M, bracket start, bracket close, and we used to use something called a string, and then square brackets for defining an array, arguments, block start, block close. So now this becomes our boilerplate, and every C sharp course needs to have that. The reason we want to do this separately from W3Schools, that we don't use this code, we try to retype it. The more you type from the start to end, the more proficient and you understand how things are working within Maya. That's how the best way to practice is. So once you write this, now the question is very simple: print sum of two numbers. Now it can be that I can say, hey, listen, okay, if that's the case, let's just take integer and number 1 is equals to, this can be, for example, 20 semicolon, and then I can say integer number 2 is equals to, for example, 30, and then I go, hey, listen, I know to print the output I need to use something called console dot write line, 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 bracket start, bracket close, inverted quotations, and I can say the sum of number 1, which can be, let's just use plus here and say no1, which basically will represent number 1 here. Let me delete that. Okay, so I can say the sum of, or if you want to print this thing, just skip it, the sum of number is, and what is it, we can write here. Let's just use it in terms of console dot write, and then print semicolon, and then I can write, hey, listen, console dot write, and I'm using write, not ln, because I don't want this to appear on the new line. Whenever we use write, also works fine. We've talked about this. It will basically print the answer on the same line. So now we come here and we can say the sum of number, and we get plus number 2. Okay, so this is going to print number 2. Don't forget to give semicolon, and then again I wrote console dot write, bracket start, bracket close, inverted quotation start, close, and I can say is, and then I can go here and just print this thing plus, and I go, listen, 20 plus 30, oops, and then give a semicolon here. But the problem with this is, now if I execute this code, is a compile time error, right? So the compile time error says that we are expecting some issues, 6 errors in this code. Whoa, why 6 errors? What the hell? Unexpected symbol underscore, there's no underscore in my code. Why is it giving me, okay, see this underscore here. So this symbol here, the minus sign, we have used exercise-1. Because of this small thing, it has generated like tons of things. So minus is a reserved word, it understands this is supposed to be there. So let me just remove it and say exercise-1. I can use underscore though, okay, not the dash sign, underscore, this under 1, this should be fine. So if you want to use this, underscore should be fine. And now if you run the code, hopefully there should be no error. Okay, so don't use minus as a name, as a variable name, or as a method name in formula. Minus, plus, these are considered as special symbols, more prominently reserved symbols as we call them, so you cannot use them. Anyway, so exercise-1, basic boilerplate, integer number 1, integer number 2, the sum of number 1 and the sum of number 2, and because we've used the write method, see this, the output is on a single line. That's the beauty of it. This is exactly what we want, and we can write the entire expression on a single line as well. Okay, but just to simplify things, we wrote it in different console statements. So the first thing we got is the sum of, now the number 1 value is 20, so we got 20 printed here, and 30, which is basically the sum of value here. Now the reason it's showing us very nicely as well with the spaces is because if you note, I have given it spaces. So off, after this I have given a space, then inverted quotation marks. Okay, and that will create a difference in your output. So for example, if you just close it like that, like mostly we do, and we write and then we close this is like this. So because now we remove the inverted quotations, spaces before the inverted quotations, see this, the number appear together. Okay, so we just need to be a little bit intelligent. If I want a space after off, I give a space after off. I need a space before and, I give a space before and after and as well. And then similarly before is, and then after is as well. So these spaces within the inverted quotations do create an important aspect. Finally, the major difference is that we get the answer 2030, because we have done plus 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 plus. Again, Why we got that? We should have proper 50 answer, right? But we have talked about this. The inverted quotations always represent a string, and when you add a plus to it, it means you are joining two strings together, or you want to join something with the string. So when you have a inverted quotations plus 20, it means that you are joining these two strings together. And then when plus 30 means that now it's joining the rest of the string together. So actually this is joining the strings, which technically we use the term concatenation. Okay, so that's the whole idea. Now if you want to do this, there are two ways of doing it. First, you use the brackets explicitly. This will make sure that you have a higher precedence. Brackets has a higher precedence. It will make sure that the brackets gets executed first. So 20 multiplied by 30 will actually be executed first before it is concatenated with the string. That way it will do the mathematical calculation, because now no string is involved on within the parentheses of. So it will say 20 plus 30, 50, whatever is the answer is 50 will now be concatenated with this string, and we should get a result perfectly fine. See, 50. This is the one way of doing it. Now the second way is, usually we do is we create another variable integer ans is equals to, and we say number 1, no1, and we do plus, and we can say no2 semicolon. So we create another variable and we save the answer in that variable, and now we can write console dot write bracket start bracket close inverted quotations, and we can say the new answer is space plus, and now we just print the value ans. Okay, so this way it will basically ensure that we get the output on the new line. So if I run the code, we get an error. That's because it says compilation failed, one error, and somewhere it is doing this. So do also understand how to solve errors, because you will be coming and getting more errors. So when we read this, it tells us there is one error. Hello world CSS, this is the error code, and it is telling us to a certain extent that a semicolon is expected, and which we note here, I've missed out the semicolon. So most probably it will tell us exactly where and what line of a point we have. So here, see this, it says 20. This is actually the line number on which it's expecting an error. If you go here, line 20 is actually these brackets here. So if there's no semicolon, it assumes that there is no this statement is still continuing and there's no break, and then it goes here and it finds a closing bracket. So actually the problem the compiler finds is at this point. So that's why it's giving us a 20 number. So it gives us a roughly idea of where the error could occur, and we can find. So if you have like 10,000, 20,000 lines of code and one semicolon missing, if you don't know the number, then it becomes difficult to find exactly where we had the error. Anyway, once this is corrected, the answer is 50. What if I want this answer to be on the new line? Okay, well, there are two ways of doing it. First is this one, \n. Okay, backslash is known as escape sequence. To add a new line, we wrote this as a \n, and \n is considered as a escape character or a special character which adds this new line feature within our code. So now we have this new line added here automatically, even though we use a write method. But if you want this, the second method would be that if you want this to appear on a new line, you can use write ln before its previous statement, because write line will add a new line after the output has been generated. So after this output has been generated, a new line will be added, and then this statement, even though it would be write, will always be printed on a new line. So if I write a line before this statement, because I want a new line here, so the previous statement I had a write ln, I want it on a new line. Now if I run the code, see this is on a new line. So you can use write line. So it will ensure that after this, it will add a line break, and the next line that would follow would automatically be on a new line. Okay, so that's what a line does. However, if you still want to do this, you can use \n, and then you can run the code, and now you see there are two lines of spaces here. So that solves our task number 1. Let's just come here, and I will usually love to do this. This is the idea, Control C, come back to your Word file, and I have solved it. Okay, so now I can say solution. Okay, as I said, I'm working on this book, so hopefully I will try to finish it in time. I can paste the code. Hang on, Control Z, Control V. Okay, okay. Now I have this code created for me, and let me just add some tab. And I was supposed to format it, so sorry about that. So let me just make it a little bit smaller. Anyway, so this basically solves our task number 1. Let's move on to very quickly task number 2. Task number 2 says write a C# program to print the result of dividing two numbers. So I have this new page. I open the code again. Let me just delete this, comment, write a C# program to do the dividing two numbers. Okay, so this is our task number 2. Now for me, I'm being little lazy, so do excuse me for that. I'm just copying the whole code. Control C and Control V. I will rename it to exercise number 2 since I just need to divide these two things together. Okay, I'm not worried about too much about any other thing. So it's almost the same task except the division value. Now I divide it and same answer can go for here as well. Okay, divide it, and instead of sum I will just change it to divide. Now if I run the code, the divide of 20 and 30 is 0. Okay, where is 0? Let me just do this. 20 divided by 30, obviously the answer will be in points, and this answer is going to show us in 0 values. So let's just make it more convincing. So I can say, hey, 30 divided by, for example, 4, or let me just make it 5 for fun's sake, divide it. Now answer is again 0. Why is 0? Because we used 20 here. We didn't use number 1 here. So we say number 1 divided by NO2. Run the code. Now answer is 6. Finally. Phew. Okay, so previous mistake. So the previous code we had actually, we even created the variable, but stupid me, we used the values directly. So actually for this, the perfect answer would be number 1 plus number 2. All right. So make sure we update that in our system as well. So this is supposed to be that. And then if I go inside the division, now I divide it. Use the same value. So whatever answer you have, you run this code, you get 6 in this case. So for example, if I make it like 60 and divide this by 3 and run the code, so the divide of 60 by 3 is 60. And then you can print whatever you like. So once you have this code, very cheekily, I copy it and I go to my Word file and I say, hey, I did that. So I can say SOLUTI in solution. This is solved, and I put the code here. Let me just add it. Oops. Just like this. Okay, so this works fine for us. We have our code. Let me reduce the font size a little bit so it's more readable. So task 2 now complete. Now let's get into a little bit more deep, and we said create a C# program to print the result of the specific operations. So if we have such kind of complex mathematical operations and we want to perform the result on them, how do we do that? So now things get more interesting. Okay, so first thing is first, again, if I copy this line, or let me just copy the whole thing. Oops. Control C. Let's just create a new file, open my one compiler and kill everything. Comment, just paste the task number here. This becomes our default code. Now, again, as writing this, I will try to do exactly same as we did previously. Meaning that we will try to create the code from scratch and we try to work with that. So we will be using system semicolon. So we know what we're doing. We will be using namespace, and I'm going to give a same namespace because everything for me in this case belongs to same project. CS block start block close, bring it down, class, and then this can be, for example, exercise 3 without the dash. Remember, dashes are not allowed. So now we have exercise 3, and every code needs to have static, STA, static, void, M capital main, bracket start, bracket close, string with a small s, square brackets indicating an array, and a variable name, okay, which can be any variable name for that matter. And then we're going to give curly bracket start, curly bracket close. So this becomes our boilerplate code. Now it says, what do we need to do? So if we jump back to our program, here one, so we need these kind of outputs. So let me just copy this and come back here. Let me write a multi-line comment. Oops. Steric and steric backslash. Multi-line means that I have a multiple lines of comments and I don't need to use backslash in front of everybody. So I just put them here. So now these are the expressions that we need to write the code to generate. Okay. And then similarly, there are several ways of doing it. It doesn't exactly say that we need to create variables or data types, or we want to apply operations on them, or so on and so forth. It just needs to do these mathematical calculations. Since the program is not so specific, and we just want these calculations to occur. Let's do it in a very simple and easiest manner. So we're going to do, hey, system, console. We're going to say console dot write line, bracket start, bracket close, and now we want the answer to occur. So first thing is I will use inverted quotations. I will copy this, Control C, Control V, and I will use the ANSW answer of this is equal to, and then I'm going to use plus, and then I'm going to use the same expression. So I can, because now this is a mathematical expression, and the problem I just mentioned that if you are writing a mathematical expression with the plus of string, it's going to concatenate. So what we need to do is we need to add brackets, exactly. And now we're going to use the same expression. So -1 space plus 4 multiplied by 6. Hit a semicolon. Okay, let's test this program out. Hit a run to see if everything works. So we get that. The answer of -1 plus 4 multiplied by 6 is equals to 23. Perfect. How did it become 23? Again, you need to understand how expressions are being evaluated inside C#. As I talked, when we write 6 multiplied by 4, the multiplication is always done first. If you have -1 plus 4, if you solve this first, now the answer would become completely different, or can become completely different, depends on how you write in expressions. So in an arithmetic setup, a multiplication is always executed first because it has a higher precedence. Similarly, brackets in fact have a highest precedence. Even with above multiplication, we have a brackets. So if I need to do this as a subway, so for example, if my expression required me to solve this thing, now this means that I have put them under parentheses. This becomes parentheses, and then outside it are more parentheses. So do follow it. We have this thing. Again, this is a standard mathematical expressions. If you go for basic mathematics, you would have come across using multiple brackets. We use the same brackets in multiplication as well for solving any standard regular expressions. So here parentheses has these round parentheses, round brackets have a highest precedence. So whatever is inside the innermost brackets would be solved first. So now here it will gonna solve this first. So if I run the code, okay, now see the answer is 18. See the difference? So now the answer is completely different as compared to previous 21. So if you, let me just copy this, if I show you in a better way. Control C and Control V, and if I remove the parentheses here, and remove the parentheses here, and in fact if I put parentheses in this point to make it more evident what exactly we want to do, and now run the code. So if you use parentheses, this parenthesis gets solved first, and then whatever is the outcome of it is multiplied here. Okay, but if you don't use parentheses, now what happens, multiplication is automatically done first because of its highest precedence. So multiplication will be solved first, then whatever is the answer of this multiplication, 6 multiplied by 4 is 24, or 6 4s are 24, then -1 will be used to subtract, and 23 is obtained. Okay, so that's the difference in terms of operator precedence and which expression gets to evaluate first. Once we are done with that, let's move on to the second expression. It says console dot write line, bracket start, and then inverted quotations, and I again put the same thing, the answer of, and this time we have this expression. See this, now we are using parentheses exactly in the same manner. So it is telling us to, what if I use 35 plus 5 and then mod 7. This mod again is known as a remainder operator, or percentage is known as a remainder operator. So it is going to take this sum of amount and going to divide with this thing. So if you write this expression in our syntax, so we're going to say is equals to, and we hit plus, and then I'm going to paste the whole expression again. So now what it's going to do is, it's going to do this parenthesis first, and whatever is the outcome of this parenthesis would then be used with this percentage to find the remainder, and then whatever is the remainder is going to be attached here. So if I execute the code, it says semicolon expected at line number 22. So this is 21, 22. This is not there. This one is here. Okay, so let me re-execute it and see what we get. Now we get the answer 5. Okay, why is there 5? Because 35 plus 5 becomes 40. Whatever is the answer here is then remainder is being calculated for that. Then 40 divided by 7 means we get, I think 40 divided by 7 is 5, right? And there is usually only 5 as a remainder is given. So we get the 5 answer. Perfect. Perfect. So that solves it. Okay. And I have a plus here. Why did not it add the answer for one this and then did the modulus? Again, if I use this, for example, if I use 7 here, plus 7, okay, in fact, control Z, oops, modulus, and let me just copy this code again, come back here, paste it, and then use plus here. Now tell me what will be the output of this code. Even though we are using parentheses, but we have a plus here and we have a plus here. And we just talked about that when we are attaching a string with any number, it's going to concatenate. What happens now? Will I get still the 5 answer? Meaning the plus is done here, and then 40 plus 5 means 45 I should get, right? So I should get a 45, or will I get 5, or I mean, how the answer is going to appear? This way. Why this way? Because we say plus 35 plus 5. Because these are inside the parentheses, so it has a higher precedence, so they become 40. Then this 40, because now it contains plus on the left hand side and plus on the right hand side, so it's going to start from the left, and this 40 is now concatenated with this string. So we get 40 plus 7 is now, hence 7 is going to be concatenated with the remaining part of the string. So the answer becomes 40 plus 7. Whereas here mod 7 is there. And these are typical questions that we ask people in interviews, in exams, especially whenever I have a questions in MCQs kind of a thing, that what would be output of this thing. And it looks very simple, but it's a very, very complex thing that we can do. Okay, it can be very tricky to understand exactly what's happening because plus all have equal precedence. So parenthesis has a highest precedence. So first parenthesis being solved, then it's being concatenated or joined with the string. Then whatever is the outcome of this whole expression is later on being joined here. But at this point, mod has a higher precedence. It's not because we have an expression here. It's because modulus has a higher precedence. Remember, parenthesis comes first, so it solves the parenthesis. Then it needs to make decision: do I need to perform modulus here, or should I perform plus here? Now the decision. So internally, it's automatically always gonna perform the modulus first because mod has a higher precedence as compared to plus. So in this case, this was solved completely first. Similar to this thing, this multiplication is done first. Understand? Perfect. So that's why if we use plus, we only get the 7 here. Okay, so answer becomes, for example, 407 here. For this guy, the answer becomes 5 here. So that's the major difference. Same thing here. If I go, the answer is 23. And if I put the answers down so that if I copy the code, I know exactly I don't have to run it and we get the answer. Okay, the answer here is actually 18 concatenated with this string. Finally, let's just go for the divide. And we say, all right, console dot right line bracket start bracket close inverted quotations, and I wrote the answer of now this expression. Control C is equals to, come here, add a plus because we need to join the string, control V. Now what's going to happen? If I need this expression to be solved as per your understanding from here, I think you should be able to answer that the first thing we need to do is we need to write this entire expression in brackets for it to solve, and then whatever is the answer of this expression would then be concatenated with the string. Second thing we could do is we could use this entire expression in a variable as well. So we can have, for example, a double value, and we can say ans answer 2 or answer 3 for third expression is equals to, and we do a control V, hit a semicolon. We could do this as well. What this will do is it will solve the entire expression and put it inside the answer, and then we can use the double variable here as well. We can easily do that, or in this case we can directly use this expression. This should not be a problem. But now how this expression is going to be evaluated? Because it has a multiplication, it has a division, it has a -4 value, it has a plus as well. Now what we're going to do, how we are going to solve this expression, or what should be solved first? So yes, as per previous thing, the operations of -4 and multiplication are going to be performed first. Okay, so this expression would basically be evaluated in a way that -4 multiplied by 6 would evaluate first because multiplication has a higher precedence. Second number, whatever is the outcome of this expression will then be divided by 11. So this will be executed second. Then whatever is the outcome of this expression will be added to this 14. Hence we get the final answer, which then will be concatenated with the string. So you think that you write a simple expression, but internally this is how a computer system is supposed to work. They automatically take the multiply and they say, hey, this is a higher precedence, and it will break it down and it will execute multiplication first. Then whatever is the answer is going to be divided and then plus. Okay, so let's just run this code. And this is what we get. The answer of 14 plus minus 4 multiplied by 6 divided by 11 is 12. Okay, so we get a 12 answer, which I hope is correct. I'm not actually double checking. I'm assuming since I'm using computer, they should be able to do this correctly, right? Okay, so now finally write line, inverted quotations, bracket marks, lex and another quotation, and we say answer of this big expression. Control C, and I paste it, is equals to, then again plus, and I paste it. Now what's going to happen? Again, since it is a complex expression that contains plus and everything, it needs to be properly evaluated. If you just execute it like this, you run the code, we get an error. Why we should get an error? Minus cannot be applied to operation of type string. Okay, so what it is doing is it said, hey, because you wrote it publicly and minus sign, I understood that this is plus 2, which can be joined with the string, then plus 5, 15 can be joined with the string, but there's a division. So naturally, it will multiply these two things together. Okay, so this multiplication will execute first. No matter how we rotate, this multiplication will execute first. Then it will, whatever is the outcome of this, 15 will be divided by that answer. So this is going to be division. Then whatever is the answer of this, it will hold in the memory and it will perform 7 mod 2. Then whatever is the answer of this will be minus by this thing. So at this point, it's going to create complications. That, hey, why minus? Because then we have a plus. So in terms of execution, plus will be executed first before minus sign. Just like multiplication is being done first, then the minus sign. Okay, so it's going to add this together, do this together, then finally in the end minus will be done. And in the end, because we have already concatenated everything, it's going to say, hey, I'm subtracting something from a string. Okay, so this cannot be applied. So minus cannot be applied on a string. Understand? I hope a little bit. If you need, again, I will let me explain one more second very quickly. In this way, multiplication is done first. Then whatever is the answer, division is first. Because they both are on the same line, multiply gets executed first, then divide, then modulus. Okay, so then we have a third answer for this. Then because now there's a plus and minus, the plus will get executed first. So plus means that will concatenate with this string, then with this string, then it's going to concatenate this whole expression with the minus value, and then this is where the problem occurs. Okay, so minus gets executed in the end. That is why in a proper way we need to first put this whole expression in brackets. Okay, that's why brackets are so important, and understanding the operator precedence and how they are working makes things a lot easy for you, that which expression is going to be evaluated first and what's going to happen. So this time we get an answer 3. I'm hoping that because I'm using the computer, it's giving me correct answer. I'm not doing the mathematics for myself. So this is how we solve when we try to understand, okay, how things are working, what expressions I can use and what not. Okay, so let me just come here, Control A, Control C, go back to my Word file, and this time I will just paste the code. Oops, let me just paste the code somewhere around here, Control V. Okay, so this means that we have solved the code program number 3 as well. Voila. So similarly, there are many other programs that I'm still working on, trying to create output and trying to find some programs from different websites. Trying to create a consolidated book that you can use to program and generate, practice and learn as much as you can. So hopefully by the end of this course, after the end of the day 4, I will be able to complete this, and I will share this module with you. Meanwhile, you have these 3-4 programs. Do work on it, and you can find many other programs from online. Again, ask ChatGPT; they can give you more good suggestions of programs that you can practice on. Okay, so I think that concludes this session. So let's move to user input. Let's now talk about User input. How do we get a user input? By user input means the user who is viewing your or running your code is able to give some data to the system or to your code, and you read that code, that what user has typed on your keyboard. Okay, so that's what basically means user input. So you already have learned about console.writeln, which is used to print the output on the screen. Now we're going to talk more about something called readline method inside the console class. Again, we have a write line which writes the output. Similar to that, we have something called read line which reads the user data. The user data means the user that can type from keyboard. So when your code is running, user is able to interact with it and allows us to give some data to it. So in the following example, the user can input his or her username, which is stored in a variable called username, and then we print the value of that username. So we have console dot write line, enter your name. Okay, so this basically means that at this point the console will wait for user to enter the data. Okay, so we say write line, we'll print the date. We go user string username console dot read line. Sorry, at here the console will wait for the user to enter the data using its keyboard. This is just simply printing a message. So if I run the code, see, enter username, which is this first string, and now there's a cursor here and it's blinking. It's waiting for user to enter the name. So for example, I enter my name as Dr. Zeeshan, and now if I press enter, username is Dr. Zeeshan. So it's going to reprint that data. How we did it? We use a simple method called console.readline, which reads the data, and then whenever we read the data, it saves that data back inside a username. Okay, this is a variable. Because the data we entered in the form of string, it's saving it in a string variable. Once we do that, we can now use this string variable to process and work with this data as we like. So this is called taking a user input from the system. Okay, so user input numbers. If you want to have a specific input as a number, the console.readline method always basically returns a string. So no matter, even if you run the code again, okay, and I think if I refresh, we come here, and if I am 23, press enter, it prints 23, but this 23 is again string. This 23 is considered as a string, so it by default reads a string. Therefore, you cannot get information from another data type such as integer. The following program will cause an error, meaning console.writeln, enter your age, and if I write console.readline and I store that answer in an integer variable type, this is going to generate an error because it says, hey, I'm reading a string and you want me to store in an integer. That's not allowed. And remember the casting issue we talked about earlier. String has a larger memory size. Okay, so it cannot be stored in a smaller memory size. Second, string is saving characters, multiple characters. So how to use those multiple characters to store integer numbers? So like error message says, you cannot implicitly convert type string to integer. So luckily, you learned that from previous chapter that we convert explicitly by using convert to methods. Okay, so we talked about this in typecasting already. So instead of implicitly casting everything automatically, we now need to use a method called convert to integer 32. So what this is going to do now is when we enter this number, it's going to convert that into number 23. So we just talked about this in previous session. So integer age now will hold the number that we entered on our console. So if you execute this code and I write again 23, press enter, your age is 23. Now it's going to work and there's no problem with that. Okay. So do always remember that. So we read the data using read line method again on console, but by default, every time you enter the data on the console, it's going to consider it as an integer number, as a string number. If you need a user to enter an integer number and you want to process it as an integer, you must then convert it using a method called convert to integer 32, means 32 bits. Okay, so it's going to convert this given number into an integer 32 bits and save it in the integer variable. Then you can safely use that integer number for future programs. Understand? Wonderful. Let's move on further and talk about something called operators now. Now, operators are used to perform operations on various variables and values. An example below, we use plus operator to add two values. So integer x, again we created an integer variable. We said 100 plus 550, meaning that this is an expression that adds two numbers together. Here the plus is known as an operator, and we have been using it lightly in previous examples as well. So although the plus operator is often used to add together two values, like an example, It can also be used to add together variables and values. So you can say that I have sum 1, it contains 10 plus 50, so this would also fine. But I can also take this variable and add it to this 250 value. Now, because this variable is of type integer, I'm allowed to do that. I'm allowed to add an integer variable that holds a particular value with another integer number. That's the main reason. So that's a logic you need to understand. This is working because this is a variable of type integer, and the variable is a container. It holds and points to a data in the memory. So when you use a variable, you're actually using the data that's stored in a memory. You're referring to that data. So it's going to read that data and add it with 250. So that's why we are allowed to use variables in an expressions. You can use both these expressions, again works fine. So I can take sum 1 plus sum 2, or sum 2 plus sum 2, or any other value you can add, no problem with that. Okay, so this is again plus, minus, multiply, divides, various operators that we already are quite aware of. Modulus is again commonly used in operator in programming that actually is used to return a remainder. Okay, so whenever we do or divide certain number, for example, if you come here, I created using system, we use namespace my application, I go class program. Okay, a standard code that almost every time we need to write. Do remember, because I'm using W3Schools website, program is a default class that they use. However, when we are creating our own class, we always change this class to some other, and my application becomes my package name. We will be doing some more custom programs later on when we go into more deep programming using if, else, and for. So I'll show you what we mean by that. So now we have integer x is equals to 5, integer y is equals to 2, console.write ln x mod 2. We get one answer. This basic mod basically means that it returns a remainder. So if I divide x by y, I don't need the answer, I need the remainder. So x divided by y is 2 divided by 5, so 2 2s are 4, so that's gone, and 1 is remainder, so it's printing 1 here. Certain situations it's quite useful though. Then we have something called increment operator and decrement operator, and these are wonderful operators. They basically behave like simple addition, add 1 to a current value. Okay, the way it works is that I have integer x is equals to 5, I do x plus plus. When I print it, I get 6. Why? Because this x plus plus actually is read in this way. So we say x is equals to x plus 1. This is the actual representation of it. So this means that take the current value of x, add 1 to it, and whatever is the answer, assign it back to x. So override the value of x now with this new addition value. So current value of x is 5, add 1 to it becomes 6. So now the 6 new answer, assign it back to the variable x. Hence the value of x now becomes 6. In a shorthand, we just write plus plus. And this is very, very commonly used, especially within the loops. Plus plus operator is very, very commonly used. So we need to do one increment. To do that one increment, we just use plus plus. It's like a shorthand operator. Instead of writing this whole expression, we just do x plus plus. And similarly goes for x minus minus. It will do one subtraction. It will minus 1 from the current value of x and update the value of x. So these are basic arithmetic operators, as we call them. Then we have something called assignment operators. Again, we have used this equal to operator multiple times, so no need to brag about that. We have other operators as well. Okay, so let's explore them a lot. Is equal to, again we have done it, it's used to assign a value to a particular variable. Then we have plus equals to. Plus equals to is considered as doing again a shorthand operation. It behaves like this. So it says if you use plus equal to like this, x plus equal to 3, what this expression means is take the current value of x, add 3 to it, and then assign it back to the value of x. So similar to plus plus operator, where plus plus always done one increment, now we can specify, hey, I want to do a 3 increment or 2's increment. So add 2 every time something happens, the program loops around, or just give me even numbers or anything of the odd numbers for that matter. Okay, so we use plus equal to for that purpose. So we say plus equal to, minus equal to, multiply equal to, divide equal to, remainder equal to. All these operators basically behave in an exactly same manner depending on which arithmetic sign you are using. So x divide equal to 3 means take the current value of x divided with 3. Whatever is the answer, assign it back to x. Okay, this becomes x3. So this can be 3, this can be 4, this can be 5, this can be 6, depending on what number you're using, what logic you're developing. These operators are quite commonly used. My personal preference is always using these expressions. I tend to use this. It just gives me a clear vibe what exactly I'm trying to do, unless x plus plus. It's just clear there. But again, this is considered sometimes as a shorthand operators. They simplify things, and you can simply understand if you want to work with that, what exactly you want to do. But for me, the understanding is more clear this way, just old school approach. Anyway, then we have something called and equal to, or equal to, nor equal to, and then double shift equal to, and left shift equal to. Okay, these are other operators that we use for certain purposes within coding. Then we come into comparison operators. We have comparison operators are used to compare two values or variables. This is important in programming because it helps us to find the answer and make decisions. Now, these operators are the key operators that allow us to develop the logic in programming. Remember the way we initially defined programming, that what is a programming language? We mean it's a language that has logic and decision making probabilities. Okay, it has data on which it operates and makes a decision. So that decision, one part of that decision comes from these comparison operators. So because of these comparison operators, a programming language becomes a programming language because it is now able to make a decision using these operators. Without this, it won't be able to do that. So the return value of comparison is usually either true or false, and there is no other answer to it. Whenever we use a comparison operator, the answer we get is always in form of true or false. These values are known as Boolean values. Okay, remember we talked about Boolean in data types as well, and in variables. And at that time, I told you that Boolean play a very important role. So whenever we do a comparison, the answer in the memory which is saved is in always form of Boolean. And then there are operators like if else, switch, loops. They require this Boolean true and false value to properly make a decision and properly evaluate the expression. So that's why their basically existence is quite important. What type of comparison operators we have? We do, for example, one of them is greater than. What it will do is we can use integer x is equals to 5. We have integer y is equals to 3. We say, listen, go to console.writeln and print me this expression. So this is now a comparison expression. Okay, so now we are evaluating a condition. Is the value of x bigger than the value of y? So we are now evaluating an expression, meaning is the value of x bigger than the value of y? This is a greater than operator. If this is value is bigger than y, it returns true to us. If the value is smaller, for example, if I make it 13, run the code again, now it will generate false for us because now the value of x is actually less and y is bigger. So this condition becomes false and it becomes false in output as well. We have basically 6 main type of conditional operators. Something called equal to, which compares the value equal to, meaning is the value of x equal to value of y. Then we have something called not equal to, again inverse of equal to. These two are not equal to each other. Then we have something called greater than, less than, greater than equal to, and less than equal to. These are various different things that allow us to evaluate certain different conditions. In this case, we say integer x is equals to 5, integer y is equals to 3, print whether x is greater than and equal to y. What does this basically mean? So if I just use equal to here, okay, if I come here and remove and I say x is greater than, okay, and then what if I use both values as 5? If I run this code, what should happen now? X is greater than 5, x is 5, y is 5, they both become equal. But if you use greater than, now the condition says false, because as per the condition, the value of x is bigger than y. Hence, that is not true. They are equal. So we return false here. What happens if I use less than here? So that means that if it is not bigger, it should be less than. So now if I use that, hey, is the value of x less than y? It says false. So in both situations, we got the false value. How did that happen? Because the value is actually equal to each other. So if I use the equal to operator now I will get a true value. Okay. Why true value? Because now we are comparing these two directly. That is the value of x equal to the value of y. Makes sense. So in certain situations, when we want to check the value with respect to greater, I want the value to be bigger and equal to. So that is why we use this operator. So now if I run this code, now it means that the value of x is bigger and equal to. So it needs to be bigger or it can be equal to. One of these options has to be true. So if one of these options is true, it becomes true. So since there is 5, 5 means it is not bigger but actually equal to. So this combines two comparison operators. So when we use greater than with single quotation of single equal to sign, they basically are combining these two things together. So now it means greater than or equal to. So it's combining them in these two things. Okay. So these are relational. We also call them relational operators, comparison operators. They compare the relation between two variables. That's how we say it. Okay. So different languages, different people, different tutorials refer to them in a different terminologies. W3Schools is basically referring to them as comparison operators. In Java, usually we refer to them as a relational operators or logical operators. Okay. Relational because they actually evaluate a relation between two variables, whether they are equal to each other, not equal to each other, greater than, less than, and so on and so forth. We very rarely use this in this scenario like this. We actually use these relational operators with if, else, switch, while loops. So you're going to see a lot of use within these statements. So that's why there's not much talk here. Okay, so don't worry about that because this is the key important part. You just need to know about these operator symbols at this moment. Then by the time we reach this chapters, you're now going to see, okay, this is how we're going to use it. And I will be doing some multiple real world examples and doing some extra coding other than W3Schools so that you can understand exactly how we use that. Finally, before moving to further, we have something called logical operators. Now, logical operators allows us to evaluate two different relations and make a decision based on that. So as a comparison operators, you can also test true, true or false, false values with a logical operator. So logical operators are used to determine the logic between variables and values. So in general, we say using these logical operators and, or, and logical not, we are able to evaluate two different expressions. If you just use these comparison operators here, they always evaluate variables. So this is one expression. X is greater than Y, one expression, one condition. But at certain times, we need to find a range of expressions, starting point and an ending point. Okay. When we need that, then we need to use AND operators to evaluate two different expressions. So for example, in this case, X is greater than 3 and X is less than 10. So now we're evaluating a range that I want this value of X to be bigger than 3, but at the same time I want this value to be less than 10 as well. So now here what's happening is we are evaluating two expressions, X is greater than 3 and X is less than 10. Only then this condition would become true. Understand? Similarly, OR would again mean the same thing, X is less than 5 or X is less than 4. Okay, so it's evaluating two different expressions. The main difference, again, not is very clear. We just do the inverse of it. It's usually written in front. It reverses the results and returns false if it is true, and if it's true, it will. If it's false, it will return true, or true, it will return false. Okay, it will just reverse the output. But the main difference we're going to talk about this and an OR operator, as I say, in Booleans, in if else, and switch statements. Okay. But before I go further, let me do a little bit more expression. I believe it's not justified if I just leave it to this point. So when we talk about AND operators, we have something called a truth table. And TRU truth table. This is an old school approach that we define. What this truth table means that if your expression 1 and expression 2, then what is the output? So for example, if your first expression is true and second expression is also true, it will be what we call true. So in this case, it needs to make sure that the first expression and the second expression both are true. By this we mean that the value of X is 5. So the X is bigger than 3, greater than 3, this condition becomes true, and X is less than 10 and the value is less than 10. only in that condition the complete answer becomes true. So it's evaluating left hand side with right hand side. Once left hand side and right hand side return true and true, only then it will say, ah, it's true. If either one of them is false, okay, then it will say, listen, if first one is false but this is true, it will still say I'm false. Okay, because for example in this case the value is 2. Now x is greater than 3, this condition becomes false. And x is less than 10, this is true because x is 2, it's less than 10, so this makes sense, so this is true. But we are looking for a number that's explicitly between 3 and 10, right? So this condition becomes false because x is 2. So because the first expression returned false, the answer for this entirety would be false for us. Similarly, if the first one returned true, okay, and the second expression returned false, again it will say I'm false, because and needs both of them to be true. So the both have to be true, otherwise if any one of them become false, it's not going to work. So if I just put this in a multi-line comment so that we don't have a problem for this, Control C and run this code, we should see false. Why? Because x is 2 and I'm checking x is greater than 3, this condition becomes false, and x is less than 10, but this is true. But because of this AND operator, it AND will ensure that I need both these sides, left and right side expressions, to be true. Unless any one of is false, I don't buy your thing. Okay, so if both are false, you can imagine, then it's clearly false. So the AND will always return false if any one of them are false. It needs AND to be true. At the same time, if I use what we call console.login, Control C, oops, let me just delete that, and use an OR operator here, double pipe sign. Okay, now what happens? Now the truth table of OR is completely different. From the word itself, the OR truth table is something like this. So if I use double pipe here, if first one is true, second one is true, it becomes true naturally. Okay, we said okay, no problem. If first one is false, the second is true, this will make it true. Because we are using the word OR, it means or x is greater than 3 or x is less than 10. So either one of this condition is satisfied, I will agree with you. So if you run the code, the first one is false because we are using AND operator and AND needs both of them to be true. The value is 2 here. But once you change the symbol to OR, now the expression becomes true. So it depends exactly clearly what you want to do, because this is, as I said, this is where the logic comes into play. So that's why they are known as logical operators or logical comparison operators. Okay, so then OR needs at least one to be true. If any one of them is true, left or right, it will make it true. So for OR, true, 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 we have true conditions 3 times, because it says either both of them are true, I will consider them true humbly. If left side is true and the right is false, I will consider it true. If right is false and left is true, I will consider it false, true as well. Only in a condition where both the conditions are false, then I will say, now I don't like it, make it false. Okay, so for OR to be a false, it needs both sides to be false. Otherwise, if any one of them is true, this is going to go true. For AND, you need both to be true, only then it would work, otherwise it's going to go false. So that's the key difference between the logical AND operator and logical OR operator. More about this in if-else statement. Okay, so now let's talk a little bit about this math class. Before we go further, if you still haven't subscribed this channel and here for the first time or watching this video again but not subscribed, please do leave a comment and don't forget to like this video. This helps and encourages a lot and motivates us to make more videos regularly. So now, without further ado, let's learn what C# math class does for us. Now, C# math class. What do we exactly mean by C# math class? Well, a math class is like a utility class. It's like a library that again has been pre-built by the good people of C# and .NET at the Microsoft. And what this class contains is certain mathematical functions that you use within your code almost most regularly. Okay, so knowing about this class is quite useful. Similar to C Meta, there are many other library files as well that we would be using time to time, and sometimes we need to explore to do a particular task what library file exists. Okay, so this is considered as one of the library files, math, and it has mathematical functions that we use and they perform a specific task. Functions like cosine, sine, theta, tangent theta, maximum, minimum values, random values, xyz, xyz. Okay, so C# math class has many methods that allows you to perform mathematical tasks on various different numbers. Math class such as math.max takes two arguments x and y. Okay, so now this becomes the syntax. So we use math, which is a class name, and this class contains a method called .max, similar to console and other methods we have been using. So basically, we access this math class and we say inside the math class, we have a math maximum method. This method syntax is that it takes two arguments and then it will determine which number is the maximum amongst it. So if I use them, you see we'll have this code. If I just zoom into this guy a little bit so we can see it better. So we say use system, using system, namespace, my application, class program, and then console.writeln maximum method. What this does is now that it determines that amongst this 5 and 10, which number is the bigger number. Sometimes we need to find out that when the user enters a value, which number is bigger and small. So we use a mathematical function called max inside a math class and we process it. You can use it in a similar manner. So for example, I can say integer bigger number is equals to, and I can use math.max and I can say, listen, find out which number is bigger from 42 to 89. Okay, semicolon. Now, why did we give this two arguments? Because the function syntax defines it that, hey, listen, this takes two arguments and then it will determine which number is the maximum. And this method automatically does that. Again, we can write our own code to do that, but this method automatically does that. Then it says this method exists in the math class. So what's the basic second logic is that when we execute this method, it's going to find out which number is bigger and then it's going to return a value. Okay, so whenever we do a programming, you have to keep in mind that there are certain methods that will just perform a certain task. For example, console.writeln. Console.writeln is a method that prints something on the console. That's it. Gone. In this case, math.max is a method that performs finds out which number is bigger, performs a calculation, and then returns a reply. So we need to receive that reply as well. Okay, so that's why here I have written integer, bigger number. This number now becomes a variable which will have this value or with this number which is bigger from here. Similarly, we have used here in console.println. Okay, writeln. This writeln method will actually receive. So whatever answer is replied from here will be received by writeln method directly in their brackets and will be printed on the console. So there are two ways of doing it. One, you receive an answer in a variable and then use that variable to print it or do any operation on it. Second, sometimes just to test a code, we can directly print that method value inside our code. Okay, such as another method. So writeln is a method and we are passing it as an argument, another method. So this method will perform its task, return a value that will again be read by writeln and print on the console. Okay, so don't confuse with that. So this is again pretty legitimate, meaning that we are using a method inside another method as an argument. Now, so similarly, there are many other methods that perform the functions within our C# class. So we have math.minimum, where what math.minimum does, again, the name is quite evident. It finds out the minimum value amongst the two values that they pass. Then you can use math.sqrt. It finds out the square root of a given number. Okay, so whatever number you find, if you want to find out the square root, you basically use this method. So in our case, for example, we come back here and I said, okay, let's just use console dot write line, and then we provide again same thing, math class, and I want to write sqrt bracket start bracket close and then bracket close and then semicolon. What this defines, now when the number, so for example, if I write 49, run this code, is going to go inside the math class, find out this method sqrt and tries to do the mathematical calculation for that, and we got an error, system.math does not contain a definition for sqrt. What happened? Capital SC. So we have a capital S in the method and I apparently use the small s. So this is again, be very careful with respect to errors. If you write a code, sometimes it's a common thing we mistakes. So make sure you read the error description. When you do that, It says that the system does not contain sqrt, means there's something wrong with the sqrt function that I've used. So I come back to my code, I check, sqrt, I've done it. It should be the same, spelling should be okay, but then check the resources. That's why we love W3Schools, because it has all the resources available. On this website, you can say, S is capital, and in my code, actually, I wrote S as a small one. Okay, so make sure that you use that. So in coming here, I change this to capital S, and now I run the code, and here we go. So we have a value printed on the screen. Okay, 7 is the sqrt, and then you can use it, for example, something like that. The squr square root of number 7 is something like that. Okay, and then you can say, listen, I want this to be printed, and then we add a plus sign. So means this becomes a string plus the answer that is returned by this math.sqrt. So if you run the code again, now what it's going to do is it's going to attach this string with the answer of this. So now the square root of number 7 is, oh sorry, 7 no 49, right? So for example, if you give it 49, so it will say the number 49 is 7, or whatever you want. So you can use this in a way. So I'm just trying to explain that you have a method, and you can use a method with a string inside another method. So remember, right, ln is a method, and inside the method we have a string which is concatenating or joining to a reply that is returned by another method. So math.sqrt is a function, is a method that performs the square root, and whatever is the answer that is returned by it will then be added to this string, which then is collectively printed on our console using this another method. It's like nesting one thing into another. Then similarly, we have many other functions. Okay, so we have math.absolute values, finding the absolute value of a number. Math.round will basically rounds up to the nearest whole number. Quite self-explanatory, these things. And there are few other methods that exist within our math class. So if you go into the documentation and read the documentation and go into details of this, I think there is a reference here somewhere where we have the whole details of various different methods that we can use in from our math class. Okay, or I will point you to the right documentation. So there are many other things that we can do with the math class. Understand? So this is how, in other words, we use math and some functions to perform operations on data. Similarly, moving forward, we have something called string. Now, string is quite amazing. String has many uses within C# and in general. Okay? So strings are used for storing text. That's a plain simple thing. Anything you write within inverted quotation marks is basically considered as a string. Double inverted quotation marks having multiple number of text. Even numbers would consider string if you write it inside the double quotation marks. String variable contains a collection of characters surrounded by a double quotes. So do always keep in mind that. Creating a variable of type string and assign it a value. So here we create s with a small s string, and we create a variable is equals to hello world. This becomes my string. A string variable can contain many words if you want. So we can have nice to meet you, meaning that string, we create a variable's greetings, and we use this as a. Okay, so if I execute this code, and let me just kill all other things. I think we should already done that. Bum 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 bum. Just simplify the code here, and execute this thing. So now we have various different strings available to us. So we say, hey, string hello, and we say string 2, nice to meet you. So this again is completely valid. And then we can come here and say console.writeln greetings. So it's going to print whatever string we have written here. It's going to be printed. And then we can write console.writeln greeting 2. It's going to print nice to meet you. We can even say, for example, console.writ, right line, and we can say print the greeting hello, and then do a plus and say please subscribe. Okay, and close this. So now what we're doing is we're taking one string which is hello, and then we add the plus because this is already a string. So whenever we use a string at any of the left or right hand side of the arithmetic operator plus, it behaves like a concatenation or joining operator. It's going to join the output of this string with the option of this script. Please subscribe. So if we run the code now, it's going to say hello, please subscribe. Hello, please subscribe. Do that if you're up till here. Okay, so this is how strings basically simply work. Now there are various different methods that are inherently built within the string. Okay, let me explain. String in C# is actually an object. Okay, we have not talked extensively about objects at this moment up till this point, because we will go and do in this later chapters. But string in a C sharp is actually an object which contains properties and methods that can perform certain operations on a string. Meaning that when you create a string, by default, this string behaves like an object. And this object now internally already has multiple methods that you can use directly without any other thing. When we created this string, okay, greeting, now this greeting is considered as a string object. We refer it to as a string object. By an object, meaning that because this is an object, it is not just containing this text here. It contains information on various different methods of a string that can be used on this thing as well. By creating an object, you're not only creating data type, but you're also associating various different methods that you can use on this one. So it's a double package that you get. Okay, this is what the object-oriented language teaches us. So a string internally actually is what we call an object. So for example, the length of a string can be found using the length property. Okay, so now when we write this code here, we come back this one. Let's try this one out. Let's see what's happening here. So we say, okay, we created a string a, b, c, d, e, f, g, up to z, and then we use something called console.writeLn. The length of a string is, again, we write a string here, plus, then we say text.length. Now what we did here is, we created this text variable of a string type. We gave it a some number of string. Said, okay, perfect. Then we used text variable dot length as a method for this string class. We have not declared it, we have not defined it, and do keep note that there is no round brackets around it as well. Okay, because this is a built-in method and with capital L, this method is built in because text internally is now handled as an object, and because this is an object, there is a string class that has been defined by the system internally. So there's a class such as this class already existing that contains our string class, and that class contains various different methods. So whenever you declare a string object, it becomes part of that string, and hence it's able to use methods inside it. Okay, so it automatically inherits all the methods of that string class. One of those methods is length. This length specifically is without brackets, and what it will do, it will tell you count the number of characters. So this is what key thing about strings we need to understand. There are various other methods that we can use. So there are many string methods available. For example, to upper, to lower, which returns a copy of the string converted to uppercase or lowercase. So we can use string text hello world, and we can say to uppercase, it will convert the entire string into uppercase, or we can say console.lowercase, and it's going to convert entire string into a lowercase. Understand? Simple as that. So this becomes methods. So there are multiple different methods that we can use with strings that allows us to operate on it and perform multiple different functions. Okay, let's move on to C# Booleans now. What do we mean by Booleans? Well, very simply, C# Booleans are very often in programming. You will use this on data types, especially on if, else, switch, while loop conditions. These Booleans refer to, simply speaking, true and false. Some programming tell it yes or no, on or off, but in general, mostly we refer it to as true and false. So C# Boolean is a data type bool which can take either true or false, as simple as that. It can take either true or false. Only these two values, no other options are available. Booleans internally are represented with one bit of value. So it occupies only one bit when we declare this in a memory, and that one bit basically will only have either true value or false value. True internally is represented as 1 and false is represented as 0. That's why one bit, we know in memory, can only contain 1 or 0. So if it's 1 means it's true, it means 1. If it's false means it's 0, or it's 0 it means false. It's reciprocal. So a Boolean value is declared with a bool keyword and can only take either true or false. Whenever we declare a variable with a bool, is C# fun is equals to true. Now we declare a variable, and this variable is holding a value called true, and this Boolean variable is holding a value called false. So this is a data type that's basically doing exactly the same thing. Why we exactly need this Boolean when we only need true and false and we can write it directly? Because internally memory needs to understand what is a true value, what is a false value, how to handle this true value, true and false expressions. Because this true and false is used in our various different evaluation purpose. So for example, whenever we write a conditional expression such as x is greater than y, okay, so when we write it, the answer is either true or false, but that answer needs to be saved in a memory. and then memory needs to know that what type of data I am saving. So that is why we use Boolean. So we tell the memory that, hey, listen, this answer is either true or answer is false based on the expression, and this true and false is of type Boolean. Only then the memory will be able to store one bit and save that answer inside the one bit. In memory, the word true is not saved in terms of its text form. Okay, the word true in a string form is not saved. It's always saved in either one value, and false is saved as a zero value. That's it. So that's why it only occupies one bit in memory. So memory only will save 0 or 1. In general, whenever we process this data through a programming, our C sharp will return either true and false. It will automatically convert 1 into 0, 1 into true, and 0 into false. So because of the memory, we need to use this Boolean data type. Okay, and for example, when we write 10 is greater than 9, this returns true because 10 is greater than 9. We can use this comparison directly, but inside the memory, it again needs to know which type of data this is, because the true value will be saved in memory first before it is sent for an output. And when it is still sent for an output, means that the system needs to know that what type of data I'm sending to the particular console. So that's why it will consider this as a Boolean data type inside our memory. Okay, this Boolean, and it's written through every expression. So every expression that we write, Boolean expression, every conditional operator that we use, every logical operator we use will return this Boolean data type. Okay, so this, we talked about this operators here in terms of comparison operators. So every type of comparison operator that you use here, all of them will always return Boolean values. This greater, equal to, not equal to, greater than, less than, greater than, equal to, not equal to, all of these comparison operators will always return true or false, and that true and false needs to be handled by this Boolean data type. Okay, so no matter which expression you use, the answer is always in form of true and false. Okay, so whether you use equal to, not equal to, and so on and so forth. So for example, we create a real world example. We use system. Using system, again, this is the first line of code that we need to write every single time. Because we are using W3Schools, the basic code is automatically written for you. But remember, if you are creating your own custom code, the first line we write is using system with a capital S. Then we provide it a namespace, block start, block close. This namespace defines like a project folder, like a package that which your code can belong to. So a package can have a multiple classes that belong to a same application. So for example, if you're building a single software, you have that package for that software, and all multiple classes and data belong to that one single software name. Understand? So we create that namespace here. Then we create a class. By default, every W3 School example creates the class with the program, and it saves it with the program so that it can run it. But if you're creating your own custom code, you basically will use anything. So for example, if I have this code, and if I use, for example, VS Code Online Editor, or you can use VS Code from your own system. Let me create a new file. Oops, this one, sorry. Let's just create a new file and create a text file, Control V. So now I have this code here. Okay, so even if I'm using, I will still be using system. Using system, this is basically allowing, or like it's in importing the package. Then my application I can change to, for example, Dr. Zeeshan CS. So that means that all of my code will now have this particular project representation. So then I will create class, and I can change the program name to, for example, what should I name? Okay, bool type. Okay, so this class becomes my bool type. So when I save this code, Control S, I go here and I will save this as bool. Usually it's always recommended to use the same name as the class name. So whatever name you've written here as a class, use the same as a class. .cs extension is there, and we save the code. Okay, so you can change the class name to whatever class name you want. Usually we define the class name which reflects the purpose of your code. So in this case, for example, I'm just going for Boolean type explanations. So I've written it a Boolean type. Namespace, we usually give it a project name. Technically, if I'm working, or for example, in this case, if I'll create 10 different examples, I will keep the namespace same for all of them. So they are in one single folder, they belong to one single namespace, makes things a lot easier. Okay, and then class name representing the function of a class. Then we do integer age is equals to 25, integer voting age is equals to 18. We say control dot write ln, my age is greater than voting age. Okay, now we are using a Boolean expression to evaluate a certain condition. If returns true, meaning your age is greater than you're 25 years old, it will return true for us. because age is 25, and it's going to check, hey, is my age, the variable that we are using here, has 25 value. So this 25 value will be represented here is greater than the voting age, which is actually 18. Okay, and then if that is the case, it's going to return true for us. So this becomes a Boolean expression that we tend to use. Okay, so this is what exactly this is trying to do. So we use such kind of Boolean expressions to determine certain condition. If the condition is true, it needs to do something. If the condition is false, it needs to do something else. And this is more reflected primarily in developing the proper logic, which we call decision making. Okay, so here's what a decision making looks like. So we can come here and try your self code. And now again, we are using namespace. Again, if I'm going to write it myself, so I, for example, come here, I create a new file. I can say, listen, I want a new file, new text file. Okay, and then I'm going to say using sys system, making sure I write this code every single time. Then I'm going to say, listen, this is because this is what exactly it's doing. So you can copy paste it, or usually that's why we sometimes ignore it. But this is what every code needs to have. Then we say namespace, and we provided a particular namespace. So I'm going to use the same thing. So I'm going to say namespace, and then I'm going to say my namespace. Okay, so now this means that both of my code basically belong to the same namespace. Okay, then we start with a block, end with a block. So this namespace means that this entire code can belong to a one single namespace. Also meaning that you can write multiple namespaces or have this multiple blocks of code in a single file. Not recommended though, but you can use that. For example, now let's create a class age, or in fact we can say voting age. Okay, block start, block close. Again, block represents a set of code, number of lines of instructions, number of lines of code. So, or generally we say block of code. So this bracket start bracket represents a block, meaning that whatever we write inside this block now belongs to this particular block. Okay, so we said class voting age becomes my voting age. Now we write static, we say void, and we write main, and then we use string argument square brackets, again block start, block close. So this is a method just like this one. We public static void main string arguments. We wrote the same thing here. Okay, this is again a variable name arguments belonging to an array of a type string. We have not discussed arrays yet, so don't worry about that. Declaring a main method is essential because this will tell that when I run this code, the first line of point of executing the code starts from the main method. And this is like a default thing. So that's why we use main. Void again means that this, when it executes, it will not return anything, will not give us a reply. And static is because I can use this method without creating an object of this voting class. Once we do that, control that. Now we say, okay, what we were talking about? Yes, integer age. So we were trying to do this thing. So let me copy this code, and let's be a little bit lazy and come back here. That better. Okay, so now what we said, integer age is equals to 25. Okay, integer voting age is equals to 18. We use the same variable, and we use something called if my age is greater than voting age. This is what we say. Now this is a comparison expression, but this comparison expression is provided passed to something called if. This if will evaluate if the condition is true. If this expression returns true to me, it will make a decision to execute this line of code. Okay, and the rest is completely ignored. However, if the decision is false, if my age is, for example, 5 years, so now the condition is my age is greater than equal to voting age. Am I elder than 18? Because I'm 5, it returns false. Because it returns false, this line of code is ignored, and the control of if goes to this else. And now only this line of code is executed. This is what we call decision making, and this is now we're going to understand a little bit more in depth of how this if else is working. Before I go, if you want to work on this, you need to save this code with the same class name. So again, I press Control S, come back here, and I'm going to say voting age.cs. So making sure everything is saved as .cs extension for the JavaScript C# file, and we give it the class name, that name of we have written here. You can give a different name, but it's always recommended to use the same name. And then you save this code and you execute it. This is an online VS Code editor. Actually does not support what we call C# online. So if you want to use that extension, come here and just type in C#. Oops, C#. install a VS Code on your systems and you will get the C# development kit. You need to install that. Because I'm using an online editor, it says it's not supported for that, apparently, unfortunately. But that means we cannot execute the C# code on this editor. However, hopefully in future they would be able to do that. So if you are using VS Code on your systems for testing, just install this extensions, install this extension, and download .NET on Windows. Should not be a problem. Okay. So let's talk more about this if-else things now and understand how this logic is working. All right. So this was C# math class, string, and booleans. Okay. So without further ado, let's begin and learn if-else statements and how we use if-else logic within our code. So if-else, what do we mean by if-else statements, or in generally known as conditional statements? Now this is where the main decision making of a programming language comes in. Using C#'s if-else statements, we are able to make a decision. By decision means that in a general decision, we say if something is okay, what should we do? And if it's not okay, then what should we do? If you have an interest in this area, what should you do? If you don't have interest in this area, what should you do? You know, making a decision based on a certain situations. So this is where if-else statements come into play. They allow us to make a decision based on a condition. Okay, so that's why they are known as conditional statements or conditional if-else statements. So how do we generate a condition? We use exactly the same conditional operators that we discussed earlier. So when we talked about the operators, we discussed these relational operators or conditional operators. Less than, equal to, greater than, equal to, not equal to. These are known as conditional operators. We use them with if statements to generate a condition, and based on this condition, a decision is made what to do. Okay, and this is where the real programming decision making inside the programming comes into play. So you can use these conditions to perform different actions for different decisions. C# has the following conditional statements. If statement to specify a block of code to be executed if a specified condition is true. So when a specific condition becomes true, then this if block is executed. Then we have something called else statement. This is used to specify a block of code to be executed if the same condition is false. So usually else does not work independently. Else always works with if. If, however, can work independently. So we can have individual if statement, or we can have if and else statement. So they do work together, which means that if this one is true, executed, else execute something else. So this is like two-way binary decision that comes into play. Then we third type have else if. So again, else if doesn't exist independently. It exists with the if statement. We write the if statement, and instead of just writing else, we write else, and then we nest if inside it. So it means that if first condition is true, fantastic. Else, check second condition. Okay, so it's like a nested else if structure. Then third type is switch statement. Okay, switch statement is an alternative block of code that is used to check certain conditions. Okay, so let's explore the if statement a little bit more in detail, and then we'll talk about all of these as we go along. The use of if statement to specify a block of C# code to be executed if a condition is true. So if this is if, we write if with again if. It's a keyword, it's a reserved word. You cannot use if as a variable name or as a method name or as a class name. It's a keyword reserved by C# itself. Then here's the magic. We write a condition here. What conditions we write are based on these operators. Tuck, 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 tuck. All of these 6 operators are basically now conventionally used here. If technically only requires true and false. If, again, technically, if has a block around brackets. Within this, it needs true or false. If the condition or if this value is true, it will execute the block of code. If this is false, this block is completely ignored and not executed at all. This is how if works. So we say we need either true and false, and in order to get that Boolean value true and false, we need a condition. So only these conditions are able to generate true and false values. Arithmetic operations, for example, only generate values. 5 plus 5, 10. 10 is a value, not a true and false condition. So we need a Boolean value for that. That Boolean value can only be obtained through a certain conditional operators, these ones. So that is why most commonly we write condition here, means that we need to write these conditions. So now the logic is very simple. We write an if condition wherever we need to check a certain condition has been satisfied. If that condition has been satisfied, the answer is true in form of a Boolean value, then this block of code will execute. If the answer is false, then this code is completely ignored and nothing happens. That's where the decision making power comes into play. So note that if is a lowercase letters, upper letters if or if will generate an error. Okay, so do keep that in mind. In the example below, we test two values to find out if 20 is greater than 18. If the condition is true, print something. So we say if 20 greater than 18, is this condition true or not? So again, we need relational operators here, or conditional operators which evaluate a particular relation or check a condition. So 20 greater than 18, if this is true, print this statement, 20 is greater than 18. But what happens if I say 118 or 128, for example? Now 20 greater than 18, it becomes false, right? So because this becomes false, this statement here is completely ignored. Now this is no longer executed. So if I run the code, you should not see any output. That's the beauty of decision making. So we make a decision and we say, is this greater than or less than? If this is true, you need to do this. For example, if your password is match, log into the system. If password does not match, redirect and ask them, hey, password was not matched. So that's a decision making statement. Okay, so this is what we do. So since see no output here because the condition is false, this line of code is completely ignored. Again, this is a relational operator. We can write true here as well. Since true is a data type, it has a value. We can write true directly here, because if technically only requires true, and if you run the code, it will print this value because it doesn't need a condition. It needs actually a Boolean value. That's a one common misconception many young developers starts to have. They think that this is a conditional statement and always a conditional statement needs to be here. That is not correct. I can write a method that can throw either true or false, and I can execute a method here as well which can generate a return in a form of true and false value. Okay, we can talk about this in methods later on, but meaning that actually if only needs true and false. So if I write true here, this works. I can write false here as well. So if I come back inside my code here and I say, I don't like this, what if I write false? So this means every time it executes, this is considered as false and this won't be executed. Khalas. Understand? Why? Because if require Boolean value, if becomes true, execute it, false, ignore it. But how to obtain this value logically? To obtain this value logically, we always need a relational or conditional value. Okay, so that is why we always use a relational operator here to evaluate a particular condition, a situation, a relation. Based on that, we get a value which is either true and false, and we have already studied this in Booleans and in operators under comparison operators, because we said that always these comparison operators will return either true and false. So their return value is quite important. That is why we're going to use them here in if and else. Okay, so we can also test variables as well. So you can write, hey, integer x is equal to 20, integer y is equals to 18. If I write if x is greater than y, okay, then what should happen? So now what it's going to do, it's to say, oh, I have a variable called x, a greater than variable called y. The value of x or stored in the memory is 20, so it's going to fetch that value. 20 is greater than the value of y in memory is 18, so it's going to fetch 18 here. So 20 greater than y means greater than 18, condition becomes true, this code is executed. So you can use this expression as well, and most commonly that's what we tend to do. Okay, so in the example above, we use two variables x and y to test whether x is greater than the value of y using the greater than symbol. As x is 20 and y is 18, we know that the 20 is greater than 18, and we print the screen this value here. Okay, so this is only using the if statement. So if can be used independently. But if we move to the next step topic, it's called else statement. Else statements are used to specify a block of code to be executed when the condition of if is false. So what happens if this condition becomes false? In that situation, the control will go to else. Okay, so in this statement, when we said if 20 is greater than 2, do this. But what happens if this is like 222? Now this condition becomes false. What to do now? Now we say if this condition is false, go inside else statement and execute something else. So this can be another single line of code. Control C, for example, this thing, and we say, for example, false, else is executed. Okay, and then we run the code. So now what is this going to do? Hey, 20 greater than 22, this condition becomes false. Because this becomes false, this block of code is ignored. Okay, so do remember in SPY programming, we always count on these blocks. So if something is false, the entire block gets ignored. in this situation. So once this is ignored and this is false, and it control will go to now else. So from this line, the control will move to this else, and it will execute this statement, whatever we have written inside the else statement. Because this is just a single line, I can write it here. But if there are multiple lines that you want to execute, okay, so for example, if you have this control C and you want to execute multiple lines under this else, now this will create a problem because we have not created a block. A block represents multiple lines of code. So if you have something that belongs to a block or a piece of condition, then you need to write inside a block. So this means when if is false, the control will go to else and it will execute all of the block. Okay, so it will execute all of the statements of the block. If this condition is what we call true, 20 is greater than 2, the condition becomes true, we execute the code. Now what happens? It's going to only execute the first line, and everything below it, including else and the block, completely is ignored. Okay, so this is how if else statements tend to work. So it all depends on this condition. If the condition is true, execute this, else execute this. If it's a single line, for example, in this case also, we only have a single line. So we can write, and space doesn't really matter, so you can leave it that. The single line is there, we can write a single line without the block of code, no problem with that. So if you execute it, there should not be any error. Okay, 20 is greater than 18, we got this output because it's a single line. But if you again use multiple lines here without the block, then it becomes a problem. So this is again one common example, error issue that so many students tend to make. Because we are using multiple lines, do make sure you use a block. And sometimes people assume that without the block, the code will not work. So that's also not case. That's not the right case. If you are using a single line of statement, you don't need to write a block. What happens if I don't use a block anyway? Okay, so in this case, I'm not using a block. Now what should happen? Sometimes we ask this in exams as well in various different situations that, hey, I have a if, I have a block, fantastic, fantastic, fantastic. I have a else, except a couple of lines. What should happen? So sometimes we assume that all 3 lines will be printed, okay, because again, all 3 lines come under else. Or sometimes we assume that it's going to print only all these 3 lines, okay. So we said, no, what's happened here is that now 20 is greater than 2. So the condition becomes true, right? So it printed 20 is greater than 18. Perfect. But then it printed these 2 lines as well. Not the first line, second line. How do we know first line? So let me just say, for example, first line 1, and then let me copy the string. Let's be lazy, and then copy this here, and then copy this here, and then make it 2. So we know that this is 2, and we make it 3. So we know this is 3. Okay. So if I re-execute the code, now we'll notice that it will ignore the first line and it's executing line 2 and 3. Why? Because you have not used a block here. So by default, the C# compiler will assume that the else has only one statement, and the rest of the code actually do not belong to else. So it will only connect one statement with else. Hence, when the first condition became true, it executed this block of code, and ignoring the first line which is associated with the else, it went on and executed the remaining 2 lines as well. That's a very critical thing. So this tabbing actually does not matter. It's just the convenience sake for our coding. So this technically represent or can be written in this way as well. Okay, so I have something like this. So this now means that if condition true, execute this, else if condition is false, execute this line, and just here. So you notice we just change the spaces and makes more sense. But in programming, these spaces does not really matter. These spaces we use for our own convenience sake, so that we can make the code readable. So now if you make this, see this, now completely the meaning has changed. We assume that all 3 lines belong to this else statement. So when this condition becomes true, these should not be executed, they should be ignored. But they are not ignored, because if there is no block here, then by default only one line becomes part of else. Same goes with the if as well. So we need to be very careful about that. If you do want these 3 lines to be part of else, then make sure you use the block here. Okay, now because we use the block, this will assume that if this is true, execute this, and then the else and all the code that is connected with the block are ignored. Hence, if I run the code, it will only print the first line. Okay, and all lines inside the else block are ignored. So this is one key aspect of logic that we need to follow. Okay, enough of that. So let's just do some more examples here. Time, integer time is equals to 20. If time is less than 18, we print console.write Alan good day. else console.write ln good evening. So if you check out the code, again, it means that let's say find out the time. If time is below 18, okay, as per 24 hours, we say good day, and after 18 it becomes evening, so we say hello, good evening. Okay, so we use this if statement. If time is less than 18, condition is true, print this thing. Else, if the condition becomes false, then from this if, ignore these lines and the control goes directly to else. Okay, so from here the control goes here and the block of code is executed. Understand? Wonderful. Okay, so this example is again explained in the same manner. Let's talk about something called else if. The use of else if statement is used to specify a new condition if the first condition is false. This is also known as nested if else if structure. Nested means if inside else inside if, right? And then this if can again further have else statement, further have if statement, further have else statement. So the way it works is that it checks the first condition. If the first condition is true, it executes this block of code and everything else is ignored completely. All these else if are ignored. However, if this is false, then it goes and evaluates else here. And within this else, because we have another if associated with this else, so this if gets evaluated and this condition is checked. If this condition is true, this block of code is executed. If this condition is false, again this block is ignored and the control goes to the next else and it executes. So it creates a multi-conditional statement kind of a loop. Okay, so for example, let's check this code. So if integer time is 22, so let's assuming that the temperature time is there. Let's assume that if the time is less than 10, right? So it's before 10 a.m. console.write ln good morning. However, if time is greater than 10, so we say else. If this is like 22, so this condition becomes false. Because this becomes false, the block of if first if is completely ignored. So the control from this, because of being false, goes to this else here. Within this else, again we have another if. So now this condition will be evaluated. So it says time less than 20. If this is true, print good day to you. If this is again is false, ignore this line, and for this if, the control will go from this if to this else, and then print write ln good evening. Okay, so if always evaluates a condition, it always evaluates an expression, as we call it, a logical expression. If the condition is true, immediate statements below if are executed, and if you have written else, that else will be executed. That else can contain another if inside it. If there is an if, it's going to check that condition. If it's true, the statement will be executed. Otherwise, control can go out. So it's not necessary that we write this else. I can end the code here, or if I want, I can write the code here as well. Depends on how basically we want to use with it. Okay, so I hope you understand it. Now, before we go further, again, there's a shorthand if else operator, which is most commonly known as ternary operator, tertiary operator, sometimes called. But I'm going to talk about this later on. Let's do few examples of if else statements, do real world examples, and then come back to this tertiary operator and we'll discuss switch. Okay, so now let's do examples. So I'm here now on a website called onecompiler.com C#/. Again, this is a online compiler that you can use to compile the code. Again, don't get me wrong, W3Schools website is again fantastic. You can use the same compiler online to compile your code, but this just gives them some nice helps and make coding a little bit faster for us to work with. So I'm using this compiler as well. So if you are doing programming, you can come here and choose from various different compilers online and do the coding to much part online, and you don't need to download and install anything. Okay, this is a wonderful way of sometimes doing things easily. So let's just kill all this code. Now, the first thing that we want to do is let's start with simple thing. Check if the number is even or odd. Okay, so basic program. Let's just check whether the number is even or odd. How do we do this? Okay, even or odd. So first thing, as you know, that we will be using something called using, and then we will use system to let the C# know that we are using the system default programs. Then we create something called namespace, and I'm going to name it, for example, dr myself. This is my package name, and I will put all my code relevant to this within this namespace. Then we need to create something called a class, and let's just give it a name called even odd. Again, any name we can give to this class. Do note that I'm starting a block of code and ending a block of code and then add the space. It just helps me to easily ensure that the block of code start and ending are all matched up. Okay, once we have that, now we need to give something called a static void, and we give main bracket start string, and then we give something called arguments, and then square brackets. Okay, now main method is there. Again, block start, block close, and then move cursor back, enter to add the new line here. That way, again, you can see this, that all closing brackets are properly aligned with all starting brackets, and just makes things a little bit easy. Now, the idea is that we take integer, and for example, I can say number, and if the number is 3, I want to find out that whatever value is saved inside this number is either even or odd. So we just take a variable, or you can take an input from the user as well. So now we write something called if condition. So we need to evaluate whether this number that we just entered is even or not. So the easiest way to do is find a remainder. So we use a percentage sign, remainder, and find the remainder equals to 0. And then block start, block close, bracket. What we did now is we evaluate a condition, an expression that allows us to find out the remainder and then use a conditional statement to check whether that remainder is 0 or not. So in this one if statement, actually we are performing a calculation, and then whatever the answer of that calculation comes is being compared to this value 0. So this is again a perfectly legitimate answer. So eventually this will return true or false to us after completing this entire expression. So first it will find a remainder, then equal to is 0 or not. So whatever is the remainder of 2, if the remainder is 0, means the number is even. So let's just print a simple message. We say console dot write, and WRITE, write line and inverted quotation marks, and we can say the NUMBER number plus, and let's just print the number here again. Oops, now this one, NUMBER number plus inverted quotations is EVE and even. Okay, and then let's just put a semicolon. Don't forget to put a semicolon. So now what we did was we used this number, inverted quotations, as a string, plus whatever number we enter here will be used here to print within this string is again even if the remainder is 0. So let's just execute this code by clicking on this run button, and it says compilation error failed, 0 warning, array type must be specified, must appear before the parameter name. What? Oh, okay, sorry. I think this is the issue. We need to use this at the right place. And then the program did not output anything. Did not output anything because we have a 3 here, and this condition becomes false. So we took a number divided by 2. The remainder came 1. Obviously, 2 divided by 3, there will be 1 remainder, is equals to 0. It gives basically false result. Since this if is false, this line is ignored. Hence, this compiler will tell us. This is again not the official C++ C# output. It's just the way this compiler, online compiler, works. They tell us that, hey, there's no output from this program. Okay, so that way we know that there's no output. Perfect, this is exactly we wanted. So if in this case, what if the if returns false, what should I do now? So this is where the else statement comes into, and we write again something, console dot write line bracket start bracket close, inverted quotation start and close, and we will use the same string. So we can say the number, inverted quotations close, plus add the value of this number here. Okay, and then plus join this entire string with this string is odd. Okay, and then make sure we give a semicolon here. So if the number is 3 here, the value will be fetched from the memory. 3 divided by 2 or 3 mod 2, whatever is the remainder is then compared with 0. If this becomes true, this statement is executed and everything else is ignored. However, in this case, this statement becomes false. Hence, the first line is ignored and else statement is executed. And whatever is underneath the else will be executed. So if I run the code, we should see the number 3 is odd. The output is coming from this line. The number and the 3 is coming from this number value, which we have concatenated with this string value. Okay, and is odd. So if I give, for example, 22 and then run the code again, the number is even. Perfect. That's exactly what we wanted. So you see, a very simple if-else statement allows us to understand how the logic is working. Okay. Using the same thing, let's just create another program to understand how more complex form of if and else can work. Okay, so I will create another window of this one compiler, or we can just create a new code, come back here, and then let me add, where's my one compiler gone? Sorry. Okay, so I reload this thing. By default, every time you open it gives you a dummy text. You can use that, no problem with that, but for our sake I just want to start fresh so that we get into habit of typing everything. So now what we're going to do is we can create a grade system for mark sheet. Okay, and the way it's going to work is that if the grade is, and then now I'm going to use multi-line comment here, oops, backslash static, and then static backslash. So multi-line means multiple lines I can write without using these backslash for every line. Okay, so within this now we say that if your marks are between a grade, if grade, or for no, not grade, if marks are, so if your marks are between 0 and 39 is equals to, you are basically fail. However, if your grades are from 40 to, for example, 59, you get what we call D grade. Okay, and then again this depends on your grading system, however you want to follow up. But if you get 60 to, for example, 70, 70 I guess is equals to, you get a B grade or a C grade. Okay, and then if you get something, okay, let's just make this, usually if I follow correctly this is supposed to be 69, and then we start from 70 to something of an 79, oops, dash 79, you get something called a B grade. In fact, in most cases, yeah, that works fine. Then anything from 80 to 89 will render us A grade, and if you get anything from 90 to 100 you get something called A plus. Okay, so now you know there are multiple conditions and the range that we need to evaluate. Based on what your mark is, we need to evaluate. If your marks is between 0 and 39, you are fail. If you get 40 of between 40 and 59, you get a D grade. If you get between 60 and 69, you get a C grade. If you have a 70 and 79, so it's basically 10 increment all the way, and we need to check the range that your marks are between these range. To do that, let's just start working with the program. So first thing we do again is we say using system semicolon, and then I'm going to say, hey, I want a namespace. Again, I'm going to use the same namespace. You can do whatever you want. Okay, called bracket start bracket close. Then we know that we need to create something called a class. So we say, hey, there's a class, and I'm going to say mark sheet. So this becomes my class name. Okay, then within my class name I'm going to create something called static void, and then I'm going to use something called main bracket start string. In fact, s is supposed to be small, string inverted quotations arguments, and then again block start block close, and then I move a cursor back and press enter to add this space. So that way I have correct number of closing tags and correct number of starting tags. So within this, let's just create something called integer marks is equals to, for now let's just make it 10 marks, bad boy. Now how do we write this range? How do we write an if else statement that allows us to have this particular range? To do that, we write if your marks is less than, equal, or less than 40, for example. Okay, so if your marks are less than 40, what are you supposed to do? You're supposed to do console dot write line bracket start bracket close inverted quotations. We say your marks are, and then we plus add the marks. So we tell this guy that, hey, these are your marks, and then again add a string inverted quotation marks, and we say e equal to for example fail, 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 and then don't forget to give a semicolon at the end. So if your marks are less than 40, you are fail. Understand? Perfect. So let's just run this code and see if it runs at this point. So this says hey, your marks are 10 equal to 40 fail. Okay, or you can, instead of equal, you can just use is equals to fail. Okay, so if I now run it, because I've made some changes, I say, hey, your marks are 10 is equals to fail, you become fail. So it depends whatever string you want to do. It's just really no matter. So now I have 40. What happens if I get exactly 40 marks? Okay, what will be the output now? Will this condition be true? Because we are evaluating an expression. So it says marks less than 40. So if I run the code again, this is going to say program did not generate any output. Why? Because my marks are 40 and this condition is evaluating less than 40. Anything less than 40 will render this as true. Anything from 40 and above, it will be false. So if I give it 39, okay, and run the code, it will say you have failed. So 39 is exactly less than 40, but 40 and above will basically be false. So in this case, let me just copy this line, okay, so that we can be a little bit lazy later on. We write else, and now I need, inside this else, I need to say, hey, what should I do? So I do again if, and then bracket star bracket close, and I'm going to now write a more complex conditional statement. I'm going to say else if this is false. For example, if my marks are like somewhere around 79, what should I do now? So I say, okay, if your marks are not less than 40 and they're greater than 40, so we're going to check, okay, if your marks are greater than equal to 40 and your marks are less than 50, then you're going to do something called this thing, and you get what we call D grade. Okay, so now what this expression is doing is, let's just try to explore this. What this expression is doing, it's checking the range as per this requirement, 40 and 59. So we want our D grade to be between this range. To achieve this range, we wrote two expressions with AND operator. Now we have discussed all this already. So we're checking, hey, marks must be greater than, and this time I've used equal to. So if I use 40 here, this should be true condition, because now I have done equal to. If I don't use equal to, again 40 will give false and no output will be generated, because 40 is not less than 40. This will be false. It will then come here if marks are greater than 40. Again, greater than 40 is not 40. Okay, greater than 40 means 41 and above, so this will again be false. So I need to use equal to sign here. So the first condition, it needs, hey, your marks have to be 40 and above 40, including the 40 itself. Okay, because we have used equal to, and because we have used AND operator here, this will again go and check the second condition. The second expression is, now your marks needs to be less than 50. Okay, if you want to be specific, you can use equal to here, and then you provide, for example, 59 here. Okay, which basically means that exactly what we need, 42 for 59. So if you want to use double equal to, or because we know that 59 would be equal to 60, so we can just use the 60. Now it depends on how intelligently you're working, what exactly you want. Both these expressions will give us the same thing. So if you are using less than 60, less than 60 will basically mean 50. But if you are trying to understand that I exactly want 59, so just use equal to, and then make sure we provide 59 here. This again is also equal, fine. So this means equal to and less than 59. This is greater than and equal to 40. So we provided this range here, 40 to 59. If this is true, what should we do? So now we have something called 40. We run the code and we get 40. Your grade is D. Okay. What happens now is, first it checks this condition. Since this becomes false, this line is ignored and control is moved to the else statement. Inside the else statement, because else has another if, so now it's going to check another condition. And this if is a little bit more complex. It says I need to evaluate two sides of an expression, and both need to be true because and is there. So what happens if I give marks which are like, for example, 60, or let's just make it 70 to be more permanent. So if I run the code now, it says program did not generate anything. Why? Because we have given it explicitly a range. Both of these needs to be true. Marks needs to be greater than equal to 40. This side is true. This becomes true. Said, I agree, this is true. However, when it goes here, and marks must also be less than 59, greater than 40 and less than 49. So this and actually plays that physical and. There's no if, but, else, or. It has to be that both of these conditions need to be true. So this is where and play a vital role. If I use an or operator here, okay, and I set it to 70, this, if I run the code, guess what happens? Exactly. Because now we have given it a choice, or a real choice. Hey, do this or you can do that. Marks needs to be greater than 40 or marks needs to be less than 59. So because the marks are 70, the first side of expression became true. Grade needs to be greater than 40. Yeah, it's greater than 40, 70. So it says, hey, because one is true, and we have a choice because of this or operator. So this whole expression became true, and console log's write line got executed with a D grade. So that means we rendered an invalid output. This should not be there. So there's no error in code. Code is working fine. This is not the code error. This is not a compile time error. This is what we call a logical error. Logic means that your logically there's issue in your code. Syntax wise there's no problem, the code is working fine, but the how you develop your programming logic is key thing. And that key thing is that I don't need or operator here, I need an and operator here to ensure a strict rule between 40 and 59. Understand? So, perfect. So if you understand this, now we just follow. What happens if my marks are 70? So this also becomes false and we get no output. So we again go another else. We say, okay, if this condition is not satisfied, then go to else and do another if check. Now check whether my marks are greater than equal to 60 and my marks are less than equal to 69. Okay, if that is the case, then what you do is you control V, you go here and you print this line. So if this condition becomes true, you print this line and you say your marks are, for example, C grade, okay, with the semicolon. Okay, so this is an example of nested if else statements. So now it will check, hey, is the range true here? If the range is true, this will print. If this range is again false, now I write another else, I write another if, again I check, hey, listen, if it's not the case, now check if the marks are greater than equal to 70 and marks are less than equal to, for example, 79. Okay, because as per our, oops, what happened? Oh, no, 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 we missed it out. Anyway, so let me just copy it. I think I changed the window here. So we write else if marks are greater than 49 and we say 60 and we say 69. Let me just retype this thing. Your grade is C. Okay, then come back here. I usually like to give this tabs. This tab allows us to understand the code more appropriately. This is more professionally, more people do recommend you to use this. See, so we follow a nested structure as we go. So now we say, okay, if your marks are above 70 and less than 79, okay, so this is what we want to go for. So now you get something called B grade. Perfect. Okay, so if I execute this code right now, let me just copy this in case I mess it up again. Okay, so and this time I get something called, you get a D grade. Why do I get a D grade? A, B, C, D. Did I not run this code properly? You get a D grade. Why I'm getting a D grade? If 70, okay, I still have OR operator here. Sorry, since I said I messed it up. So because the first this condition becomes true. Okay, marks is 70. I said if marks are greater than 40. True. Yeah, marks are 70, they are greater than 40, or marks are less than 59. But because this becomes false, like because we are using OR operator here, it needs only one side to be true from left and right. So because this is true, the if becomes true and this line is executed and all the lines below it are completely ignored. Hence, we are getting the D grade. Remember, as I said, I just moved the page back. So we got back to this point. So we again remove this logical error and make sure we come to the proper conclusion. Once you understand this, control C this line again. And now for this next part, again, I'm going to write another condition. So if this is false, now you need to check if your marks are greater than 80 and 89. Okay. If this is true, if this becomes true, then what I'm supposed to do, let me run this code again. And now we get a B grade. So if my marks are 70, this means that it's going to check here. Marks, is it less than 40? This becomes false. The control goes to this else. Marks greater than 40? True. But and marks need to be less than 59, less than equal to 59. So this condition becomes false. Because this is false, and operator will convert this whole expression into false because and needs both to be true. So from control from here will again go to this else, and this line is again ignored. This else again contains another if inside it. So now this if will be evaluated. If marks are greater than 60 and marks are less than 69, then execute this. But again, this becomes false because marks are greater than 60, true, but and forces it to ensure that the both sides are true. So the both side 69 less than 69, this becomes false, hence the whole expression is false. The control from this if now jumps to this else. Inside this else we again have another if, and now we check, hey, are your marks greater than equal to 70? You said yep, true, agree with that. And your marks are less than equal to 79, agreed, true. So hence at this point both of these becomes true, so it prints a B grade here. So your marks are 70, which is actually B grade, and this should be actually A grade. Finally we say control V one more time, come back here, that if your marks are above 90 and less than 100, now you need to print your marks are this, and I can write congratulations, da-da-da, you got what we call A plus. At least A plus deserves a congratulations, right? There we go. So now we have this thing. Finally, what happens? I mean, let me just make this A plus. I want to see this, the 99. So what if I got a 99 marks out of 100? I come back here and I say run the code. Ta-da! Congratulations, you got A plus close. Your marks are 99, you got this. So now see, this is an example of nested if-else structure, where our code is nested into multiple logical conditions. We have this expression here. These are the user requirements we try to satisfy, and each user requirements has a range. For that range, we use this marks greater than and less than symbol. Finally, I want to do, what if I give marks and I became overexcited and I say, hey, my marks are 101. What should happen now? So if I run the code again, it says, hey, nothing. I didn't get any output. Why? Because I entered an invalid number in my marks. Okay, because this condition became false, this false, this false, this false, this false, all the condition becomes false. So at the end there's an if, so it's not necessary to write else every single time. It depends exactly how you want to do the code. So for example, if you do want to write it, we can come here and we can say, listen, let's just move to this point and come here. Oops, tap 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 tap, and at this point I write else, and I'm again going to write, listen, if this is the case, write console dot write line method, and we say inverted quotations, please enter marks between 0 and 1, okay, 100. Okay, and then we just gonna go this way. Make sure you give a semicolon at the end, and now this is how it looks like. So let's just check this. So now if you run the code, please enter marks between 0. So we provided an error message as well. So if you give any number outside 0 and 100, it's going to give us this message. Understand? So this if finally this also is false, it will come to else. So now I have not used if here. I don't need to. It depends on the logic. So this is what you need to understand whenever you're doing programming. You need to understand various different logics of solving a problem. There might be errors in the code, but there might be errors in your logic. And this logic means you start working with this. So I will be sharing a complete manual of programs that you can practice and do the task in the description. So I'm still working on it. So hopefully by the time I finish this video and upload it, I already finished those questions and I will share the links with you. So you can actually go and start practicing many different tasks, just like this one. Okay, fantastic. Control A, Control C, copy this code and save it if you want. I don't think so they have a download option as far I understand, but it just gives a tooltip, very easy to write and use it. You can do the same coding in this one as well. So this is another example of what we call if-else statements. Okay, so now let's do one more program, and this is like a very simple discount calculator. Okay, so the idea is to count discount based on age. Okay, so the idea Very simple. We take age from the user. Based on the age, they get a particular discount. How do we do that? Again, every program begins with using system. So we write that. Then we write something called namespace. And then again, I'm going to give a same namespace so that all code belong to my same thing, Zeeshan C sharp, block start, block close, enter. Then we create the class, CLA class, and we're going to say DISCO discount, block start, block close, and then again static void m capital main bracket start a string block start arg argument, and then outside the block bracket start bracket close, enter. Okay, so assumingly integer age is equals to, for example, 12. Now based on this age we need to calculate how much discount we are supposed to get. Okay, so for example, I say, okay, if your age is equals to greater than or let's just make it simple as that. So if your age is less than equal to 12, then what do you get? You get console dot write line print inverted quotations, you are free. Okay, okay, perfect, semicolon. But what happens if your age is like 14? Okay, so now if age is 14, what should we do? So that means that if age is less than 12, you're free. However, so we write else if bracket block start block close, and we're going to say if your age is greater than equal to 13 and your age is less than equal to 18, or let's make it 17, right? This is a standard age. So if this happens, so if your age is between 13 and 17, then we say, listen, because you are between 13 and 17, this time console dot write line bracket start bracket close inverted quotations, you get 20%, or let's just make it, oops, you get 25% discount, semicolon. However, if your age is greater than 18, so we say else if age is greater than equal to 18, then what I'm supposed to do is I'm going to write console. Now do also note that at this point we are not using blocks for if and else. Typically you should. Okay, maybe you'll do this in the next example. So write line inverted quotations, and we can say you get like 15% discount since you are adult. Voila. Else, but then again everybody above 18 or something else that works, right? So in this case, if I just leave it here, I can. This means anybody who's above 18 gets a discount. Perfect. So now we have 14. If you run the code, you get 25% discount. Why? Because your age is 14. So if you want to print that message, we can do that. Inverted quotations before this, and then we can say your age is space plus the age variable. So we concatenate this age variable with this. So whatever is inside the age variable, what the value here will be basically concatenated with this. But then we also need to add a plus here, so that then whatever is the outcome of this expression is then concatenated with this one. Hence, if I run the code, it says your age is 14, you get 25% discount. But now notice 14 and 25 are joined together. That's because this u starts immediately after inverted quotations. So we need to give a space here so that if I run the code, now it appears more readable form. Perfect. So you can select this, Control C, and we can add here and give a space before this u, and we can add the same string here and then give a space here. That means that if my age is, for example, 24, I run the code and it says your age is 24, you get 15% discount. Okay, so this becomes a very simple if-else program that we created and then allows us to develop the logic. Hopefully you understand that. So that's the idea behind it. You understand things and then you develop statements that allow you to work in a various different situations. Let's try another example now. Okay, so now let's just do this program called check voter eligibility. Okay, so condition is if you are 18 and above and have your what we call the national ID card, okay, uh, of, for example, Malaysia, then you can vote. You can vote. Okay, so simply this is the basic conditions. Now using again same thing, so we say using system. Okay, obviously can copy the basic boilerplate every single time, but I'm writing it again and again, so it just, if you write again and again something, it makes you remember it more easily. So I'm writing this again and again for you, and I hope you do this initially so that you understand this and remember it as well. So we need to write using, then we give a namespace, then we write something called class, and I can say check voter. This becomes my class name, and then I'm going to say fantastic. Let's just use something called static, make it void with capital M main, then inside it we use a string, square brackets for array sign and arguments, again block start block close. We have this code. So we take integer, again age, and let this be, for example, 22 semicolon here, and then we're going to take another variable called string, and we say have nic is equals to, and we can use yes or no, or in this case we can say, for example, boolean, bool, bool. Okay, because I just need yes and no. So if this is the case, I can say yes, and then I can say bool is malay Malaysian. Sorry, I'm using Malaysian because I'm from here. MALAYSIAN Malaysian, and we say is equals to yes. So this time I'm using three variables to check different conditions. Okay, so that's the idea. So we are checking the age, we are checking that have they their own NIC, and then we check whether they have their is their Malaysian status okay or not. Fine. So we use if block, and we say if age is equals to or is greater than equal to 18, and now what we need to check, have an IC and is Malaysian. That's it. Why we use these three variables? There's no expression here. Okay, because this is a Boolean variable, and in terms of using an expression here, they return true and false. So this again already is a true or false. This again is already a true and false. So since we have created a Boolean variable, now this becomes a perfect example where you can directly use a Boolean variable without writing any comparison. We don't need to check if have nic is equals to true, because again that expression we can do that. Okay, if I can write this as true as well. What this would mean that check whether nic is equals to true. This would work fine, but this again would return either true and false. And since we already have a Boolean, so either this value will be yes or no. Do you have an IC? Are you Malaysian? So in this case, we don't even need to write that. So we directly use the Boolean value here, because again, remember, every expression will generate and true and false in form of Boolean. So if needs a Boolean, and will again check two conditions based on Boolean. So if we have a Boolean directly, we use the Boolean variables here. For this as well, I can write this as true, but there is no need to write this extra word because already this is a Boolean. So if this is true, it's already true. If this is false, it's already false. So I don't need to check it. In that case, I can say, for example, now, again, remember I talked to you, you need to have a block. So sometimes, again, the good practice is block start, block close, close it. So this is not mandatory if you are using printing a single line, just like in previous example. So because we were just printing a single line under if, we did not need the block. However, if you want to print multiple lines, in this case, we will try to do that. And then you will need that block. So we can say console dot write line. Again, L capital, keep in mind, inside the inverted quotations, congratulations. Okay. You are eligible Okay, if you want, we can say hello console dot write line, and we can say you age is, and then plus, and I can use the age variable here, semicolon. Okay, do note that we have a method called write as well, remember, so we can write console dot write as well, and not line, just write. And I can say your age is this, and you have your NIC, plus I can print this value, have NIC, semicolon. Then I can say console dot write, and then I can say, and it seems you are MALAY Malaysian as well. Okay, and then plus I can say is Malaysian. If no, this is not needed, but I'm just printing it. And then finally I can say congratulations, you are eligible to vote. Now, what this basically means that inside this, if this condition becomes true, it will perform all these given set of instructions. So this block of code represents that if the condition is true, all these statements will be executed. If the condition is false, then nothing will be executed. Okay, so let's execute this and see how the things are working. So compile error, there are two errors in this code. That says the name yes does not exist and is the current context. Oh, sorry. Well, my bad. You're not supposed to say yes. We're supposed to say, bros, true. Ah, true. There we go. Okay. And then again, as I said, we can write this or we can just omit this one out. So let's just run the code again. And excellent. So we now get an output, but this is exactly what I wanted to show you. Your age is 22 and you have an NIC, true, and you are a Malaysian as well. True. Congratulations, you are eligible to vote. The key thing here is everything is printed on the same line. Why is that? Because we use the write method. Because we have used the write method 3 different times, the write by default will print the same line or will print the string on the same line, and it will not add a new line. This word line here refers to adding a new line after this text. So at this point, for example, I want there to be a new line. So this write ln, I can write as a write line. This would mean that it will print these three on the same line. After this third line, it will add a new line. So now if I execute the code, it says you are age is 22. Let me just kill this. I hate that. Your age is 22 and you have NIC, and it seems that you are Malaysian as well. Okay, true, true. And then we say congratulations, you are eligible to vote. So now note this, the congratulations message is printed on the new line. However, the first three lines are still printed on the same line because the write method means print the string, print the string, print the string, and then add a new line. So this align will add the new line after the string has been printed. Okay, so these three lines get printed on the same line. So if you want to use that, perfect. If you don't want to use that, if you want every line to be on the new line, you just write the line method. But do note that adding the line word will add a new line after the string has been printed on the console. So now you get it. However, what if you are not? So we check else. Okay, and then again, else can have a block of statement. And if I can do this, I can print all these things. Oops, let me just copy this, be lazy, control C, bring it here, and I can say console, your age is this, you do not, you have NIC, or just make it this way, and it seems you let's just change this, you are Malaysian, and I'll just remove this word as well so it makes a little bit more sense. Sorry, you are not eligible to vote. Okay, so in this case, for example, if any one of them becomes false, if I run the code now, it says 22, you are, and your age is 22 and you have your NIC, which is false, you are a Malaysian, true, but you are not eligible to vote because one of the conditions become false. So let's just use a line here all the time so that everything gets printed in a better manner, makes a little bit more sense. Not in case of output I actually wanted in this manner, but here I'm getting a smaller thing, so I'm just using this, and this should do the trick. So if I run the code again, now see, more readable. You are 22, you have your NIC, which is actually false, so you can use, for example, colon here, and then you can use a colon here, and then you can use, for example, your age is colon, and obviously since it's supposed to be string, so you can easily print that, no problem. And then you run the code, it prints colon 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 colon, makes this false stand out a little bit. Sorry, you are not eligible vote. So since any one of these conditions becomes false, true, if I make this as false false, run the code again, you are not eligible. Why? Because we have evaluated three different conditions now. Age has to be above 18, have NIC, a Boolean variable, so we just directly use the Boolean variable here. So do you have NIC? Either true and false. So if you say true, means you have an NIC. Since this is a Boolean value, and if requires a Boolean expression to generate a Boolean value for us in true and false forms, so instead of writing an expression, we directly use this variable. Okay, so that's key thing to understand. And then we use another AND here. Now this time we have used double ANDs. So we are checking three different conditions in a same if statement. If your age is above 18 and you have an IC and you are a Malaysian, so three conditions are evaluated, and we do that. Okay, so I hope this clarifies and explains few things easily. Okay, perfect. Now let's move on to our next topic, which is, where were we? I think switch statements. So let's talk a little bit more about the switch statements, and then we do few more examples of conditions that allow us to involve switch. Okay, so what do we mean by switch statements? Switch statements are used to select one of many code blocks to be executed. Switch statements behave or are a different spin-off from if-else statements. They do check conditions. They are also under a branch of conditional statements. They work like if-else statements, where certain condition is satisfied, then a piece of block is executed. But here there are many blocks to choose from, that which block to execute if a certain situation is satisfied. Okay, so if certain situation is satisfied, certain block will execute, and you have option to give many blocks as well. So it works again same as switch, as if else. Okay, the way we write it, we say we have a switch statement, bracket start, bracket close, and we write an expression here. Then we block is start, and then block is close at the bottom, and at the middle we now give something called case and break structure. We have a case and break structure. We have a default with a break structure. This typically behaves as a switch in case. The switch expression is evaluated once. Okay, so here's the key thing. The system goes, this expression is checked once. The value of expression is compared with the value of each case. So whatever we write here, this actually is evaluated with this each case individually. Okay, simply speaking, switch in case works with, or is always working in form of equal to operator. Okay, it always behaves like equal to. So we write a value and then we write another value here, and these two values are compared. If these two values match, the code below the case executes. If they do not match, the next case is evaluated. So expression checks case number 2. If this value and this value match exactly using equal to comparison, then this block of code is executed, else everything else is ignored. Okay, so if these two catches don't match, then finally default is executed. Default will execute when none of the cases actually match the expression. So that's why we call it switch and case, where each case is individually mapped with their expression. So expression is there, and individually we check each case against it. We can have, I believe, 999 cases. So here we can write as many cases as we want. Okay, this is very much associated with block of code executed. Okay, so the block that executes is connected with the case. So if the case true, only then that block of code will execute. The break and the default keywords will be described later in this chapter. Okay, dokie. So let's move on forward. So here's an example of how this works. So this example below uses weekday numbers to calculate the weekday name. Okay, so assumingly if I give you a number, you tell me which day of the week that is. So let's just evaluate this. Now what's happening? We have integer day is equals to 4. So we create a variable. We store the value of 4 in this variable, which is of type integer. Then we say switch, switch with a small s. Again, switch is a keyword, is also a reserve word. So is case, so is break, and so is default. Okay, I don't think so they've used default here. So is default. By reserve word means you cannot use switch as a variable name, you cannot use switch as a method name, and you cannot use switch as a class name. So you need to be very careful about that. Same goes for the case and break as well. These are reserved words by C# for itself. So now we're going to say, hey, listen, I have a variable called day that contains a value 4. So I pass that value to the switch. So this is where our expression comes into play. So the value of day has been passed here. Now what the switch will do, it will take this value of day, which is supposed to be 4, and map it to each of these cases. Or in other words, will evaluate using equal to comparison, that is the value of day equal to this one, is the value of day equal to this value 2, or is this value of day equal to the case 3, or is this value of day equal to case 4, and now it becomes true. Okay, so it will compare with each case individually. If the value of day becomes true, then it will execute the code and ignore all other statements. That's it. Okay, again, similarly, it behaves like an if else, but it's a simpler version of evaluating a multiple block of code. If you were to write the same thing in if else, you would end up doing something like this. This code here, see, we have so many if else, if else, if else, if else, if else statements. The same can we can do same with this as well, but then it will means if day is equals to 4, else if day is equals to 2, else if day is equals to 3, else if day is equal. So it will be else if else if else if else if else if so longer time. So using switch in case in certain comparisons makes it more easier to follow, because you have directly evaluating a single case, and if the case is true, the block is executed. If the case is false, it's next one is compared. But the key point here is, and the disadvantage here is, that the day is mapped using equal to with this value. So this is a value here. It's not 1, 2, 3. You can write any number of values here. Or even you can use a variable here, no problem with that. And that variable's value or that value will be mapped with this day. If they both are matched, then the block will execute using equal to operation. There is no relational operation here. There's no relational checking here. So unlike in our earlier program, we check a relation, that is it greater than this value and needs to be less than this value. This unfortunately cannot be done in switch statements, because switch will always do equal to comparison. So if you check this code, it says Thursday because case 4 is now true, and it does. So sometimes we read it they is equal to 4. So instead of using the word case, if you use the word equal to, it starts to make more sense. Okay, so that's because it's always checking the same thing. So we say day for value 4, day's day is equal to 1. Now is this day equal to this 2? So now this day equal to 3. As soon as this case becomes true, it executes and then it breaks out. Understand? So this is what a simple switch in case statement does. So now let's understand the version of this default for now. Again, they have not used the default here. Let me just try to put in it. What if I give, for example, 41 day? Okay, now if I execute, nothing should happen. Okay, and that's why I wanted to use this. This compiler is a little bit faster as compared to this one for some reason. They're still executing blah 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 blah. Anyway, so if this happens, there is no output and we get no information. So that's why we write something called default. Okay, colon, and then we print the statement here. We say, listen, if there's a default, go into console dot write line bracket start bracket close semicolon at the end, inverted quotation marks, and we say enter week day between 1 and 7. Okay, so now that means that if my day is 41 and none of the cases are matched, the default will automatically execute. Okay, the default will automatically execute. So if I run the code, okay, so if I run the code, I get an error. It says control cannot fall out of the switch. So we say, why is that? Control cannot fall out of switch statement through final case label case default. Okay, so this error is again, hang on, why this error is there? Okay, sorry, we need to write break here. Now if I run the code, okay, so enter the day between 1 and 7. So we say enter the day one. So if no case is true, it falls between that. Why we need the break statement? Let's talk more about that. So basically, you need the break statement to break out of a switch block. This will stop the execution of more code and case testing inside the block. When match is found and the job is done, it's time to break. There is no need for testing. Okay, so let me explain exactly what this English is saying. This is saying that, listen, if you don't use break, okay, so if I don't use break here, what happens is that the day one is checked and the value here is 1, for example. To say day is equals to 1, day is equals to 1, this case becomes true. It executes this statement. But then once this executes this statement, it assumes that all other statements are also true, and it starts to execute other cases as well. And this is where it makes problem. So that's why it's throwing us error that control cannot fall through from one case label, case 1, to another. So it's giving us an error that, see, what's happening is that over the way it works is that if case 1 becomes true, now system will not evaluate every single case. It will just assume that this body is true, it will execute, and it will try to execute this line of code as well. But because this line of code is in case 2, it gets confused, and that's why it generates an error. If you're doing in Java there's no error. It will just simply execute this line of code as well. Okay, and that's where we call it a logical error. However, in C#, it says, listen, I understand your case 1 is true and you don't have a break statement, but the problem is once the case is true, now this, after this statement, I should execute or should not execute this line of code. I'm confused. For us, we say, hey, you don't need to because the case 2 is there, but it does not now consider case 2 anymore because for its purpose, the case is already true. Either one of the cases true, it will consider every case below it true. So it generates an error and says that I cannot fall through it. Your case 1 is there, but it seems that you have another statement that is below it, and before this statement there is a case. Remember, there is no semicolon, this is a colon, and that's why the problem is there. If there was a semicolon, that marks the end of statement, no problem with that. But after this line of code, it's confused what to do with this case. Okay, this is how it's internally built in. So the part of its core syntax is that we always use a break statement. It just stops the code of execution and breaks it from this point to this point here, and everything below this break is completely ignored. Okay, so that's why it's saying that, hey, I need a break statement to ensure that the code after the first case is true is breaks, and the code's execution is automatically blocked here and come out. This does not happen with the if else statement. For example, if I use the statement called 40 here, or let's just say 20 here, and I execute this code, it says your marks are 42, D grade. So it means the marks are somewhere between here. Your grade is D, and then the code automatically breaks from this point and comes out. All other lines below this are automatically ignored. Okay, when we use if else statements, these lines are automatically ignored. We don't need to use break. But for switch, that execution is not there. So switch works, as I said, in a different manner. It uses a colon here to evaluate a case or put up their case, and it means like it's a half done thing. It's my sentence is not complete. If this is true, then you need to complete this sentence, but then there is no semicolon and there's a case here, and this creates a problem. So it says I need a break statement. So it becomes a part of it that you write a case. If the case is true, the statements are need to here, and then you break it out. The other problem with this is that if you write this statement here, console dot write line, and then I put a statement, inverted quotations, after the break break. Now what should happen now? This will again generate an error. Okay, because this, after the break, the control stops and the code just follows to this point. So it says Monday, I printed, but this line is now not printed at all. It's completely ignored because we have already done a manual break, and we said, hey, break here, don't go here and print everything else. If you're using Java, Java will generate an error here. Okay, Java will say, hey, this line is unreachable. So if you're coming from Java or even C++, In Java and C++, there is an error. C Sharp is not throwing us an error. Again, this is for me first time as well. I never tried this. Usually we give this in examples. Anyway, so I actually didn't knew that before. I was expecting an error. You'll know everything. Anyway, so break at this point it's not generating error. Funny enough, usually it means that this line is unreachable, because always when I come to this line, I will break and I will never be able to execute this line. So this creates a problem for Java, C++, I believe Python as well, again because they all have it. But somehow C Sharp is not complaining here. So we said perfect, no worries. So it's always recommended that whatever code you write before this, and you can write as many lines of code as you want. There is no need of a block of code, but you can write a block as well. So you can use a block here, and then you can say, for example, this block here, but it's no need. You don't need to confuse your code and just try to keep it simple. So as many statements as you want, you can write here. It should not be a problem. Once all these statements are executed, it breaks and the code just does its job. Okay, so this is what a switch and case examples work with. So we use a variable, do equal to comparison, case is there. If none of the cases are true, default will automatically execute. Let me check one thing. Usually we can write the default at the top as well. It's not, should not be a problem as well, because default by default will execute when all of the cases have been evaluated and none of the cases are true. Okay, so if none of the cases are true, the control goes to the default. So you can write the default statement at the top as well. It doesn't need to be at the bottom. That's one other thing. For if else statements, when we write, the else always comes after the if statement. Okay, the else always comes after the if statement. However, in switch, and we can write the default statement before it. One other example that we sometimes end up doing is, what if I write this code? Okay, there's no case here, day one, and there's a default statement. This is sometimes we give in question in exams as well, and it may appear in some certifications here and there. What happens now if I run the code? Since switch syntax needs to have a case statement, but if you don't use a case statement, perfect, no problem, because again it's evaluating the default. So it's going to go day one, day here. Since there are no cases here, it's going to assume that nothing matched and I'm supposed to execute the default. This is a perfectly legitimate syntax. Some students do confuse that I must have at least one case. That is not true. You can write a statement without the case, and this means just execute the default statement. Okay, so this is a switch and case thing. Let's try to do a few examples of it so that we understand switch and case a little bit more better, just like we did with if else. Okay, so now let's just come to our new page. Let me open up the compiler and let me just get rid of this code and try to figure out a problem that we can do. Okay, so let's do a simple calculator. Block close, come here, create a simple calculator using switch switch. Wonderful. So let's just create using system. As we know, every C# code has to have a system thing. Then let's just give it a namespace. I'm again going to use the same namespace that I've been using previously. Okay, block start, block close it. Then we're going to need something called a class, because every C# code must have a class, and then we can call this calculator, block start, block close. There we go. Then we know that every code also needs to have something called static, void, and main with capital M. Okay, bracket start, bracket close, a string, argument, array, and then variable. Again, block start, block close. So now we have a very simple boilerplate code for our system. Most people tend to copy it and use the same thing again and again. But as I said, if you're beginning to try to program, make it a habit of typing it from scratch. That way you would understand the structure and syntax more better, and you can use it every single time. So for example, let's just use something called a double variable here, and I can say number 1 is equals to 20.2 d semicolon, oops, 20.9 d semicolon. Again, remember this d was for this double. We talked about this in our data types, that when we declare a data types such as double, it needs to have this d at the end. So we're gonna give this d to n. Okay, capital D, sorry, my bad. And then let's just create another variable called double, and let me make it as num2 is equals to, let me just say 12 and D semicolon. Okay, so I'm not using decimal value there, no problem, we can do that. It works for us very easily. And now let's just say, for example, which operations do you want to perform? Okay, so let's just use something called character operation operator, or double P is equals to single quotations. Remember, in character always has a single quotations. I always tend to forget, and I say, for example, plus. Okay, since we don't have a GUI, we are using variables. If you create a GUI, then you can use that. So if you're interested in this course, later on I will be creating Windows GUI based programming, creating Windows apps using C# and .NET. So do subscribe and hang out, and you will see me this lecture soon on creating Windows based applications for using C#. In that, we will create a calculator again, by which will we have a buttons and plus operators, so you can choose these values and then click on the operator you want to perform, and so on and so forth. Okay, so once we have these three variables, now yes, just use switch bracket star bracket close, and we use operator here. Okay, I use operator here because I want to know which operation you want to perform, based on plus, based on multiply, based on divide. Obviously, you know that every calculation will be different. So since this is a simple case, I will use case single quotations plus colon. Okay, so you can do comparison not only integers, but you can use doubles, you can do string characters, you can do comparison whatever you want within our switch statement. In this case, I'm using a character now, so we are evaluating a character. So if this character is equals to plus, you are supposed to do certain actions. Which actions are going to be? We're going to say console dot write line bracket star bracket close, let's give a semicolon, and then we're going to say inverted quotations are a result of, and then space plus num1 plus inverted quotations. Okay, and then let me just, in fact, yep, plus, and I'm going to say o double p plus, and this will be plus num2 again plus inverted quotations. Bear with me, bear with me, bear with me, I will explain everything in detail. Plus, and then inside the brackets, I'm going to use num1 plus num2. Voila. So now what we have done here is, because I want the result in this form, so I want the result to appear in this, say that result result of number one, which is going to be, for example, 12.9 12.9 plus, and the next value is going to be 12 is equals to, which will be 24.9, right? So I want the answer to appear in this format. Now do note that if I break it down inside this, this is result of num1, then this is op operator o double p, and then again num2 is equals to answer answer. So we can have something called another variable here and save this answer there, or we can do a calculation directly here as well. So I can just say this one. Now actually this is what exactly it's going to be look like, because I want the answer to be result of 12.9 plus 12 is equals to 24. Okay, if we break it down into code, we have a string, then we need a number one, because this 12.9 is a number one, and an operator which is plus, and then again I need a number two, which is another variable, is equals to going to be a string, and then the answer from the calculation. Understand? So this in fact is number one plus num number two. Okay, so this will give us the mathematical result. Now this is exactly doing the same thing. So we say result of this number one is there, so we write the number one, but because we want to concatenate this number one with this string, we added the plus sign here. Okay, so this should give us this result of number one. So whatever is the value of number one will be printed. Then after this, we need this plus operator. It can be plus, it can be minus, it can be multiply, it can be divide. We know that, right? I know currently I'm doing plus, but I want to use the same string multiple times. Understand? We said, okay, so we are using result of num1 plus, I want this operator to be printed, but there's a space here. to add that space, I've created this empty string here. So we are saying the result of inverted quotations plus num1 plus and join it with this empty string. So this is going to add that extra space after the number value. And now I need this operator. So I don't know which operator it's going to be selected by the user, right? They can do plus, they can do minus, they can do divide. So this operator value is printed here. So now we're going to say number one concatenate with this empty string plus concatenate with operator plus concatenate with and then another blank space, which is going to be space after this plus operator, and then print the value of number 2 as well. So this whole expression is going to print this thing for us. It's written in this way. So this space again is quite important, and for this space we have used this empty blank space string. And then finally equal to operator is there, so we're going to concatenate the equal operator and then we're going to print it. Okay, so if you want, let me give space before and after the equal operator as well. This should do the trick. So once this is done, once this calculation is done, I'm going to say break semicolon and control A, control C, hit the run code. See, the result of 12.9 plus 12 is equals to 24.9, exactly what we expected it to be, because this is how we break it down, and then once we break it down, we use the same thing. Got it? So I hope you understand how we format a string with the variable values in C#. So this is exactly how easily we can manage. If you want, let me just write this string again. Control C, and this we go. So I can say this result of is inverted quotation marks. Then so there's a space after this. So we say plus value of num. Okay. Then this value of num, because but then again we need a space here. So that's why we used plus inverted quotations and plus here. Make sense? Makes sense. So in fact, if you don't use the plus, so we use this string. Now operator 2, operator 2. Again, this becomes a little bit more confusing. Previous one was okay. So this is a space here, this is a space here, number 2, then we have a space here, and then we have a space here. Okay, so this is what the expression further looks like. Then finally we just add the remaining plus to create that final string. Once you have that, this basically means that if I have a plus, this case becomes true. Now I can copy this whole string, copy, paste it, bring this case a little bit back. Let's be lazy, minus, again the same thing. Now I don't need the comment, but we can leave it there for now. The result of number 1 plus the operation. Now if whatever the operation is going to be, so it's going to be minus now. Okay, if it's minus, this case will be true. It's going to do subtraction, so instead of this plus, I can just use the minus sign. Okay, so now if I have this code, let me just re-execute it. Okay, same output, no error, because again we have a plus here. So what if the user chooses the minus sign, hit the run code. Now see there's a minus here and the answer is 0.9 because the character is minus. So the switch statement will say the value of op or the operator compared with the case first one, the case second one. Since this is minus, this case becomes false. It's just like fighting something in your code. So we say, this case is false, this is not true, just remove it. So this will be ignored and it will go and evaluate the second case. If these cases match, sign of this case is equal to the sign of OP, which is minus. Since this match, it will execute this line of code. And it will do number 1 minus number 2. All of the statements remain same. Perfect, wonderful. Then similarly, we can come back here, paste again, instead of this another plus, we can say let's just have something called multiply, and instead of this plus we can use multiply now, and then just self-explanatory. Okay, this is plus here, and then again I don't need these comments here again and again, you just understand it. I can easily remove these comments, and this time after multiply we have a divide, and instead of plus we use a division. Okay, so if I have minus, it works. If I do, for example, multiply, this will do the multiplication comparison. Since this operator is multiply, this operator multiply, print the statement and do the multiplication here. Why we use these in parentheses? Because we want this to be performed mathematically. Because we are using string and plus plus plus, here the plus operator is not doing mathematical plus but joining two strings together. And here we want a mathematical calculation, and whatever is the answer of this expression, then we need it to be joined here. So we used it inside the parentheses, so this operation is performed separately, just following standard mathematical rules. Okay, and then execute. So now we have this 12.9 multiplied by 12 is equals to 159 or 154.8. Okay, perfect. So this is another example of switch in case that we can use to determine what kind of decision we need to make based on what situations we have available. Okay, so I hope this clarifies few things. Next, we need to go forward and talk more about what do we have left called loops. Oh my god, the most important topics at the end. So now we're going to talk more about loops. What exactly, first of all, loops are? Loops can be execute a block of code as long as a specified condition is reached. Simple terms speaking, looping statements are statements that repeat themselves continuously, and they will execute the block continuously in a loop until a specific condition is reached and the condition becomes false. Unlike if else statements, if the condition is true, the block of code is executed one time. However, in the loops, if the condition becomes true, the block is executed multiple times until this condition becomes false. Let me explain how this works. So loops basically are very handy way as they save the time, reduce errors, and make code more readable. Okay? That's why we use it. It's a huge help in programming. Almost every programming language you would come across, if else and looping statements. It's like they must be there. Okay, so we start with something called a while loop. What do we mean by while loop? Well, while loop is a syntax. It starts with a while and bracket start, bracket close, and within which we write a condition. Okay, it loops through a block of code. So this now means that whenever we write a while statement instead of if else, while statement will mean that we again have a condition similar to if structure. However, once the condition is true, the block is executed and it loops back to the condition. So the control from this block goes back to the condition and it again checks the condition. If the condition again is true, again the block is code is executed and control goes back again to the condition. Again, it checks the condition. If condition is true, the block is executed. Again, it goes. So this cycle is known as a looping statements or a loop. This will continue to happen until this condition becomes false. So that means once this is false, then it will break out. If else, only check the condition once stay time. If the condition is true, they execute the block of code and move out. That's the main difference between if else and while loop. They execute the block one time if the condition is true, whereas while or for or do while, they are looping statements. They basically will execute the loop continuously until a specific condition is met and this condition becomes false. So another technical part to remember here is that now we need to ensure that at a given time this condition becomes false. Okay, so this is something that we have to worry about. That no matter what, at a given time, this condition should go or and become false. Otherwise, it will create problem. Okay, otherwise it will be called as a loop. It will be continuous loop or an infinite loop, or sometimes we call it loop of doom. Means it will continue to exit forever and ever and it will never execute, never stop. I will show you in a moment how we can do that. Anyway, in an example below, the code in the loop will run over and over again as long as the value of I is less than 5. So what we do now is, this is a practical example. So if I check the code again, we now have using system. Again, we have been doing that, namespace, my application. This is what W3Schools is using, class program. So they use all the classes with the program name. We have a static void main string arguments, integer I is equals to 0. So now first we declare a variable. Okay, variable declaration is not important, but somehow it is needed, so it becomes a part of loops in one way or another. Okay, so integer I is equals to 0, so we initially declare a variable. Okay, then we say while the value of I is less than 5. So see this, it becomes a part of a loop because we're going to use this variable's value to iterate through these statements and loop through the statements. So we say that, hey, is the value of I, which is 0, less than 5? So condition becomes true and it comes here console.write line. It prints the value of I and we get the value of I. Then it goes and does the increment. Why this increment is done here? First of all, this increment represents the statements like I is equals to I plus 1. Oops, sorry, what's happening? I plus 1. This means take the current value of I, so current value is 0, add 1 to it, so it becomes 1, and then assign it back to the value of I. So now value of I is replaced to 1 after this simple addition. So this is a shorthand operator, we have already talked about this. So we did this increment, we changed the value of I by 1. Why we need to do that? Again, as I said, we need to ensure that at a certain point this condition becomes false. After a certain number of times when the looping statements have executed, this loop statement must end, and in order to end it, we started with the value of I, we use this y value in a condition, and then we increment or gradually change the value of I depending on what your logic is. You can increment it by 2 or by 3, or making sure that when we reach a certain point or certain number is reached, this value becomes that number and we can have that condition. So at any given point we need to ensure that if something is changing, so that this condition can at a one point be false and the loop will execute. So this will currently execute up till 4. The moment I becomes 5, and because we have less than condition, so I, if it's 5 less than 5, this becomes false, the looping statement executes, stops. So this is what simply a loop statement does. Okay, if we don't do that, for example, if I don't write it, okay, and I run the code, now what will happen? That it, I value is 0, condition becomes true, I is less than 5, condition becomes true, console.roylen, it will print the value of I. Next, because there is no increment, okay, the value of I is not changing, it will come back here, check the condition, value of I is still 0, less than 5, true, again print it. Value, then again it will loop around, I is 0, because we have not done any increment or any change. It will do less than 5 and it will execute this statement, and this will continue to happen and happen. So until this condition is true, becomes false, you would find that this becomes a, what we call an infinite loop, a loop that runs forever. Okay, and that's the most dangerous thing, because that will crash your system, that will create problems in the system, that will hang your system, because this program is now continuously generating trillions of numbers, and at one point your memory will be so full that your system will crash. So we need to ensure that we need to stop this code and we close this window in this case. Okay, the second way of doing is, other thing we can do is, because while again requires a condition, while loop, same goes for do while and for, they require something called a condition. And the same thing that we discussed in if else statements, condition means actually they need a Boolean value. So I can write true here as well, this will also work fine, because they don't need the expression, they need the condition Boolean value. So if the value or reply becomes true, the block will execute. If it becomes false, the block will not execute. So if I write false here, and I'm not going to use true again, this is going to crash the system, I don't want to do that. So it becomes false, we'll also run the code, but this time there shall not be any output, because integer I is equals to 0, while it has a false value, it will just come out. Okay, you can set it to true as well, again no output. You can set it to true as well, this means it will run forever, but we don't want that as well, because we want to ensure that the loop terminates at a certain point. That is why I becomes technically part of this loop. Then there's a condition here which we say, hey, I is, for example, less than equal to 20. Okay, and then we do the increment. Now again, this plus plus is not necessary. For example, if I just comment this one out, I can do something like this, I is equals to plus 2. Okay, we can write another shorthand operator which is equivalent to I is equals to I plus 2. Okay, so I can write this as well. So in maybe my system requires me to do an increment of 2, so I can run this code and check the condition. So I said, hey, start from 0, check the condition, if this is true, print the statement on the console, then do the increment of 2. Okay, so take the current value of I and do the increment of 2. So it will do that increment of 2, and hang on, why there's I 2, why there's an infinite loop, I plus is equals to 2 should add, hang on, this is a nice interesting thing, it's supposed to be plus or equal to 2. Okay, sorry, my bad, I did a mistake. It's not equal to plus, it's actually plus equal to. Okay, so plus comes first, equal to is there, because the normal syntax is I is equal to, then I plus 1. So when I write I equal to, the system is assuming that we are doing here, and then when plus 2 means, it assumes that you're just adding to the value of I, but then the next time it doesn't know what to do. So it's just taking the fresh value of I. and somehow it's messed up, so it just went on an infinite loop. So see, even a small logical condition can make or break your code, or just misplace of sign. So be very careful of that. So I misplaced that sign. Well, one thing and else we found out, so actually the signature is supposed to be plus equal to. So don't use this control X, we use this. Okay, this will generate infinite loop. Okay, error at this point, error error. So again, now we had less than 20, and because we use plus equal to 2, this means take the current value of I, add 2 to it, and assign back to I. Now this is appropriate. So now you see we have increment of 2 2 2 2 2 2 2 as well. So it's not necessary that you always use plus plus plus. You can, even though, for example, have this as well. I can do again another comment, and I can say take the value of I, and then, for example, equals to I plus 3, or I multiply by 3. Okay, this can also work for me. So if I run the code now, it will go take the current value of I multiplied with 3, assign back to I, and the loop will execute. Okay, so now it says another error. Fuck. Okay, expected semicolon. So we missed out the semicolon. We come back here, hit a run. I is equals to 0. Oh, okay. So now see what happened. Beautiful thing. Okay, something again, another logical mistake. Today my head is not in the game. What we're doing is we're taking the i's current value, which is actually 0. So we're saying 0 multiplied by 3, the answer becomes 0. Okay, so now what's happening is, because I value is 0, the condition becomes true, and come back here again, because I is still 0, multiply by 3. So 0 multiplied by 3 becomes 0. So the value actually is always 0. So that's what is happening here, right? So just give me a heart attack. Anyway, so I guess if I just change from 0 to 1, this should solve the problem. So again, logically, this is sometimes what we call a logical errors, and this is why we need to be extremely careful with loops, because if a small issue, small logical error for me should be like, okay, I take the current value of I multiply by 3, it should be like 3, and then it should go, an increments of 3. We could have that. The problem is, because the initially start value was 0, every answer multiplied by 0 becomes 0, and we end up having an infinite loop that runs forever and ever and ever and ever and ever. Means that every variable will be stored in memory. So at one point you will end up having a memory problem. Do very careful with that, and your system will start to slow down, and you will crash. So that's why we be very careful while using the loops as well, because you can easily end up creating an infinite loop, a loop of doom that can crash your system. So just to avoid this, we will start with 1. That should make sense. So now 1 multiplied by 3 becomes 3. The value I will be 3. Next time 3 multiplied by 3 will become 9. And hopefully we should not have a major problem of infinite loop this time. So we get 139. Perfect. Okay. So then finally, when there is 9, 9 multiplied by 3 should become 27. So it becomes greater than this, condition is false, it loops out. So most books will always use plus plus sign, but do remember the plus plus is not always recommended. Oh, sorry, it's always used, but it's not the only option. Okay, you can use whatever multiplication plus or operation or the increment you need for this loop to work with. Okay, as long as the condition is satisfied at a given point. So we keep an eye on the condition, we keep an eye on this initial variable, and then we keep on this increment. So this is in generally defined as initialization. We use this as condition, and then we use this as increment. Okay, so these three become the part of the loop, and then whenever you write something inside this one, it basically is considered as the block of loop. Okay. Okay. So once you understand this, this is what we do in loops. So do not forget to increase the variables used in the condition. Otherwise, the loop will never end. So be very, very careful with that. So this is how we basically use while loop. Don't worry. I will be doing more practical examples like we have done for previously after this. So we will try to do as many exercises for the do while loops, so you understand exactly what we're doing. Moving on further, let's now talk about do while loop. What do while loop means, we will be doing same thing, however the syntax is a little bit different. So it is a looping statement, it does exactly the same, but here's the difference. Do again is a keyword reserved word, so is while. So do be careful. You cannot use this as a variable name or method name or class name. It's a reserved word keywords by C Sharp. The difference between do while and a while loop is that the body of the code executes first before the condition is evaluated. When we talked about while loop, it checks the condition first. If the condition is true, only then the block will execute. However, this is like a reverse structure. So initially the code of the body is executed, then the condition is evaluated. And if the condition is true, it loops around. So what happens in this scenario is that no matter what, the loop will always execute for at least one time. So even if I set it to false, okay, if I run the code, so now what it does is it comes here, it initializes the variable, it does says do block of code and then checks the condition while, again brackets and with ends with a semicolon. So now this is the very key thing that we usually forget. You need a semicolon at the end of the while because there is nothing after the while. There is a block. So if something is continuously referring to some block of code, there's always curly brackets, and so once we use a curly bracket, that indicates a block. There's no need for semicolon here. However, this time the while doesn't have a block, so it needs to have a semicolon to end it. Now, even though when we wrote the condition false, we still get an output 0. Why is that? Because the do again executes the block first time before anything. So first it will execute the block, then it will check the conditions. Even if the condition is false, if this false, it will exit, but it has already executed the block of code. So no matter what, even if you write a direct false, the body will still be executing for one time. However, this is not the case with the while statement. So if you write false here, we all know, we did this example earlier, this will not execute any output because the condition is false. It says, hey, listen, I'm false. I don't need to do anything. And this is expected semicolon because again, I have a full stop here. So it says false, I will not execute because it's false. But do while are reverse loops. They will be repeating the statements. The logic goes the same. We have a variable we initialize, we have a block of code, we have an increment statement, and then we have the condition statement. So this is like a little reverse, but the concept is same. It will repeat, but the structure is a little bit different. We write the word do first, we start the block, and whatever statements needs to be inside the loop, we write here, and then we write the while condition after the block is closed, bracket start, and we provide a condition, which can be any expression that we basically use. So in this case, it can be I is less than 5. Same thing. So if you run the code, it will go and run the code. So if you are executing it multiple times, you might not feel the difference at all because again, the same output can be generated with the while loop. So usually that's why we end up using while loop more often, or the for loop, the third one. However, at certain situations, we need some code to execute first, like like in the game or in situations where we are doing multiple attempts or playing anything, where at least the loop needs to execute once before it can re-execute multiple times. Understand? So that is why we say we need to use in those situations a do while loop. So the example where the loop will always be executed at least once, even if the condition is false, it will execute. Do not forget to increase the variable condition. That's the key thing that we want to ensure, that make sure you do not forget to change this variable and value. Otherwise, again, you will end up with the infinite loop that never ends. Okay, now, so let's talk about C# for loops. Now, similar to while and do while, for loop also does exactly the same. It loops around multiple statements. Okay, and similarly, it will loop until a certain condition is satisfied. So for loop again behaves exactly same of as the while loop or do while loop. However, there's a difference in syntax, and then that's the only key difference, in other words, between these looping statements. So for example, for the for loop, as name suggests, we use the for word. Again, the for word is a keyword in the reserved word, so you cannot use this as a variable name, class name, or a method name. However, now you note that the syntax is quite different. Okay, so it's a the syntax basically says that in the first part you need statement 1, then semicolon, then there's a second part containing second statement, again a semicolon, and there's a third part containing statement 3. Now, as compared to previous while loops, we only had a condition. We wrote explicitly that you can write a condition here. However, for the for loop, instead of word condition, they have written the word statement, and there's a very good reason for that. And the syntax is basically divided into three parts. Instead of just writing a condition, it contains now three statements having separated by a semicolon, which is again quite important because this means that this is independently a complete Java C# statement. Similarly, statement 2 again behaves like a complete independent statement. And then there's a statement 3, which again behaves like a complete independent statement. However, there's no semicolon at the end because there's the end of bracket, which identifies this as a loop ends here. So this is a specific syntax. Okay. Statement 1, statement 2, statement 3, or part 1, part 2, part 3. Now, this behaves in a very specific manner. I will talk about this with this example. So when we write for loop, note the three statements that we've written. Be mindful that this is not the actual, or this is not the what we call exact thing. Okay, exact thing means that this is not what always is the same scenario. Okay, so for example, the second part is a conditional statement here. In while loops, we specifically mention that you need to have a conditional statement here, which requires true and false. However, for loop, they said, hey, you need a statement here. This statement typically 90%, 99%, in fact, we write as a conditional statement, but you can write any other legal C# statement here as well. Similarly, you can write any other legal statement, means you can even write console.write within these lines and it would work fine. Okay, so how does this system work? So for example, if I come back here, and if we execute the code, you will see that it loops around, prints everything fine. The difference is that this time, or 99% of time, you would use for loop with this particular syntax. 99. Now 1% people change it, it depends on them. However, the 99% people target this and we try to focus on the same structure. So the statement 1, or the first part, basically involves something called initialization. So we initialize the variable inside the for loop instead of before the loop. Then we have a conditional statement. Then we have an increment statement. So the initializing, in condition, and increment all written inside a for loop. That's the major difference here. If I were to write the same thing with the while loop, you would note that we would initialize integer, for example, w is equals to 0, initialize a variable before it. We will write a while loop and we will say w is less than equal to, for example, 10. We write a condition, we start a block, and then we print some statement called console.write line. And then, for example, w is printed here, semicolon ends here, and typically we do the increment here. So this becomes a statement of, or the syntax of, a while loop. We have initialization, we have a condition, and then we have a block of code, and somewhere before or after, depending what your logic is, we have an increment operator. So all are actually written as a three separate ways, in three separate lines, in other words. For loop, all are written inside the parenthesis of for loop body. That's the major difference. That's the only difference. Now, as long as this condition is true, this second part usually requires either true or false. So as long as this part is true, this statement will execute. Once this becomes false, the block will add. Same as while, same as do while. Okay. So this initialization is done, but now if it is supposed to repeat, how many times it's going to repeat this, how many times it's going to repeat this, how many times repeat this. That's the key thing that we need to understand. So if you come here and let me write a comment, and we say steric backslash, we have a multi-line comment, it works with this way. So first part, I statement 1, state statement 1, or initiali initialization part is executes one time only, which is actually first time. Then we have second statement, state statement 2, which usually is condition. This is again every time, okay, until false. So that makes sense. So it checks for the condition every time the loop iterates. It will re-execute this line of code. Then the third is execute the block if condition is true. So now this is a different thing. What happened to increment? So increment doesn't get executed until the fourth step. So now statement 4 or statement 3, increment, increment. Okay, this is what happens. Do the increment, and then Step number 5, if I put it down, basically says that repeat, repeat step 2. So this is the basic life cycle of a for loop. Statement 1, which is the first statement, initialization part, executes first time and one time only. So first time when the loop executes, for the very first time, it executes the first part. Okay, the first part is executed, and that's the only time it gets executed. Then it checks the condition. If the condition is true, then it executes the block of code in its third step. So the third step means that it execute the block of code. Okay, so whatever we have written inside the block will be executed. The increment will not execute this time. Once the block of code is completed, the iteration goes back to the for loop, but this time it executes the increment, statement 3. Now it executes the statement, and then once statement is executed, repeat step 2, which means go to the step number 2. Statement number 2 is check condition. So after increment, it checks the condition. This is how a for loop typically works. So the increment is in fact done at the last time, not at the first. And that is why typically, if you even see a while loop, we write the increment after the statements have been written, just to match up the logic. Okay. So however, we can write this before it. It depends on what logic you want, but the typical loop logic is the increment is to be done later on. So here, in integer I is executed first and only one time. That's it. Semicolon means statement ended. Check the condition. If the condition is true, execute the block of code. The code gets executed. Once it is executed, then it goes back, and this time it again does the increment. So the increment is done as a fourth step. Once increment is done, then it goes to this statement, checks the condition. If condition is true, it executes the block. Then again it goes back, does the increment. So this is how it basically cycles, and it completely ignores the first part after the first execution. Okay, so looping again does the loop, but this is how the syntax typically works. So this is what we need to understand. This is what it's trying to say. Statement 1 executed once, 2 defines the condition, 3 executed every time after the block has been executed. So after the block has been executed, okay, so this means that once the block has been executed, now the statement 3 part will execute. So in this case, statement 1 sets a variable before the loop, statement 2 defines a condition for the loop, and if the condition is true, it executes the block. Then it does the statement 3 increment, and after that again it checks the condition and goes for it. Since we now said, okay, remember now basically if you understand this, the why we use the word statement here, statement here, statement here, means any legal statement can be written here. So for example, you can come here and you can say, hey, initialize a variable I is equals to 0, I is less than equals to 10. Okay, so instead of increment, now we can write I is equals to I plus 2, or shortened operator, that would works fine. Because it needs a legal statement, this is also completely fine, as long as it changes a variable which satisfies and makes sure that at one point this condition becomes false. Okay, so this loop basically works in this manner. Similarly, if I come here, let me give you one more example. If I copy this code, Control C, and if I, let me just move it here. If I want, I can write console dot write line here. Okay, and I can say initialize initialize, and instead of integer, I can write, for example, integer x is equals to 1 here, and then this condition can become x is less than 5, and let me do the increment x plus plus. Okay, if you declare two variables of the same name, again it will complain. So do make sure that if you are working the two variables, there cannot be two variables with the same name. So that's what it basically needs. So if I again go for x here, and if I run the code now, okay, so it will now this will be a completely independent loop, this will be independent loop, and this is an independent loop. Now what's happening is we print a word initialize, and it's only printed one time. Why? Because this statement has been executed 4 times. After that, initialization we have done separately. In place of initialization, we have written another legal statement within C#. So any statement that you can write anywhere else actually can go inside here, no problem with that. So console.writeln initialize basically means that we have written a statement inside the block of a for loop. But because there's a semicolon and it needs a statement, this is completely valid. Hence, we have a condition statement. It checks a condition, and we can write same thing here as well. So if I want, I can come here, Control C. Let's be a little lazy, Control V, but making sure there is no semicolon at the end. Okay. So this semicolon is now not needed because the block is closing here. So if I have check now, if I execute the code, this will ensure that this statement also gets executed. But now where's the increment? We need that increment, right? So we can do this increment here, plus equals to 2. What this will basically allow us to do is it will increment change the value of x until this condition, for example, is satisfied, and it will run the code. So now if I execute it, see, we have initialize, initialize. Okay. Why this multiple initialize? Because of this. Okay, let's just change this word. INCRE, increment, or what we can say statement 3, right? STATE, statement 3. This can be statement or initialize as it is. So now if I run the code to make a little bit more sense, so we have initialized. So this part gets executed only one time. And this is a very valid statement. Sometimes we ask this in interview questions, as in exam questions and midterm questions. If you're giving online tests or certifications, these kind of things pop up. What is the output of this code? Okay, so sometimes we confuse, hey, it's supposed to be initialization. As I said, 99% time we do that, but that doesn't mean that that's the only way. With a for loop, you need a statement, and that statement actually can be any statement. That's why this statement is also legally allowed, can be written here. And to make things more easy, we always try to do initialize, and this part always gets executed one time. However, condition is there, and then the second part again needs a legal statement. So I can write any legal statement here as well. Okay, so I can write any legal statement here, and I can say go here. So see, statement 3, statement 3, statement 3, statement 3, statement 3, statement 3. Perfect, no problem with that. If I want, I can say plus x, meaning that print the value of x. So since this is a legal statement, this would also work fine, and it will change the value of this as a value of x, same as this one. So this also is what we refer to in terms of for statements. Now let's talk more about something called nested for loops. Okay, a nested for loop, nested while loop, nested do while loop all have the same concept. Okay, again, all three loops basically have the same purpose. It's the syntax wise the differ is and how we write them. 99% you again will always encounter for loop of being with the same syntax, but do keep in mind you can write any other legal statement here. Now, what do we mean by nested loop? A nested loop means a loop inside a loop. So we have a loop already which we call outer loop, for example, and then within that loop we have an outer loop. And why is it important to understand? It's similar to if else if. Okay, so where we write multiple else if statements. So if else, then again within that else we have if else, then within that else we have else if. So it creates a nested structure, something inside the structure. Same thing goes here. We have an outer loop for outer, and then we have something called for inner loop. How do these two differ, or how is the logic here? So as we execute the outer loop, okay, if you now note how nested loops are working, that's the key thing to understand is for every single time an outer loop executes. So if outer loop executes one time, the inner loop will complete all its internal cycles. So if an outer loop is supposed to execute, for example, one time, and the inner loop is supposed to execute 3 times, you will note that one time the outer loop executes, the inner loop executes for 3 times. Then once it completes its cycle, the control goes back to the outer loop, and the outer loop executes for the second time, and the inner loop will again start fresh, because now it assumes that the loop is re-executing. Okay, because it's re-executing, it will reinitialize the variable, and it will recheck the condition and start from the 1 again. So hence the inner loop again gets executed from 1. That's the key difference that we need to understand. So if I set this to 4, and if I set this to, for example, let it be 3, and run the code, this means that the outer loop executes 4 times, but the inner loop will complete its 3 times cycle for each time the outer loop is executing. So inner loop executes 3 times when the outer loop executes first time, because it's inside it. So once integer I is equals to 1, condition let it be less than 4, condition becomes true. So it needs to execute this entire block, whatever is written inside the for loop. So it prints outer loop, Then it goes, hey, it's another loop. So then another loop is executed. Once this loop gets executed, it will complete its cycle. Initialize integer j is equals to 1, j less than equals to 3, and then it will go and print j plus plus with console.write ln j's value. So this loop actually executes every single time the outer loop executes. This is what happening in the nested loops. Same goes for while loop. So you can have a while loop, and then inside it you can have a for loop. You can have a for loop, and inside it this can be a while loop. No problem with that. So understand that when we use a nested loop, it means that every time the outer loop executes one time, the inner loop completes all its internal cycles until the condition is satisfied. So if we set it to 5, we run the code, and so we see that outer loop executes one time. So this outer is printed here, outer 1. So means that outer loop is executed. The first time when it executes, the inner loop starts again from 1 and executes until the condition 5 is met. So it executes 5 times. Then once the condition becomes false, the loop body ends, the control goes back to the outer loop. Now it will execute for the second time. When this executes for the second time, it prints outer loop 2. Then again, because now it is coming from the bigger area outside of the box, this loop again gets initialized. So this statement will actually reinitialize. That's the key point here to understand. Because it will reinitialize, this loop will again start from 1. In this case, once the loop has started, this statement does not get executed again. But here it is re-executing because it's inside another loop. So technically it completes its cycle when the condition is false. The block of body comes out. When it comes out, it control goes back to the top. It starts to execute again and then come back here. So because it control goes outside this loop after the condition and the control goes back to the outer loop, it comes back in. Now it says, hey, I need to reinitialize this variable. That is why we say always inner loop 1, 2, 3, 4, 5, inner loop 1, 2, 3, 4, 5, inner loop 1, 2, 3, 4, 5, inner loop 1, 2, 3, 4, 5. Okay, and outer loop only 1, 2, 3, 4. This is how nested loop works. I know sometimes it becomes a little confusing, so don't worry about that. I know what we're going to do is we're going to try to do some of the exercises. So just like previously, I have set up few exercises, and we will try to understand these nested loop structures with few all around 8 to 10 different exercises very quickly this time, because we already have the basic understanding, and we will try to generate this kind of patterns and structures using nested loops with single loops and so on and so forth. Okay, so let's begin with this, doing these exercises. So now we are back here, and as discussed previously, I already have created some task lists that we want to be developing. So first program we need to develop is called write a program in C# to display the first 10 natural numbers. Now again, this is something very simple. We have already done that, but since we are doing it, let's just create it very quickly. So first thing we will be doing is writing using, and we are going to say, hey, I want to use system. Then we're going to name it namespace, and again I'm going to use the same namespace. Okay, block start, block close. Then we're going to create the class name, and this is going to be, for example, task dash task underscore 1. Remember, dash is not, minus sign is not allowed. So we do that. Then we have static, we have something called void, and then we use m capital main bracket start bracket close as string square brackets arg for a variable name. Move your cursor, create a block, there we go. Then we create integer, and for example x is equals to 0 semicolon. Then let's just use the while loop, and then we're going to say x less than equal to 10. Okay, block start block close again, and then we're going to use console dot write method bracket start bracket close inverted quotations, and we can say the natural number num number is, and then we're gonna go hit plus, we're gonna print x value, give a semicolon. That's it, that's all it takes. So to print any number, we basically need to use this while loop. X is equal less than equal to 10. The condition becomes true, loop it. So now it's going to print this, and then it's going to give us a range error. In this case, because we are using this compiler, it is giving us a range error. Otherwise this code is okay. The range error means that this condition is never becoming false because we did not use x plus plus hit a semicolon. So in this case, this one compiler, online compiler, gives us that this is like exceeding the buffer length, and it's infinite loop going on and on and on forever and ever. Okay, so that's what I wanted to show. If you go for W3Schools compiler, and if you create some kind of a loop, it will just continue to print outputs. But different compilers have a different behavior. Usually this one is more natural and realistic behavior. This, because it's online, so it detects and it gives us some customized message. Sometimes it's quite useful as well, so that's why we tend to use it. Anyway, so this is how you basically print any number, any given number of times. So in this case I'm 10. So if I want to print 100 numbers, all I need to do is just change this condition here, and now if I go and hit run, it will print this number 100 times. Obviously we have used write method here. If I use write line, it is going to print everything on the new line of 100 times. So see, we printed 100 lines just using this 4 lines of code. Okay, so that's what looping allows us to do. It allows us to print iterative statements or do iterative operations, execute iterative instructions that basically are same, but just are changing some parameters. Based on that, they make different decisions. So that allows us to repeat those statements and with a very little amount of code. So this completes our task number 1. So I'm just going to hit Control C to this, go back to my Word file, and then this is going to be my solution. Oops, not this one. Control V. Oops, let's just not kill this, paste text only, and this is just adding so many extra lines we're not supposed to. Anyway, so I will just print the output and do the formatting later on. So that's task number 1 completed. Now little bit more different task. Write a C# program to find the sum of all the first 10 natural numbers. Okay, so the idea is that if I take all the first 10 natural numbers and add them together, now how should I generate this output? Okay, so this basically becomes more interesting, that it's not only just generating the numbers, but this time we need to do some form of calculation as well. Okay, so we say no problem, let's just come back to our code. Okay, once we are here, let's just generate a new version of it. For example, let me bring it in, Control A, delete it. Again, we start with the same thing. So now we're going to say, listen, I need something called using SY system semicolon namespace, and then I'm going to use the same namespace that I've been using, block start block close. Inside this we will create a class, and this time it's going to be task underscore 2. You can name it whatever you want, but as I said, I'm just going to use this static void main string square brackets for array arg block start block close. So we have this basic code available to us. Now the idea is again that we need to have an integer, and we're going to use this integer for our for example the looping purpose. So we can say integer x can be there, and then comma, we're going to create something called integer sum is equals to 0 semicolon. Now what this means is that we declare variable both as starting from 0. Okay, so this is called multiple declaration. Then let's just create, for example, output of it. So how do we want the output to be there? So we're going to write for loop, and we're going to say integer, or we already have integer, right? So we're going to just say x is equals to 0 or x is equals to 1, depends on how you want to start it. Because we need natural numbers, we want to sum. If you want to start 0 or less, it's up to you. So less than equal to 10, because that's what the question asks us to do. And then we're going to do something called x plus plus. Okay, block start block close. So we have a loop. So now basically this loop will iterate 10 times. Okay, same as what we did with the while loop. Here we had x is equals to 0 condition, and then it will loop. So this time again, we have an initialization statement inside the for loop. We have a condition that if this, again, let me just increase the zoom for it so that we can read this better. So now we have integer x is equals to 1, x less than 10, x plus plus. Now inside this, what we need is, first of all, we're going to say, listen, let's just take this sum variable is equals to, I'm going to say sum plus x semicolon. So remember, our task was that we need to write a C# program to find the sum of first 10 natural numbers. So that means that the first 10 natural numbers are these ones. So we need to add all these natural numbers together with each other. So the first number is going to be printed is going to be print 1. The next number is going to be printed is 2. So 1 plus 2 becomes 3. Then 3 plus 3 becomes 6. And similarly, it's going to add all these numbers together. Okay, so that's what exactly we're doing. So we say, hey, sum starts from 0. So take the current value of sum, which is 0, and add it with the value of x, which will start from 1. So 1 plus 0 becomes 1. So that's where our sum 1 comes into play. Next time when the loop iterates, the x sum is now 1, right? X again becomes 2 this time. So 1 plus 2 becomes 3. And the answer is saved in 3. Then again x becomes 4 now. So 4 plus the value of 3, and then similarly it goes and iterates itself. Just like we want here. So 1 plus 2, 2 plus 3, 3 plus 4, 4 plus 5. Whatever the answer comes into play, it just keeps on adding to the next value. This is a simple equation to do that. That's it. That's all it's what we required. So now we're going to say, listen, boss, let's just print output console dot write line, and then we're going to hit brackets, inverted quotations, the sum of nat natural number is, and then we're going to do plus and natural number plus x. In fact, let's just move is and equals semicolon here. So we're going to print here everything that we want to basically print. Okay, so this just solves one our problem. Finally, once this is done, outside the loop we're going to print the console dot write line, bracket start, bracket close, sorry, semicolon, inverted quotations, the final sum is, and then we're gonna plus the sum value here outside of the loop. Why we need to do that? Because this sum will continuously iterate and add all the numbers together until this condition is satisfied. So once this is satisfied, this number will have the final value. Once this number has the final value and the loop exits, now we need that final value of outside of the loop. So we're going to print the value here. So in fact, let's just move this, the natural number x, we're going to hit run. Compilation fail, and it says console system.console does not contain a definition of a write line. Okay, so it's telling us where's the mistake. So we did a spelling mistake, my boo-boo, and then here we are. So we have a natural number 1 2 3 4 5 6 7 8 9, and then the sum is 45. Perfect. So if you want to make sure the first 10 numbers, just use equal to sign here. So now see, this is a sometimes as we call it logical errors. If you want the 10 number to be there as per our requirement here, that the 10 number should be 10 and the sum should be 55. So that means that we use an e less than sign. Less than means it will be less than 10. So it's running up till 9. Now to get it to ensure that it runs up till 10, we need the equal to operator. Once you add the equal to operator and run the amount, now you get 1 2 3 4 5 6. These are the natural numbers, and then the final sum is 55. Voila, as simple as easy as it gets. So we select it, come back here, and then we're going to say, nope, I don't want this. Control, this is supposed to 55. I don't want this. Let me just come here and keep the output here. So we get the output, and now we have the generation. Again, I will do the formatting later on. Let's move on to the next question. Write C# program that displays the sum of n natural numbers. Okay, so test data is that, for example, if we give 7, so expected output will be the first 7 natural numbers, right? So this time the 7 level is there. As simple as that. So we can have, for example, integer n is equals to 7, semicolon. So we use the same program, but this time instead of 10, we're going to use n here. Okay, so n basically means that x is less than equal to n. So if I set it to 10, this means that x will be less than equal to 10. If I set it to 7, x will be less than equal to 7. That way, it's going to run this program all along, okay, up till that particular number. So next program, we just had to change this small thing. And if I run the Xcode, now it runs 7 times and does the calculation for that. So this is exactly what we expected here to be. So if I wanted to run 7 times, it is 7 times. You can even ask for a user input at this matter. Okay, so if you are, because I'm using an online editor at this point, they do not, I believe, allow us to take online input. But if you want to take an input, you can use console.readline and then use that method to take input from the user, as we have discussed previously. So whatever the number user gives is basically saved inside this value, and then the loop will run that number of times, printing and adding the sum of that number value. Capish? Excellent, Tomanto. Again, if you want, Control C, I copy this code, bring it to my Word file, and now we have the code here. Control V, I get this 3 programs done very quickly. See, so if you do more practice. That's why I've been saying, if you want to learn programming, try to practice as many tasks as you can. There are many websites that allow you to have these tasks. The more tasks you do, the better you get. Okay, so for example, let's just create this one, table printer. Now this is a typical program that we use with every single system. Let's create a multiplication table very quickly. So again, I create a new page, open up the one compiler, get rid of everything else, and let's just start with using system. And then this time I'm going to need the namespace again. I'm going to use the same namespace, block start block close. We're going to create class, and I'm going to say table block start block close. We're going to have a static. Okay, and then we're going to create something called void, means this method is not returning any type. Bracket start bracket close, we create a string data type with an array symbol, a variable name, block start block close, press enter. We have this. Wonderful. Let's use for loop. So we create a for loop. Inside the for loop, we create a variable x is equals to 0. Okay, x less than, let's just make it to 12. So it starts from 12. In fact, let's not use it from 0. Multiplication, if you multiply anything with 0, becomes 0. So it just messes up the whole equation. So let's just start with 1. Then I give a semicolon here, and then an x plus plus. Okay, so now again, this means that for loop will loop statements, we provide initialization at the first part. We provided a condition that when this value of x is less than 12, you execute the loop. The moment it becomes 12 bigger than 12, you exit the loop. And then we ensure we do x plus plus, so it keeps on changes this variable value. Simple as that. Beautifully done. Then let's just use console, oops, not constant, console dot write line, bracket start bracket close, semicolon, inverted quotations. Now the output we want is something like this. It's going to be, for example, say 5 multiplied by 1 is equals to 5, right? So this is the typical way we represent multiplication. So I want exactly the same output. So I'm going to say integer number number is equals to 5. So first we need the table or multiplication number that we want to generate. So I have number here. Okay, so I'm going to say, listen boss, first I want this num number because that's my first value. Then I need this multiplication sign. So because this is a number, a variable that I've used here, in order to use a variable with a string, we add a plus sign. Inside inverted quotations, we use this x. Okay, so this will ensure number x is printed. But see this, we have given a space here. That space is not here. So it's going to concatenate and join these two things together. So we need that space. So we add that space inside the inverted quotations just to spread the things out very nicely. So it's going to print a number plus join it with this string that has already spaces. So this first two characters are printed. Then we need this value number, which is actually coming from the x value. So we're going to say, listen, now join it with x. Okay, so this is going to join it with x. So first time the loop executes, the value of x is 1. It's going to come here, the number is value 5 plus this x as a string is printed plus the value of x is printed here. Then after this we need this equal to sign. So again we're going to do the same thing. We're going to say, listen, after this x, plus it, concatenate it with space equal to space. So again we added a plus here. So now note there is a 2 plus after this x, one before, one after. So this plus is used to concatenate this string. Then whatever is the outcome of this entire string is going to concatenate with this thing. So now because of this, we're going to use this equal to sign this value. Finally, we need the actual answer. So for that, we're going to say, listen, plus, and then I will do something called brackets, and then I'm going to add number multiply by the value of x. Okay, so why we gave these brackets here, we have been talking about this for a long time, because we want to ensure the operator precedence. This is going to concatenate the string. This will ensure that the mathematics is done first, this multiplication is done first, then it is concatenated. At this moment, these brackets are not necessary because multiplication has a higher precedence, so it will do multiplication first anyway before it's going to concatenate. But it's always a good practice to simplify your equations and make it a nice and clean way. That's it. So to print this string, this is what basically it looks like. So we need a number, so we use a number. We need an x in a string form, so we concatenated using the plus operator. We concatenated that string with this x. Then after the x, we needed 1. So if I run this code, let me check before I talk. Perfect. See this? We get a nice, beautiful looking output. Remember these spaces here. If I don't give these spaces inside the inverted quotations that I do for equal to and x, now if I run it, it works fine, but they are quite joined together. It's like difficult to read what the hell is going on, right? So when you give space inside the inverted quotations, it makes sense. Space outside the inverted quotations doesn't really matter. It's inside that matters. So now we get a very nice looking multiplication table simply by using a single loop and ensuring that we print the statement in a particular manner. So the loop will ensure that the variable starts from 1. If the value of x is less than equal to 12, execute the body, come back here, do the increment, change the now value of x by 1, again check the condition. If the condition is true, execute this statement. Then come back, do the increment, and repeat the whole goddamn process. Got it? Capish? And I hope you understand how we have formatted this string to print this nice looking output. That's it. So we again take this code, Control C, I go back to my page, and this is what I expect when I hand over the manuals to my student. These are what you're supposed to do. Solve these equations and make sure they're formatted nicely, not what I've done here. This is very poorly designed, but again, copy pasting from internet has that effect. So I will create maybe probably a style somewhere, and then we apply the quick styles to it so that it's formatted nicely and looks properly. Anyway, so this is done, and this is multiplication table, and then various different formats that let's just print a table on one single line. If I need to do this, okay, that print the table on a one single line, what do you need to do? Only one thing needs to be changed. Just from this right line, make the print right method. Voila. And then obviously we need inverted the comma marks that separated. So see this, there's a comma here that separates everything. So for that comma, after the multiplication has been done, we again do concatenation, inverted quotations, add a comma, and then add a space after it. So when I run the code, now we have a comma and a space, and then again another quotation. That's all it needs to do. Okay, so if you understand the basic logic of this, you would understand that creating any form of output anyway is very easy. Write will add simply output without the new line, but when you write the word line, it means add the new line inside the code. Wonderfully done. Okay, so I hope that explains few things. Let's just do one program more that prints our number in a particular order. So this is something that we love to do. This one. So write a program that prints the triangle in this form. Okay, the sterics in that triangular form, or what we call the right angle form. How do we now do that? Okay, so for this we basically need nested loops. This time I'm going to be a little bit lazy and I'm going to leave everything, delete everything, name this, for example, namespace myself that I've been using, Dr. Zeeshan C Sharp, public class, and then instead of a program, I'm going to use triangle. Triangle. Everything else needs to be same. Let me just delete that. Okay, so we're just using the same boilerplate. Now, how do we print this steric pattern? How do we print this steric pattern inside this? So now note the key thing inside the steric patterns. What you need is that first time the loop executes, obviously we're going to loop use because it's going to repeat the step. But the first time the loop executes, it needs to just print one steric. Next time it executes, it needs to print two steric. Next time it executes, now it needs to print three steric. Fourth time it executes, it now needs to print four sterics. Okay, so that means for this particular purpose, we're going to need something called nested loops. Okay, so to print the nested loops, we're going to do create few variables, integer I, comma j, comma row, semicolon. Okay, so I take three variables here. Bear with me and I will explain the logic much detail in this case. So now we're going to say, okay, once we have that, let's just create a for loop. Inside the for loop, we declare this variable I is equals to 0. Oops, 0 this one, semicolon, and we're going to say I less than equal to ROWS, the rows we want. Okay, semicolon, and we're going to hit I plus plus. bracket start, bracket close, standard for loop. This is an outer loop. Inside this loop, we want another loop to execute. So we create another for loop, and I'm going to say this variable j is equals to 1, semicolon, j less than equal to I, semicolon, and then j plus plus, block start, block close. Now check. So let me do one more thing that I love to do. End of for, or in fact outer for, and I'm going to use end of inner for. Well, these are just simple comments, but what this will tell me that, hey, this bracket is where the outer for loop ends, and this bracket where the inner for loop ends, because you can end up having hundreds of lines. Sometimes it becomes extremely confusing and difficult to debug where the block is starting, block is ending. Okay, so leaving these comments will actually help you understand a lot. So end of main, so I know that this is basically end of main method, and then I can have end of class and end of namespace if I want. It will ensure that our code is more readable. We have an outer loop, simple as that. And then now inside this, we create something called console dot write, bracket start, bracket close, semicolon, and print static. Okay, so this goes inside the inner loop. Once this is printed, now we come here and we're going to print something called console dot write again, and this time we're going to inverted quotations backslash n. Voila. Now let me explain the logic to you. Okay, bang bang. Okay, since we need the output in this manner, so that means the loop that executes will only need to print the static one time. Then it needs to come here. This time it needs to print 2 times. So we need a mechanism to repeat the loops counter, or change the loops counter and increase the counter every time the loop executes for the next time, right? So the first time it executes, the counter is 1. But now next time it executes, it's supposed to execute twice. The third time it executes, again it's supposed to print 3 times statement. The fourth time it executes, it's supposed to print 4 times. So see, every time the loop is repeating itself, it's actually printing more and more lines. So in this case, the loop is printing 4 times. And that is why it is going to print maximum 4 stars. So it's repeating 1 time, first time only 1 star, second time 2 star, third time 3 star, fourth time 4 star. Why 4 time? That because in our code we have told it that the row is there, and then this row is going to be telling us the points, how many rows we need. So we're going to initialize this row variable to, for example, 4, and when you change it, it will change it. So this will tell us number of rows to print. Okay, so let me just execute this code to double check, and we get error as always, the crap. Okay, so it says the name does not exist. Okay, at this point, line 13, the name does not exist rows. So if I come here, I have a row, integer row variable has been declared. This variable has been initialized. We have talked about this declaration and initialization. And at this point, line 13, oh, I have, sorry, my bad. This is row, and I named it as rows. And that's what it says. That's why it says, hey, this variable is not recognizable. Once we execute it, voila, it executes. Now let me explain the code again. So what's happening here is that there's an outer loop. It starts from 0 and it says I less than equal to row. So basically the outer loop will execute 4 times because that's supposed to happen. So this is where line 1, line 2, line 3, the 4 rows are coming into play. Understand? Capiche? The logic comes here in this inner loop. The inner loop again starts with the 1, and then we say this point here, j is less than equal to I. This is what creates this variable outputs. This means that the for loop will execute only the number of times based on the value of I. So the first time this inner loop executes, it starts from the 1, j is less than equal to the value of I. What is the value of I? So the first time the loop is executing, the value of I is actually what? Yeah, 0. So this basically means that, in fact, if we start from 1, it makes a little bit more sense. The 0, actually, there's a blank line here. So if I run it, See this, it jumped up actually. So the first line actually went blank because of my 0. So now if I re-execute, it sees it's there. So 0 was okay, but 0 will just add a blank line because 0 is absolutely nothing. So if I add a 0 again here, now you'll note it will jump to the second point. If I run it, there's a jump, right? Because it added a 0 static line here, which we don't want. So we just come back here and add a 1 to it, and hopefully that makes much more sense. So these are small logical errors that you need to understand and rectify within your code. Once you are here, we say, hey, I is equals to 1, I is less than row, so execute 4 times, perfect. So then j is equals to 1 and j is less than equal to I, which for the first time this is executing, it's supposed to be 1. So that means j also 1 and less than equal to 1. Condition becomes true. Console.write comes here. It prints the static one time. Then the loop ends. Okay. Why the loop ends? Because then when it goes back here, it adds j plus plus 1, j becomes 2, and if I come inside here, 2 is less than equal to I, which still is 1. Remember we talked about outer and inner loops. So outer loop will execute one time, the inner loop will complete its entire cycle. So in this case, the inner loop also is supposed to execute the only amount or the number of times the outer loop has already executed. Since outer loop is executed for the first time, this is only going to also execute one time. Hence, this is 1, j now becomes 2, the condition becomes false. This block ends, the control comes here. Now we need to add a new line. So we use \n for this new line. So the control comes from this point to this point, the second line. Then control from here goes back to the outer loop. It does the increment. So I previously was 1, now becomes 2. I is less than equal to row, condition becomes true. It comes back to the inner loop. I j is equals to 1. This variable starts afresh, reinitializes it. Now j starts from 1. The value of I is 2. This condition becomes true. J plus plus will now be executed for the first time. So it's going to print the static again. Then again it will go here. Plus plus j becomes 2. Again this condition becomes true because the value of I for the second time is 2. So it's going to print the variable again. So this is how we print the variable. So we are making this inner loop execute the number of times the outer loop is executing. So the outer loop has value 1, the inner loop executes 1 time. The outer value has loop 2, the inner value executes 2 times. The outer loop has a value 3, the inner loop executes 3 times. The outer loop has a value 4, the inner loop executes for the 4th time. Simple as that. Beautifully done. And this is our code to generate this wonderful little static program. Understand? I paste the code and my task is complete. So as a student, I would say my submission is done. Let's just move on to another nested loop example. And we say, okay, if this is the case, and I want to print the number called 11123, now what would you? So now let's create this program similar to that, but this time we have a very simple logic that instead of printing sterics, we actually need to print something called 123. Now, how do we go about doing this? Okay, the logic goes very simply the same. So what I do is come back here. If you want, let's just copy Control C. Let it be a little bit lazy. Create another window of this. Okay, delete the previous code, paste it. So now again I have a using system namespace same that I've been using, class triangle, and then this I can for example say triangle underscore or triangle num, right? So just change it to num. So make sure we have a different class name. Then public static void main with capital M string there, bracket signs, so everything basically remains same from the previous programs. So we create integer I, j, and row, 2 variables. Okay. If you want, you don't need to use this variables here. So for example, if I remove here and I just create an integer row variable and I declare this rows, for example, is equals to 4 on this line, which can be perfectly normal. And I can do that as well. Okay. So delete this. This comment can now go Control X and we're here. So basically we are saying that listen, we need this comment here. So once this is integer 4 is there. Now where did I and j go? Remember at 4, we can create I is equals to 1 integer and integer j is equals to 1 as well. So in previous example that we did, we declared I and j as a separate variables above and then used I is equals to 1 inside the for loop. So declaration was done here, a declaration was done here, and initialization was done here. Again, perfectly legal. Just one more example of how we can use statements inside the for loop. Or in a typical way, we just use integer I is equals to 1 and j is equals to 1 as well. Now remember, we are starting with 1 because we want the numbers to run from the value of 1. That's it. So now what we need is we need to print the value instead of this j, we will print the value of, for example, j. That's it. So instead of steric, we have printed the value of j. Then backslash n will go as it is. Everything remains same. If I run the code now, see what I get: 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. Okay. Why is that? Because this time we told it that, hey, print the value of j. So we have an outer loop and then we have an inner loop, just like the previous example. So inner loop will have j is equals to 1, j is less than equal to I. Now again, keep an eye on this because of this, we get this pyramid or triangle kind of structure. J is less than I means that first time when the loop, inner loop executes, it will run only the number of times we have I. Okay, then it will execute based on that. Similarly, if I is 1, then the inner loop will execute one time. So that's why we only get it one time. When I becomes 2 next time, then the inner loop will start and run 2 times based on this condition. So we get 2 times value here. Then the third time I becomes 3, it will execute 1, 2, 3, 3 times. Okay, so this is how we try to execute and ensure that our code runs properly and we get 1, 2, 1, 1 values, whatever we want to basically print with them. Okay, simple as that. So now we have another example of how we do these things. Similarly, there are many other examples that you can follow and you can work on to create more accurate patterns. So for example, if you need 1, 2, 3, 4, 5, 6, all different numbers, or want to create this kind of a pyramid shape or create this kind of steric shape, how do we do that? So we just use these nested loops, but we play with them how we want to do that. Okay, so try to go through these programs. I will, as I said, should be sharing this document as well as soon as I complete it. I've been little bit lazy on that, procrastinating too much. But as soon as I do, I will share this document on the channel, and then you can access it. Then probably follow along, do as many tasks as you want, and only then you can develop the logic. Don't think these are repetitive tasks. The more programs you do, the better you get. The better you get, the logically stronger programmer you become, and you would be capable of solving more complex programs. Because programming is all able to understand how to crack the logic and solve a problem by writing a code. Okay, so to go through that process means you do as many programming tasks as you can, even how minuscule or simple they may seem, but they are very important and they allow you to develop that fundamental logic of solving problems. Okay, excellent. So coming back to our code now. Now this is basically for our loops. We completed that. And then next, let's just move on to, again, we have talked about break already in switch statement and extensively. So I'm just going to move on to arrays. Up till now, arrays is something that we have not discussed except within the public static void main. This square brackets, as we said, is arrays. So now what exactly do we mean by arrays? Arrays are used to store multiple values in a single variable. Numerous times you would come across that you would be required to store multiple variables, multiple values in a single variable. Okay. Previously or up till any, if you take any example, you would find that we basically use any variable to store a single value. Integer I is equals to 0 means this variable holds a single value at any given time. Arrays are ways of holding multiple values in a single variable. So instead of just using one value, you are able to store multiple different values. This is what arrays means. In a general sense, we define array as a collection of similar or a collection of data types, similar or dissimilar elements, depending on which actually language you're using. So in this case, we just say that, hey, array is something that is able to hold multiple data for within a single variable. So it's a collection of variables, or it's a collection of data. Okay, data that is stored in a single variable. So to declare an array, define the variable type with a square brackets. Now this is where the square brackets come into play, and this is where every time we write public static void main, we have this string arguments with the square brackets because it indicates that this is an array. These square brackets means that this variable now is of array type and it can contain multiple values. Okay, so this is how we define. So any type, again, you can use integer, byte, short, or whatever data you are using, float, long, double. You can create array of any data types using the square brackets. Okay, and then you define a variable name just like previously, and then semicolon would ensure that we have declared a variable. We have now declared a variable that is basically for a string type. To insert a value to it, we can use array literal. Place the values in a comma separated list inside the curly brackets. So now these are two things that we need to worry about. So to put a value inside this array, basically you need first the curly brackets. Again, the block is there. So these curly brackets indicate there's a block, and inside the block we provide the string values. But because it's supposed to be an array, meaning that it needs to hold multiple values, each value will then be separated by a comma. So this is value number 1, this is value number 2, comma, value number 3, comma, value number 4, comma, and so forth. Because this is the last value, there's no more value, or we don't want any more value to be here. So the last value does not have a comma after it, because obviously comma means it's still continuing. So now this is a typical example of how array would look like. We declare a data type, again any data type, we give a square brackets indicating this data is of type array. Then we declare a variable name. This becomes now what we call an array literal. This is what it is referring to. Now it's not considered or not technically referred to as a variable, because usually we say variable holds one value, and because this is holding a multiple values, it's considered or used as what we call array literal. Okay, again another terminology you use, but most commonly you will see programmers just using the same array variable word. Because you've added that array word, it's self-explanatory. So once you do that, then is equals to, so instead of giving it a single value, you use a block to define again multiple operations, and then those operations are initializing multiple values and assigning those values inside the single array, comma separated. Okay, so this becomes an array holding multiple values inside a single variable. To create an array of integers, you could write integer array sign, my number, and then the way we declare integers. So integers are not declared inside in double inverted quotations, they're just natural numbers. So we use 10, 20, 30, 40, means again comma is there separating the variable's value, and then you use the variable name here. Okay, so this is basically how we try to work with this. Square brackets, block, multiple values, comma separated. In the end, semicolon. So this is a typical syntax of array. The question now is, okay, I declared it. How do I use it? Okay, so the access of these elements of an array is quite important to understand that once you have an array, how do we access it? So you can access an array element by referring to the index number. This statement accesses the value of the first element in a car. Okay, what do we mean by this bloody index number? Well, the index number refers to the point in array list this item is placed in. So consider this as a stack, okay, or shelves. So the first shelf is automatically numbered. No matter what value is inside it, it's automatically numbered and starting from 0. The second shelf is BMW, but this is the value. It's numbered as 1. In terms of programming, we call it index number. So when you create an array, it contains multiple values. To know the position of each data value, we need to have something called index numbers. And those index numbers always start from 0. So even though there are 4 items here, the index number of the first item will always be 0, 1, 2, and 3. And subsequently, depending on how many elements you have, the number will be there. So this index number or the shelf number or the value or the page number, whatever you would like to refer to them as, they are basically always starting from 0. That represents some data being placed at this particular index. Okay, so a string declared with the square brackets, variable name, having multiple values. Fourth major thing is it internally has this 0 index. First was again using these symbols, square brackets to indicate the array, curly brackets, second thing in data, third thing, fourth is or comma separated, and then index number. So every data value that we save, whether it's in string or whether it's an integer, they always have an index number, means the location in an array of each data item. So the location of this data item is 0, the location of this data item is 1, the location of this is 2, and this 3 inside this array. Okay, so that is how we know that on which index what item is there. And so therefore, to access that item, we use the variable name that we have created. Again, the square brackets will be there to indicate that we are accessing the array, not just a single variable. And then within these square brackets, we provide the index number of the item we want to access. So for example, if I want to access the first element, we use the 0 index. If I want to access the 0 element or second element, okay, so even though this is second, but the index number would always be 1. Why? Because the index numbers of an array always starts from a 0. So we call this is second, first item is 0. The second item or the second element as it is referred here is also on 1 index. The third element is on 2 index. So that's how we basically output it. So if I access it, see this, it's accessing a Volvo. Similarly, if I want to access some other element, like for example, if I make it 3, I run the code, it's going to access whatever element is on the third index. What happens if I access it the 4? Okay, since it doesn't have the fourth item, 4 means that 0, 1, 2, 3, and the fourth item. Since there is no fourth item, it will generate an exception. What do we mean by exception? Exception means runtime errors. Okay, so it's not an error in the code, it's an error during the runtime. And the error is specifically is known as system index out of range exception. Means that the index number of this array is out of its range. The range maximum is 3, 0, 1, 2, 3. But if you access the element that are not there, such as 4, it's generating what we call index out of range exception. Okay, and it's telling us, hey, the index was outside the bound of array. The array index was out of bound, meaning out of its limits. It's supposed to be 3 maximum because there are only 4 elements inside it. So the index number maximum is supposed to be 3. You have accessed it. So we use this syntax, cars, variable name, square brackets, because we're accessing the array. It represents an array access. And then within the square brackets, we give an index number of each element. That's how the arrays are basically accessed within our system. Okay, how do we change an array element? So once you have an element, you can obviously change it just like any other normal variable. To change the variable, we use the variable name. We use the index we want to change, and then we provided the value. Okay, so for example, in this case, string array cars Volvo, we again declare the same thing. We say cars is equals to 0 is equals to now Opel. Okay, so car 0 index, go on to the 0 index, whatever data was on here, now replace it with Opel. Okay, so this is just like another value assignment to a variable that we have done previously multiple times. So we are now taking a variable, assigning it a new value, but because this is an array, it needs to have an array symbol and the index on which we want to place that item. Now once you access this item, it's going to print us Opel instead of this Volvo, because the item Volvo has been replaced. Okay, so you access, change any element using the same index number, and that's why the index number is quite important in this array. Next, let's talk about something called array length. To find out how many elements are there in an array, we use a built-in property called length with capital L. If you type in array cars.length, this is going to show us, hey, there's a string element called array which has various different elements. When we do the console.write-ln, it's going to print what we want. So if I come here and let me write, for example, console.write line and bracket stop, bracket stop, bracket close, inverted quotations. The array length is, if I go colon here and then I do plus, so I say, listen, there's an element called cars, go inside it, length, find out the length, and then put a semicolon here. Okay, and then let me just say, let's print second item here, change it because there's an exception there. Now what it's going to do, first it's going to print the item on the second index, which is Ford. Again, why we put 2 here, but we got the third element because 0, 1, 2. Then if you check the length of an array, it's using the function called length and it's printing as 4, indicating there are 4 items in this array. Okay, so in other words, we always say that the length of an array is the number of items in an array, and the last index is always length minus 1, n minus 1 kind of a thing. Okay, so it's always length minus 1 will tell us the maximum index number we have. Okay, that's it. One other thing to note is that this length does not have a round brackets to it. Somehow it's considered internal. Usually some programming language do support the round brackets, but this is a specific function, only length, if I know correctly. Only length is one of those functions within the array that actually does not contain the round brackets. Every other method that we have declared or we declare will always have these round brackets. But the method Length does not contain that. It's just the length. It counts how many elements you have in inside array, counts the number of elements, not the index. That's what I say. So index is always length minus 1. The last index is always a length minus 1. So if I do need to find out that, hey, what is the last index, I will go here and I will say the index of array is, and let me just change this, okay, or we can say the last index of an array is cars.length minus 1. So when I run the code, now it's going to say array length is 4. Oops, we got another error. Why is that? See this operation minus cannot be applied to operator of type string. Okay, because we did this thing, string plus length. So this has been concatenated. This has been converted into a string, and then the string cannot be applied to a maths. Pretty crap. We come here, put this inside the brackets as always, making sure that this operation is executed first, means we find out the length, minus 1 will give us the last index, and then we're going to print it. Hit the run button again. Okay, so these are small things that you would come across when you're doing programming. Sometimes these small errors which can be very annoying, but knowing the cause and be knowing to debug those errors make you a better programmer in a way. So don't be afraid of these errors. These errors are always will always pop up no matter how good programmer you become. You always tend to make up small mistakes, and but knowing them and being able to identify, diagnose, and solving them would make you better. So be open about it, read the errors, and try to come to a logical conclusion that what exactly could be wrong, and try a few things. So in this case, the brackets were there because brackets were needed there because the string was being concatenated. Now you can see the array length is 4 and the last index of array is 3. Again, simply just cars.length minus 1. So this will give me 0, 1, 2, 3. Third index, the length of this will be 4. Voila. Okay. So other ways to create an array. What other ways of arrays can we create? If you are familiar with C Sharp, you might have seen arrays created with new keyword, and perhaps you have seen arrays with a specified size as well. Okay, in C Sharp, there are different ways to create arrays. So there's not only a single way, there are various different ways. The first way is create an array of 4 elements and add values later. So we can create string, use the square brackets, car, same thing, but this time we use a new keyword and we create a string of 4 size. This is indicating that we want to create new string having 4 elements specifically. So we define this time that my array is going to have maximum of 4 elements. Okay, so we predefine the size of an array. Previously, in this case, the size of array was not specified. So if you are specifying the size of an array, you can do this using one of these ways as well. Creating an array of 4 elements and adding values right away. So if you directly want to add values, you can do that. So you can say string cars new. Again, new is a keyword, is a reserved word. Technically, it's used to create an object. So this is telling us that we are creating an object of class string having 4 elements inside this array, block star, block close, semicolon, and then we provided the values. So basically, it's like declaring and initializing the variable at the same time with given number of size. So we have specified specifically that, hey, I have a string array that contains 4 elements. Create an array of 4 elements without specifying the size. In this case, we can create elements, but there is no need of size here. It will automatically interpret that, hey, this array contains 4 size. So you can do it this way, or this way works perfectly fine, or you can convert it into this way that we just did right now as well. So these are 4 standard ways of doing it using the new keyword and data type with size, or you can just directly create this way as well. Okay. It is up to you which option you choose. In our tutorials or in throughout this particular course, we will often use the last option. So this is what you have mostly see, and you will mostly see further in W3Schools. Okay. However, you should know that if you declare an array and initialize it later, you have to use the new keyword. So if you declare a array and add values to it, okay, you can do that. But add values without using the new, this will cause an error. So if you, for example, declare a variable and you have not added the values, and you want to add the values later on. Okay, previously all examples see the values have been added on the same line. Declaration and initialization has been done at the same line. However, if you come into a mood and you want to say, hey, I just want to declare a variable, but values will be added later on, maybe at runtime based on the user input, what user has entered in their text fields or forms they have filled in, and I want to put that in. So I don't know the what values I need here. It's based on user input. So in that case, you must declare car with a new keyword. Okay, whether you provide the number or not, that's not an issue, but you must use the new string variable because the value will be placed later on. If you just use this thing instead of the new keyword, this will generate an error. Okay, so do keep this thing in mind. Now, once we have the array, there are few operations that we can perform on arrays, such as looping through the arrays. So to loop through the arrays means that if I have like 20 elements in my array, I don't want to access each one by one with 0, 1, 2, 3, 4, 5, right? The ideal thing would be we again will use something called for loop and use the length property to specify how many times the loop should run. So for example, if I have the following code, what this is doing, again, we created using system, namespace, my application, we created a class. Always remember we need a class, then inside the class we have a static void main method. Inside the main method, we created a string cars and we created a variable here. Okay, so we created an array. Now to loop through this array, we created a loop called for integer I is equals to 0. Why is 0 here? Because remember, array index always starts from 0, so that is why this I also needs to be 0, or the starting point needs to be 0 if you want to loop through from the first element. If you loop through, if you make it 1, okay, this means that we will always skip the first element and it will start from the 1 index here. So that's in this case, I mean, because I'm using this as an index element, so we need to start it with 0. Then we check I, the variable length, is less than equal to cars.length. Now remember why this is less than and why it is not -1. We did just in an example that length will return 4 for us. In previous example, we did that. 4 means the number of elements inside it. And the actual last index of an array would be length -1, which is 3. So now to loop through the element, I have used the less than condition with cars.length. So this length will return 1, 2, 3, 4 for us. And because we have used the less than, and we have already discussed this extensively, that less than means less than 4. So it will go 1, 2, 3 and stop. As soon as it becomes 4, it will end. So this always will ensure that if I use less than, it will give me a less than value, means less than the last index, which will become automatically 3. So 3 is there. As soon as this length becomes 4, this condition will become false and the loop will exit. Then we did I++, the increment to this I. We go inside the loop body, we say console.writeLine, access the variable name cars, and instead of giving it a number, now we have given it this I value. So the first time loop will execute, I will initialize to 0. I is less than cars.length. The length is 4. I is 0. Condition becomes true. It comes here. This I is now replaced with 0. And whatever element is on a 0 index gets printed. Then loop goes, does the increment, I becomes 1. I is still less than length. Condition is true. I is 1. So now it will print the element on the 1 index. And similarly, it will loop through until the last number is reached. So when I becomes 4, length is also 4. So I less than length, this condition becomes false, loop will exit. If you want to use equal to here, okay, if I use equal to here and run the code, see what happens now. So we get again the unhandled exception, index out of range error. Same thing, that the system.index out of range, index was outside the bound of an array, because when it performed the check, it said, hey, you are accessing at one point element 4, which does not exist here, because it's supposed to be 0, 1, 2, 3. Equal to will allow us to run one more time, making sure that we again compare with the length. So length will be 4, element index will also be 4. Again, the same issue will occur. So that is why if you are using equal to, we give it -1 here. This would work fine. So this would say, let's solve the mathematics first, length -1, and now it will try to compare with that. So the length -1 will always be 3, and then 3 equal to I would work fine. So you can use this as well, or most commonly you would find we just use the less than and here. So always know why less than is important and why length is important. If you are using equal to, you will have to use -1 here. Some people tend to use -1, making them understand that, okay, the last index is always length -1. So just easier for them to follow through. Okay. So this was using the for loop. Similarly, we have something called for each loop. Now, for each loop, we did not discuss in the for loops. In the for loop, you already have a for each, because I wanted to discuss inside the looping statement with this array sign anywhere. So the for each loop can also be used in a specific manner to do the exactly same thing. So there is also a for each loop which is used exclusively to loop through elements in an array. So this loop actually is used exclusively for an array. That's the reason I didn't discuss there, because we yet not done array by that point. So what for each loop does is that it's written as for each. We give it a type, we give it a variable name, and we say in an array name. So here the word in becomes keyword. The type is depending on what we want to define the type as a variable data type, and then we give it a particular custom variable name. Okay, so let me show you example of it, how it works. So here it is. So assumingly we have again simple string array of cards, we give it a certain name, we want to loop through it. So to loop through it, we use this logic for each. Okay, so we say for each, and we know the type is a string, so we use a data type string. We create a dummy variable I, so this becomes a runtime dummy data type. In basically is a reserve word, and in this case is a very powerful word. Major task you can assume is done by this word here. It has a built-in meaning and function defined inside C#. And then cars is defined the variable here. So what this line basically does is that for each item inside the car element, read it and assign it to this variable I. Okay, so this is read in this way. So technically it says that, again, if I write it here, for each uh, element inside array, read it and assign it to variable I for each element, in other words, string element. Okay, this makes more sense. So this is like just this entire expression is written in a code form like this. For each bracket start bracket close data type of string element in cars, assign that to I variable. So it's like a reverse logic or recursive logic, if you can understand. So what this line will do, it will go inside the cars, read the first element in cars, so means go inside the cars, read the first element, assign it to this variable I, which is of type string, because this is also a string. So that is why string. If these were integer array, we would use integer here. If this were float array, we would use float here. If this is what, for example, character array, we would use character here. Be keep in mind that. So this means go inside the car, read the first element in cars, assign it to I, and then we print the value I here. Next, go and check, is there any other element in the array? We said, yeah. So go read the second element now, because we already done with one. It knows that we already done with one, though increment needed nothing. So read that first element, the second element now, assign it again to the I, overriding the previous element, and now we can do whatever we want with the I. Then again go inside the R, read the third element, assign it back to the I, and then do it. So and go forth, print, assign it to I, come back. Now because there are no more elements, loop will exit. Class. So in just one line, we did exactly what we tried to do here. Okay. So if you read this, Control C, and if I bring this code here, these two technically are equivalent, but here we are manually traversing through each element of an array. Okay, this is considered as a manual traversing. We are using a loop to increment an integer value. We are checking its length, and then we are processing this. However, and then we again processing and printing the value here. And see here what we are doing it the same thing, but in a more technical manner handled internally for each loop. And this is why we say this is specifically used by arrays. So we say for each string element I in cars means go inside the cars, read the first element, assign it to a string element. If there is a value becomes automatically true, means it has a next element. We use now this I alone. Okay, again, this can be any other variable, for example, car name, right? So this can be a car name, and I can use car name variable. So it's not dependent that we use I. Again, it's recommended don't use I all the time. If that is the case, for example, we can say index. This makes much more sense that we are using an index number, index number, index number. This is always considered as a good programming, so that it's more meaningful, right? It's more readable instead of I. It's like, what the hell is I, right? So now we can say, hey, find out the cars, because we have a car array. Find each car and give a car name to this thing. This becomes a single variable value, and then we print this single variable value. Now no longer needed this thing. Okay, so you can use for loop, you can use for each loop, depends on how you do that. For arrays, this is most common practice. It's like doing everything automatically. This is doing manually, going and traversing each element manually. Okay, the old school programmers like me, we tend to use still this way. The new ones, they go for shorthand. No programmers tend to prefer this one. Again, I leave it up to you. So for example, above can be read like, for each string element called I as an index in cars, print out the value of I, blah, blah, blah things. Same that I said. Okay. So this is how we loop through the elements. There are certain built-in methods available for arrays, just like length. So length was one method we discussed, but there are a few other things that we can do. For example, sorting an array. Okay, there are many methods available. For example, the sort method, which is sorts an array alphabetically, or if it's numbers, in an ascending order. So if you have a string array, again cars, we use array, capital A array dot sort. Now capital A array is again a class name that has been predefined by the good people of C# and Microsoft, the .NET, the guys who did this whole crap thing. So they invented, or they created this array class, and it has a function called sort. So what we are doing is we are using that array class. Inside this, we say there's a sort method, and we give this variable name here. Note that now there's no square brackets needed, because it knows that we are already working with an array. Okay, so that's why the square brackets are not needed. What this will do, it will go and sort this entire array and override the elements inside it. So now if you go and print it, it will print the array in a sorted manner. Again, using for each, string I in cars means go inside R and print the values. It will print all the names alphabetically in an alphabetical order. Same goes for the numbers as well. So we have integer array, we have some random numbers, you want to sort this out. So we say go inside the array class dot sort my number arrays. And then we can say for each integer. So now note, very good example, we can say this is integer. Previously this was string. String was because we are using string array. This time, because we are using integer array, we have given it an integer I in numbers, meaning that, hey, this is an integer. Inside numbers you will find integers. Read them each element, assign it to I, and then we can use it. So you will find this is already sorted out. So this array alone will sort these elements and override it, and hence we will have a new array list. So if I print it, we will get 1 to 1589, right? So even though we had this 1589, okay, it will sort them out and print the list for us. Okay, meaning that this array number has now been, the elements has been overridden, and they have been organized, and new array list has been created automatically internally. Okay, perfect. Similarly, let's just talk about something called system.link. There are various other useful methods other than sort. However, they do not directly exist in the array class. For that, you need to use a specific class called system.link, or as we call them, the namespace. So methods such as minimum value from an array list, maximum value from an array list, all items from an array list, they all can be found in system.link namespace. To use this, you will be using something called using system.link. Okay, so we have talked about system. It's a default libraries that is needed to run these programs, such as console classes are existing in this, but the additional library files such as these methods exist in this link namespace. Okay, so we are just importing and using this namespace for our project. Okay, namespace means again a group of library files that exist. So this library file is been incorporated within our code, and since it has been incorporated, now we are using functions. So for example, I have integer my numbers, and if you execute it, so it says, hey, my numbers maximum. So we're just using, now we just need to say my number, this is my variable name that I just cleared, dot maximum. Do note that they have a brackets. Remember, length we used did not have a bracket. These are function methods that do actually contain brackets. So now I say, hey, I've created a array called my numbers. Find out the maximum value within my array. Okay, and it gives us, hey, the 9 is the maximum value. So if I change it to, for example, 11, and then I run the code, it's going to say 11, obviously, right? Because 11 is bigger number. So this method automatically finds out the bigger value in your given array. So if you're taking input from the users and you want to find out, hey, which was the highest bid or bigger value, or which user entered the largest number of samples or anything, it's just as easy as finding the max number from an array, as long as you have used system.link. Okay. Then similarly, minimum value as well, which of the person obtained minimum marks, minimum value, minimum bid, minimum number, XYZ, whatever your data is inside an array, you want to find the minimum value within it, you get 1. If you want, if I can say, for example, -1. Now, which one of this is a minimum value? Yes. Right. So if you know your math, you would know the answer correctly. -1 is the lower value as compared to 1. Okay. Excellent. And similarly, sum is another way of adding all the elements together and printing it. Now, here's a question that we tend to ask. If I've explained this correctly, what happens now? So, for example, if I come here and I create string and I declare an array of type string, and I say my channel is equals to, I declare an array, give inverted quotations, and I say ZWSHN myself, comma, SUBSCRIB, subscribe my channel, and I give my channel name, for example, and I say learn with you, and comma, inverted quotations, W3Schools. So for example, we have that. Don't forget to use this, give a semicolon at the end. So I create this wonderful thing. Now I go here and I say, listen, console, console dot write line bracket start bracket close, and I want my CHA channel dot sum bracket start bracket close semicolon. So because this is a method, it's going to use this. Now sum, we just talked about, adds up all the integer numbers. What happens if we have a string array and we perform a sum operation on the string numbers? What's going to be output of this? Will there be error? No error? A runtime error? Or it's just going to add or concatenate all these things together? This becomes one common problem that we usually ask in exams. So typically it would give us an error that does not contain a member sum. Okay, because this sum actually is a part of integer class. So it needs integers to work on. So this needs an integer to work on. My channel, because belongs to a string cannot be done that. There can be other methods, or you can write your own method to do that. Okay, wonderful. So this basically concludes the arrays. Next, we need to talk more about methods. All right, guys. So we finished with the arrays today on day number 9. Almost there, almost there, almost there. So on the day 9, we talked basically about what arrays are, how do we loop through the elements, how do we sort arrays, how do we access and do various different operations on arrays. So I hope it became useful, and things that you can do with arrays would be nice. Now, next, we're going to talk more about methods. Okay, we have touched methods just for the main method. We have discussed few things in previous sessions, but not as much. Let's delve more deep into what exactly are methods, how we create our own custom methods in C#. So basically, a method is a block of code which only runs when it is called. First thing, it's a block of code which performs a specific task, or say we usually say that it's a block of code that performs specific instructions, performs a specific task, but only when you call it. Okay, so it's there. It won't execute until you call that method and you say that, hey, I want you to perform this functions. Okay, that's what basically calling means. So you can pass data to it. You can known as parameters, which will go inside the method. You can receive a reply from it as well, which is known as a return type. We're going to discuss return type a little bit later. So passing a data means that when you execute a method, you give it some values to work on, or you don't want to give it. That depends on how we basically declare the methods. Methods are used to perform certain actions. As I said, certain set of actions, certain set of instructions, as we call them. They perform a specific task. Okay, so whatever specific task you want to perform in a method, we put that inside it. And then when we call it, that task is performed. They are also known as functions in various different programming languages. Sometimes we call them functions. Mostly in C#, it's referred to as methods. Basically the same thing. So why use methods? Basically the idea is to reuse the code. Okay, that's the key thing here. So certain actions you want to perform again and again. For example, login check or do mathematical calculations, addition. You don't want to use every time the code manually, and if it's like 5, 6, 10, 20 lines, You put all those 20 lines in a method and you call a method and it repeats itself. So the code reusability is the key feature behind using methods. So define the code once and use it many times. That's the basic logic. So you define it once and then you call the method. Whenever you need, you just use that one word to call that method and it performs this task. We have used a little bit of those methods in the math class and some within the string class. So math.sqrd, for example, math.log, math.sign, math minimum. Those are methods that have been declared by default by the people of C Sharp. They basically means that this method will perform specific tasks such as finding square root, finding minimum value, finding maximum value, and so on and so forth. So it becomes what we call a reusable code. Okay, and that's what the key thing here is, that we are trying to focus on the reusability of a code. Okay, which means define the code once, use it many times. So how do we create a method? A method is defined with the same name of the method followed by a parenthesis. So we use the method with the name and then we followed with parentheses. So C Sharp provides some predefined methods which we have already discussed in the main method in the math class, string class, but we prominently have used the main method. But you can also create your own methods such as we do now. So for example, we have a class called program, or whatever class name you want to specify, you can give here. Block start, block close. Then inside it, we declare a method called my method, bracket start, bracket close. This is how we declare a method. It has certain prefix to it, such as static, not necessary though. Okay, static is not necessary. It is there, but I will explain this in a moment why we need it. Void is a part that is quite necessary. Void means return type, means that when this block of code executes, this method will not return a reply. This is different from doing certain tasks which have an output in them. So this method can print something, have some output, but when we call that method, this will not return anything to us. More about return type later on in the parameters section. So if you explain it, this is method is the name. Static means that the method belongs to a program class and not an object of the program class. So we're using the static, we can use this method directly without creating the object of this class. So we can use this method directly by using the class name and the method name without having the need of creating an object itself. What exactly we mean by creating an object? It's a concept of OOP, which will be discussed later on here. But in a nutshell, object represents the data of a class. So we create a class, we put all the methods and data types inside a class, and then we create an object of it, which becomes an instance of that class or a representation of that class, or in programming terms, an object of that class. Hence, now that object has access to all the methods, all the data that has been declared inside that class. And using that object, we basically process the data. That's an object-oriented concept. More about it, as I said, later in OOP concepts of C Sharp. But so if you want to access this method without that object using the class name directly, we set it to static, meaning that now it does not need an object, it directly belongs to the class. This is exactly what we did when we do console.writeLine. Console.writeLine is a method. Console is the name of a class, and we are directly accessing it without creating an object. Understand? And void means that this method does not have a return value, means when this method executes, it will not give an answer back to its calling function. So wherever we have called it, it will not return a value to it. So in C Sharp, it's a good practice to start with an uppercase letter when naming a method. Now this is in C Sharp. If you are coming from Java, in Java usually we use class names as capital letters and we start method with the small names. That's how small letters. It's just the convention, not the rule. It just identifies that, hey, this is a method and this is a class name. However, if you come to C Sharp, the C Sharp people have done, tried to differentiate from Java. They just put some weird rules here and then basically means that, listen, good practice, use an uppercase to start a method name and a class name. So that's why all the default methods inside C Sharp, you would find they always start with a capital letter, such as again main. Now, how do we call a method? To understand that, we declare a method, but it's very important to know that we have how do we call that method. So if I come here, we have a program. We create, again, using system, namespace, my application, class, program. We declare a method static void my method. Again, static is not mandatory, but since we are not going into objects right now, that's why we are using static word here, so that we don't need to create an object and get into the understanding of how object is working before actually the method. So they are using it as a static. So we declare it as static, we declare a return type as void, and then we declare my method. Again, any name is valid. Same variable name rules also apply with the method name, meaning that your method cannot contain a spaces. It cannot be of a reserved words and keywords. It cannot have special characters. It cannot have a minus sign. You can use underscore though. And if I'm not mistaken, C# also does not allow you to use numbers as a starting point for a method name. Okay, so the first character cannot be a number. The second can be, no problem with that, or anywhere else. But the first character should not be a number. It should always have that. You can use start with an underscore though. Not a good practice, but again, yes, some people have that habit. Sometimes you see under method starting with an underscore, but usually we start with a capital letter and then put underscore if there are multiple words. So we give a method name, again the round parenthesis, block start, block close. This block now indicates that this code belongs to a method. So when this method is executed, it will perform this set of instructions. But to execute the method, you have to call the method. Do also note that this method has been declared inside the class body outside of the main method. Since main itself is a method, you cannot declare a method inside a method. Okay, so this is a separate method inside a class, and this is a separate method inside a class. So method cannot be declared inside a method. So this is also known as method declaration. We have declared a method, means we have defined what this method is going to do, but we have yet not executed, because to execute it we need to call this method. You can call a method inside another method, but you cannot declare it though, because it's supposed to be a separate block of code that performs a certain set of instructions. So that for that it needs to be outside of another method. So hence we have a main method. Inside the main method we called my method. Now this is method calling. To call the method, simply just use the exact same name, meaning if it starts with a capitals, if it is underscore, use exact same name with a parenthesis, okay, such as this. So this becomes the calling, and then we give a semicolon to end the statement. So this my method is now called a method call. This is called method declaration. We call this method here in my method, and it performed the task. For example, I just got executed. So this is how we call a method inside our C# code. So a method can be called multiple number of times. That's the beauty. This is where reusability comes into play. So if you want this statement to execute multiple times, you don't need to write this multiple times. You just put it inside a method, and then you call the method multiple times. Understandably, you need to understand that this is just one line as an example. There can be hundreds of lines of code here based on what my method is doing. So those hundred of lines, you don't need to write every single time it needs to be executed. You just put it inside a method. Now to re-execute it, you just call the method, you just call the method, you just call the method, and it will execute this method multiple times. Hence, code reusability comes into play. Okay, so you can call this method multiple times wherever you like, however you like it. That's it. That's the basic phenomena of method. Now let's talk more about the parameters, about these empty parentheses. So the parameters or arguments, this is basically an information which can be passed to methods. This is known as a parameter. Okay, so when we talk about the word parameter, means that some information we pass to the methods. Parameters act as a variables inside the methods. They are specified after the method name inside the parenthesis, and you can add as many parameters as you want. Just make sure you do separate them with the comma. So if I have a method called my method, so within its parenthesis, which previous example was blank, now I have given some round brackets with string per argument. So this is what we call a parameter is, meaning that when I execute this method, I need to provide it some form of data. So when I call this method to execute it, I need to provide it some form of data. This data in this case is again a string. Why is it a string? Because this method, we have declared that this method will take an input in form of a string, or what we call a parameter in form of a string. Because we have fixed it that, hey, in order to execute this method, you need a string argument. Hence, when I call this method, I need to provide some string argument. Now what's happening here is, when we execute this method, it's going to call this method. Because we have provided a string variable, here this string variable data will go and be stored inside this variable name here. Okay, so when you execute it, it's gonna print the same thing: Liam reference, Jenny, and Anja. Okay, wow, how this got executed? Because this string, when was passed to this method, was then sent and stored in this variable here. And this variable being of type string, and this being string, is again now officially a string variable containing a value Liam for the first time, and it's going to print this method here. So when you call the f name, this f name will print Liam because this Liam was passed. Then again you call my method, and this time you change an argument to Jenny. So this Jenny now will again be passed, and f name will be replaced with this Jenny variable data. So this variable now contains Jenny. Hence, when this method is again executed, its block, the f name will contain Jenny. The third time I again called it, but this time I gave it a different argument. So now again this f name will have this Anja value assigned to it. This is called passing value. Okay. So when a parameter is passed to a method, it is called an argument. So beware about or follow me with these naming conventions. You would be using these namings a lot in programming as we go along and develop more complex applications. So basically this is in what we call a parameter, but when we pass it a value, it's called an argument. So we say, hey, it has an argument. So for the example above, fname is a parameter with Liam, Jelly, and Anja are its arguments. Okay, so this is a parameter that contains argument called this value and this value and this value. So when we pass these values, this is the passing of this value, and the name for this value, in other words, becomes arguments. The name for this step is known as what we call parameter. So this parameter has an argument called name value or Liam value, Jenny and Anjana. Okay, so do keep an eye on these nomenclature because they are going to be used multiple times as we go along. So how do we pass multiple parameters? Multiple parameters means you have multiple parameters within the method name. Again, this method can be any name performing any specific task. It can have any number of arguments, comma separated. That's the key thing here. And the arguments don't have to be of same type as well. That's again another key thing that you need to remember. You can pass it a string, you can pass it an integer, you can pass it a float, you can pass it a double, depends, and sequence doesn't matter. It's really up to you how you wanna customize this, because this is your completely custom method. So whatever you name you give it, whatever arguments you want to give based on the parameters, it's absolutely up to you. The sequence of parameters up to the developer, how what they need. The variable name is there, the data type is there. Okay, so this is completely our control. So in this case, we said that, hey, this takes two arguments. Two arguments means this method when executes has two parameters. So when I call it, I need to provide it two different arguments. One being string type, second being integer type, because the parameter definition or the declaration has it that it requires a string and an integer. So when I execute it, I pass it a string argument and what we call an integer argument. So see this, the nomenclature, we are using arguments when we are calling this method. When we are coming here in declaration, we are referring to these as parameters, because these are known as parameters and these are known as arguments. Okay, and multiple parameters means we have multiple data types with variables comma separated inside the round parenthesis. So now we can use console.ln fname is h. So automatically when you pass it multiple arguments, the first argument will be assigned to the first parameter. The second argument will be assigned to the second parameter. Sequence will be followed. If you assign 5 here, comma Liam, this will start to complain. This will say, hey, what's now? So for example, if I do 5 here, comma, oops, not inside the inverted quotations, 5, comma Liam, now it starts to complain. First complaint will be the listen, I need to have an in string, but you are passing me an integer data type. And then for the second, I need to have an integer, but you are passing me in a string. Similarly, if you pass less argument, for example, you said, hey, I just want to pass, I just need the name, still it's going to complain. Okay, it still is going to complain that it says, listen, I need two arguments here, because the function method declaration has it that we need two arguments. but you have only provided me one. So see this, we get multiple errors now, 3 errors for that matter. Understand? So we always have to stick with the signature of the method that we have declared ourselves. That is why when you start to use the built-in methods, we always stick to the certain rules, that what is the actual signature, what is the method declaration, what arguments it needs. So in this case, it needs 2 arguments and we have only provided one, so it's complaining. So we need to provide the same argument. Similarly, if you use an argument of a different data type, in this case float, but the data type here is integer, again the problem is there. So these are small pitfalls that you need to be aware of and we need to avoid as much as we can. Okay, so this was parameters and arguments. What do we mean by default parameter? So you can also use a default parameter value by using equal sign. If we call the method without an argument, it uses the default value Norway. So let's explain this. For example, I have a method, my method, and I declare it a string country. Typically, we declared it with just the variable declaration because the value of this variable would be passed through the argument. However, we can assign it a value inside this as well, just like a normal variable declaration that we do. So in this case, string is there, country is there, and we already assigned it a value equals to Norway. What this Norway now represents, it represents a default value. Default value means that what if I do not pass any value? So in this case, the previous example that we did, if I do not pass it any value, it will start to complain. It said, hey, it needs 2 arguments. I need 2 arguments because your declaration says it needs a string and an integer. And you have not provided me shit. So we need to provide some data here. So what we do is we need to set sometimes a default value that in case if I don't provide you a value, which usually should not be the case because we are creating the method. So we should also always have the correct value. But in certain cases, if you don't want to provide it a value, you use this syntax to ensure that a default value is always set. So if you call this method and you provide it as Sweden, it will say Sweden. It will automatically override whatever the value is assigned to country. So in other words, whenever this method executes, by default Norway is assigned. But when you call the method and you give it your own value, now that Norway, this country is replaced with the Sweden. So this variable country will have this new value because you have provided that. Then you call the method again. This time you provided India. Now it will again assign it India here. But in case if you don't provided any value, so instead of generating an error, the default Norway value will be used. And same can be done for multiple parameters as well. Okay, same syntax, just provide comma here and use multiple arguments. No problem with that. Okay, so do keep in mind it's used rarely in my understanding, in my case, because whenever we're declaring a method, I know what I'm doing. So I have a method, it requires an argument, so whenever I need to call it, I always pass an argument. This situation may occur at certain places, but it's not very common. But it's good to know that you can have a default value in case if user doesn't, or you don't want to pass it any value, there's always a default value there. Understand? So this is what a default parameter means. So a default parameter value is often known as optional parameter. From the example above, country is an optional parameter and Norway is a default value. Okay, so this means that it's an optional parameter. It makes it optional. Okay, this is how we see it. If you provided an argument, it will use that. If you don't provide an argument, it will use the default value. Okay, understandably, right? Let's talk more about return values. What do we mean by return values? Now, as we have talked about previously as well, we used void to ensure that there is no return type. Return values basically mean that when we execute or when we call the method, it will return a reply to us when we call it. Similarly, for example, if I ask somebody that here's a $5, go and buy me this item. Okay, so you expect that they take the $5, which becomes our argument, that go to the shop, which becomes our block of code, they execute, they buy it, and now they will bring the product back to me because I've asked it, hey, go and buy it for me. So when they go and buy that thing, they will come back to you and give you the product that they bought for you. Means they will return the value, they will return the reply. That's what a return type means. Understand? So return type means that it's not related to execution of the purchase. It's dependent on after the execution of the purchase, there could be an answer, there could be a value that will be returned back to me where I have called that function. So in this case, we set it to a data type instead of void. Now we have used integer. This means that when this method executes, it will perform its set of block of code, but at a point it will give us an answer or data back to us. So we need to be able to receive that answer where we have called that method. Okay, let me explain this a little bit in more detail. So for example, we have static and we declared the return type to be of type integer. Means that when I execute this method will return a value to me. So I need to be able to receive that variable. So I can say, hey, integer, for example, reply is equals to, and I can use my method, block start, block close, and I need to provide it some value, for example, 4. Now this means that when I execute the method, I gave it an argument 4 because it requires an argument here. When I give it an argument, it will perform certain actions, and after that, this method will return a value to me. So that guy, after purchasing, will come back to the same place to give me what I asked him to buy. That means that when I have asked him to buy something, I need to be there to receive the reply as well. So it's like asking some method to do a action. Once they done the action, they will give you a reply, and that's what we need to do. And once we have asked them to give us a reply, we need to be able to receive that reply as well. So this is receiving the reply from this method. If you don't do this, this method will again generate an error that, hey, listen, you asked me to do a task, I did that task, but then there's a return type as well, meaning that I'm bound to send you a reply. Okay, and that reply, when I send you, you need to receive it as well. If you don't, I will complain. So where should I throw away the reply? You asked me to purchase something, I got it, I come back to you, you are not there. What the hell should I do with it? Understand? So that becomes a problem in terms of programming. So we need to be able to receive that reply. This is what the return type's first action is. Second action, sorry. First, we specify instead of void the data type. Data type indicating means this can be integer, this can be string, this can be float, this can be double. Meaning that when I give you a reply, the reply will be of this type of data, and you need to receive that data. Okay, and the receiving can be in this way as well. So we can write console.writeLn, and then inside the brackets we use the function name. So this means that whatever reply I give you, you throw that reply to another write line and it will print it. So for example, hey, I buy this thing, if I'm not here, there's somebody else, give it to my brother, he will give it back to me. So you give the reply, but you don't give me directly, you give it to my brother. At least there is somebody there. So this is another method receiving the reply from my method. Understand? So it's catching the reply. Whatever reply is thrown, sent, is caught by the write line method and is printed on the console here. You can save it in a variable and use that variable, or you can use this very method's reply directly with some other function as well. So I can do very easily this thing as well. I can say integer x is equals to rep or reply plus my method, oops, method 45. Now what I did was I created another variable called x. I said use the reply. So whatever reply came from here, saved inside this variable called reply, use that value plus my method 45 again. So this means that whatever I have done here will be added to this thing. So my method will again be called, a 45 value will be passed to it. It will process this 45 and give me a reply. Whatever is the reply returned, again, because I know it's going to be of type integer, that integer number will then be added to this variable here, and then finally their addition answer is assigned here. So this is the third way of dealing with the replies as well. You can directly assign it to variable, you can directly use in any another expression, or you can print it inside a main method as well. Again, this is same thing as this one, using directly inside an expression. Understand? Finally, the fourth major thing is how do we give a reply? This is indicating a reply. This is receiving the reply. How do we actually give a reply? To do that, we use a keyword called return. Return is used to specify the listen boss, I am sending you a reply. Okay, return is a keyword, is a reserved word. You cannot use return directly as a method name. You cannot use a return as a variable name. You cannot use a return as a class name, because it's Java's keyword. Same goes for static, integer, class, namespace. All these are C Sharp's reserved words, C Sharp's keywords. You cannot use them for your own custom purpose. Be aware of that. So return has a specific meaning. It means that I will be giving you a reply. What is that reply depends up to whatever I want to write in front of the expression. So I can say 5 plus x, meaning that add these two numbers together. Whatever is the answer, return that answer. So that answer has to be of type integer, because this is what we need, and this answer will be replied after this method has been executed. So when we say my method 4, this 4 value is passed to this integer variable x. So this x now will be 4. So x plus 5 means 9. The 9 answer will be returned in form of integer back to the method which we called it. So this method now will return, send or throw that reply out, and that reply will be caught here in integer value. So see the cycle exactly. So this is how it follows. Then again I called my method 45. This 45 is sent to x. X becomes 45. X plus 5 becomes 50. That 50 is now returned back in form of integer to the method that actually was called. Okay, and then that 50 value will be added to this reply, and this will reply whatever values here will be saved inside this now. Capish? Same goes here. My method 3 means x now has 3. This x plus 5 now becomes 8, and that 8 answer is returned in form of integer to this method here. So wherever we have given a call, if there's a return type, the calling method needs to have a mechanism of receiving the reply as well. So this is one way of receiving a reply, another way of receiving a reply, another way of receiving a reply. Depends on how you use it. So this is what a return type does. In this case, when we specify a void, for example, main has a void. Void means that when this method executes, it will perform certain actions, but that's it. So it's just like, hey, take your $5, go to the shop, buy this thing. That's it. I didn't say that I need a reply. I just want you to buy it and do this action. Halas. So they go to the shop, they buy it, they eat it, they finish it, whatever they do, whatever product is their job. I have given them the task, they have done the task. I don't need I don't need a confirmation, I don't need a reply, I don't need an output for me that hey, once you do it, come back to me and give me the report, right? I don't need that. I assume that you've done it. So void means do the task, thank you very much. But when we specify integer or string or byte or character or short, whatever data type you want, this means that, hey, do this task, come back to me and reply me in the progress. What was it? So we're telling it that we need the reply. And so in the code, we need to write a statement called return. So as soon as we return, it will immediately go back to this point. I think I tried to explain too much, right? So this is how it works. So you can pass two arguments, again, same return type, void does. So this is what all the return type function tries to explain to us. You can also store the results in a variable. So same thing, again, it's trying to store same examples here. Okay. So this is in a nutshell what entire return type or return values means. Now, whether I should use a return or not depends on the logic of my code. For example, if I'm creating a function to add two numbers, so I will say add integer x and integer y. For example, this means I take two arguments, add them together, and then they return a reply to me. So in this case, I would need a reply. Understand? Wonderful. Last is named arguments. It is possible to send arguments with a key and value syntax. Let me explain. That way, the order of the argument actually does not matter. If you don't use a named arguments, technically you are bound to send the arguments in a sequence that they have been declared in. So if I create my method in a string and integer, we have to ensure that a string and integer is there. If you change the order, there's a problem with that. But the workaround to it is that you use something called a key and value structure. Okay, that key and v-value are known as named arguments. Means when we pass the argument, right, we give it a specific name. We tell it that this argument belongs to this particular guy. So in this case, what we have done here is we have said, hey, listen, I have a static method called my method. String, it has a child 1. String, it has a child 2. String is a child 3. Again, any arguments can be there, data types can be there, depends on our actions. So we declared 3 string variables. No problem with that. And console.argument, the youngest child is 3. We give it some value or whatever actions is supposed to perform. I can have multiple statements being printed with it. Okay. When we call the method, and again, do note that it's a void, so that means it will not return a value, so we don't need to receive a reply. Since it is void, there's no return statement here, there's no need for receiving a reply. Understand? Wonderful. So now my method, child 3, John. What's child 3? This is what we call a key colon its value. This is what becomes a key colon its value. So this key colon value is a pair where key is actually the name of variable used in method declaration. So child 3 actually is coming from this child 3 here, and it's becoming John here. In fact, if I were to do a better example, let's just use this in form of, for example, integer, and we can use this as a character. Right? So now if I come here and I can, let's just be there. So now if I use this method, Control C, come here, Control V, and let me just comment this one out to avoid the errors. So now what I've done here is I've said, hey, child 3 colon John, or can be, because this is supposed to be character, so let's just pass it a character C. Typically, as I said, you need to follow the sequence. By following the sequence means that you have to write my method. The first argument must be string. So we would have to give something called name string here, okay, and then comma. The second argument had to be of type integer. For example, age, I can say, listen, it's a 10 years old. And the third can be, for example, initial. So I need to provide invert single quotations and a. Typically, this is the syntax that we need to follow. Means the data type have to match. So the first argument is of type string, hence it needs to have a string. The second is integer, hence this integer. Third is character, hence the character. So this sequence needs to match in a typical standard environment. However, if you don't want to do that, you can use something called key value structure. So now what we have done here is, instead of writing the character third, we want to write the character first. So I just use this variable name. So character child 3 is there. So what I said, hey, child 3 colon C. So basically I'm telling it, listen, this variable child 3 in this method has a value C. This child 1 in this method has a value lam. So this is what the named argument means, that we are naming our arguments. These are parameters already declared. Each parameter has a variable name. And when we pass it the arguments, we give it a name. The child 1 is line 1. So it doesn't matter the sequence, doesn't matter the data type, as long as you have provided the name here, that this is the variable name called child 1, colon, its value is Liam. This is a variable called child 2, colon, its value is Lime. So wherever in the sequence there's a child 2, this value will be automatically assigned to this. This value will automatically be assigned to the child 1. This value will be automatically assigned to the child 3, regardless of its integer, just because this is integer. So regardless of its sequence. So typically either you can follow the sequence. If you don't want to follow the sequence, we give it these parameters here. This is actually quite commonly used because there are methods that can contain 4 and 5 values, and there could be method overloading. We'll talk about this later. So sometimes keeping up the sequence is an issue. So that's why we try to prefer to use this key value parameter where we actually name the variable name. So instead of using equal to sign, we are using colon here. That's the only logic you can follow. So my method is there, variable name is there. I use the variable name. Instead of equal, the colon is used and the value is assigned. Simple as that. So this means C is assigned to variable 3, Liam is assigned to variable 1, 23 is assigned to child 2. Okay. Regardless of the sequence now does not really matter. This is what named entity is basically. I hope you understand that. Next, let's talk about method overloading. Now, what do we mean by method overloading? Method overloading means that you can have a same method declared multiple times, but each having different parameters. This is known as method overloading. Means we overload a method, each method having same name but different number of arguments, okay, or different type of arguments. So, and this is a very amazing and cool concept that we use in programming and very commonly used as well. What this means, for example, we have a plus method, okay, plus double method. So these becomes two methods for us. One is taking integer x, one is taking integer y, okay, or double y, sorry. So what's happening now is that we create a method called plus or add integers. So it adds two integers together and returns a value. We create another method that says plus method double. It takes two double variables as an argument, adds these together and returns the thing. Now note the difference. Both of these functions are actually using same operation, adding the two arguments and returning the value. Hence, this is what we call the repetition is. We have to memorize all these method names just for the same addition. So instead of this, we define a method with the same name that can perform both these operations, hence reducing the number of lines we write as well. This is why my overloading is so important. So if you use this typically, you would say integer number 1 is equals to plus method integer 8.5. So add these two integers together, whatever is the answer, assign it to this my num, because we have specified it integer and we have used the return. So there will be answered replied in form of integer. Then now we need to call double method, again taking two arguments in a double decimal value. It's going to add these together, return a double value to us. We can print. So instead of defining two methods that should do the same thing, it is better to overload one. An example below, we overload the plus method to work for both integer and double. So here we have something called static integer plus method. If they take two integer arguments, it's going to add together. We now use the same method. Everything else is same, but instead of writing two different names which difficult to understand, we create the same method called plus method. The arguments are different. Based on different arguments, this is known as a method overloading or overloaded method, and this is completely allowed. And they both perform the same task, integer xy, integer xy. Understand? Makes them simple. Hence, now wherever you need to add two numbers together, you know that you just have to call the plus method. If you pass it to integers, it's going to add two integers. If you pass it to two double values, it's going to do the same thing, because we have method overloading done. So multiple methods can have the same name as long as the number and or type of parameters are different. This is what simply method overloading is. That you declare a method having same name, but you change the arguments. And typically the function can be different or same, it's up to you as well. Okay, so it's not necessary that the body also has to be exactly same. The operations can be separate. The key point here is that we use the same name. That way we don't have to remember and memorize multiple methods that almost perform the same task. Okay, and they only just differentiate based on the arguments. So we declare two variables or two methods having same name. We change the number of arguments or the type of arguments and we call them. So plus method. So for example, add in calculator. Add is one function. So whether you're adding numbers, decimal values, minus values, whatever you're doing, add is just one single function. It will be used to add numbers, whether decimal or a natural whole numbers. makes more sense, right? Instead of time, if you imagine, if in your calculator you had add two integer numbers, but if you want to add 2.2 to 1, now you have to use another plus symbol that allows decimal values. That just becomes a very crazy idea, right? So that's why overloading is quite important and just used there. Okay, so this is just the basics of it. We'll try to do some more examples of the methods and overloading and the return type to make things more easy and simplify few things in terms of understanding. Okay, so next we will talk a little bit more about classes and objects, and then we see how we can use our own methods for that sake. Okay guys, so now let's talk about C++ Sharp's OOP. Okay, OOP stands for Object Oriented Programming. By this we mean that we have a specific behavior of our class and object structure that we need to understand. OOP is basically a conceptual framework. Okay, if you understand that, it means that it tries to create a framework by which a language is working. Basically, a procedural programming is about writing procedures or methods that perform operations on the data, while OOP or object-oriented programming is about creating objects that contain both data and methods. For example, language like C. C was considered as a standard programming language. It's not an object-oriented language. By programming means that it did have methods, but that's it. So in order to, or whatever operations and functions we do, we had to create methods, call methods, create methods and call methods. That's it. When we talk about object-oriented language, it contains something called method and data. Okay, and then we create an object that can use this methods and data. Then these objects can be multiple, so you can create multiple different objects of the same class. Each object will have an independent copy of their data and methods, hence allowing us to expand the coding to a whole new level with multi-reusability and multi-structuring and having inheritance and polymorphism and abstraction within our system that previously could not be achieved using simple programming. Okay, so that's why OOP is now something very important to understand and how it is being implemented. Obviously, from C++ to Java to C# to Python to PHP, almost every other language now works fundamentally on OOP concepts as well, and they try to work because it is such a powerful way of doing programming. Object-oriented programming has several advantages over procedural programming. OOP is faster and easier to execute. Okay, so internally it's much faster to code. The code is always a short, and it's faster and much easier to work with these things. OOP provide a clear structure of the program. Debatable, but yeah, they do have a much understandably clear program structure, which is more easy to follow and more easy to work with. OOP helps us to keep C# code dry, don't repeat yourself, and make the code easier. Dry represents, again, we call it dry, but it's not the literal word dry. It's like a figurative, and it means don't repeat yourself. Means that once you write a code, the reusability concept comes into play. We talked about this in methods as well. Similarly, this makes the whole class very reusable. Okay, so that's what the word dry comes in. And makes code easier to maintain. Yes. Okay, so you can very easily update, maintain. You don't have to change the entire code. You just add new methods to work on previous methods, overload previous methods and update them, and many things you can do without actually changing the previous code. You know, that's what it becomes. So you can do inherit the previous code and modify it and create a newer version of the code very easily, which within a standard programming language was previously very difficult to do. That's why the systems now, you see these upgraded systems happening every other day. It's because the code is so upgradable very easily. Okay, OOP makes it possible to create full reusable applications with less code and a shorter development time. Self-explanatory. So don't repeat yourself. Dry principle is about reducing the repetition of a code. You should extract out the codes that are common for the application and place them in a single place and reuse them instead of repeating it. Okay, so that's what basically the whole principle of dry yourself means. Now, whenever we talk about OOP, there are fundamentally two things that you need to understand: classes and objects. Every OOP concept, no matter which language you go into, has the same fundamental principle, and it goes across the board. Okay, so it's not like that if you understand C++, OOPs, if you go to Java, it's something different. Or if you know OOP in Java or the OOP concepts from Java, if you come to C#, it's the same. So no matter which language you go into, even you go into Python or PHP, OOP concepts are the fundamental concepts are exactly same. The syntax wise, the working wise, there might be some difference, but the fundamentals, the basics, structuring, and the concepts are exactly same. Okay, so that's why we talk generally about this. So every OOP has something called classes and objects. So you need to understand the difference between and the usability of these two things. What is the class? What is an object? How they differ? And then how do we use, these two things becomes major thing to understand whenever we're talking about classes and objects. Having classes and objects make OOP, right? So the foundation of OOP actually stands on these two pillars, classes and objects. If you take either one of them, you cannot create OOP, and all other concepts of OOP basically are useless and are not applicable as long as there is no class and objects. So that's why we said we're understanding how classes are working, how objects are working, how we use classes and objects with each other and generate our system wide outputs. That's the key thing that we work with. So classes and objects are two main aspects of object oriented. Look at the following illustrations to see the difference between classes and objects. So now here's a very cool, very well, not cool, but very easy to follow understanding of what classes and objects are. And if you understand this, well, it makes things a lot easy for us. So for example, a class is generally considered as a prototype that contains the definition of everything that is supposed to happen for that particular class. So for example, we have a class fruit. So this fruit now is considered as a prototype. It contains definition of what a fruit needs to be, how a fruit is supposed to behave, what a fruit is supposed to taste like, what features and aspects, and what makes a fruit a fruit. How do we identify that this is a fruit or this is a vegetable or this is meat, for example, right? So this is what a class basically represents. A class contains data, it contains methods about defining a particular aspect, which is in this case fruit, or another example, this is a car. So car is also a class, fruit is also a class. For example, we can have animal as a class and human as a class. So how do we differentiate what's in the animal, what's in a human? Then we say if it's animal, what type of animal it is, so there are various different categories. So we have another, we can divide in another categories. Amphibians can be different, insects can be different animals, birds can have a different animal category, fishes can, water based animals can be different. So when we define a class, we define certain properties, methods that are associated with that class. Okay, so those properties, those methods, those data belong to a class, and all the data is basically within that class. So if I have a fruit, all information about a fruit will be inside my class. That's why we call it a prototype. If I have a car, all the information about a car, like they need to have four wheels, they need to have windscreens, they need to have doors, the seats, the players, the engines, the every mechanics that goes inside a car, all that information is actually inside the car class. Understand? Now, if I jump to object, object now means that it is a single entity that represents a class. It's an entity, it's an instance of a class. Meaning that when I create an object of a class fruit, now this fruit possesses all the properties of this class. When I create an object of this banana of a class fruit, meaning that now this banana is a instance of a fruit class, or this banana is an object instance of this class containing all the methods, all the data, all the properties of a fruit now will be used inside banana. Similarly, mango, for example, again another object, meaning that now mango is another object that contains all the data, all the methods, all the attributes of a fruit class with it. If I take an example of car, so we have a car, as I said, car needs to have four wheels, it needs to have a windscreen, it needs to have a particular engine, it needs to have a battery, it needs to have an axle, and all the properties that we fundamentally say a class needs to have, we define it inside this class. So when I create an object of this class, means now Volvo is an object of this class, or as I call it, instance of a class, or as they call it, it represents this class. Okay, or we in some books we use the word entity. Okay, so Volvo is now entity of a class, meaning that now because the Volvo is an instance of this class, this Volvo object will have access to all the data of this class. That includes the tires, the windscreen, the engine, the axle, the body, everything is now accessible and readable by Volvo. Then I create another object called Audi. This again is an instance of the same class, but now it contains all the methods and access and data of this class. Same goes for Toyota, right? So now we have three objects. We have three objects here. So these objects are basically way of using the data. A class is only representing the data. Object is way of using that data. That's why we call this as a prototype. We call this as an entity or an instance of a class. Okay, so as a prototype, it represents, it contains the data, it holds the information, it doesn't use it. To use that data, you need to create an object of a class. That's another point that we use and we need to understand the difference between class and object. So we create a class to declare, to define data, methods in form of methods and variables. Okay, so it will have methods and it will have data variables that will contain information about this class. So it will only contain data. To use this data, you need to create an object. So this object, once we create it, is an instance of this class. It will have access to all the methods of this class. And then using this object, we were able to perform operations that can use this data. Okay. Then when you create a second object, basically now it means that the object A is nowhere related to object B, even though they belong to the same instance classes, but they cannot share the data, they cannot access the data of each other, they cannot process each other's data, they cannot even know about each other. They are two independent entities. Again, whenever we have a class, it's a prototype, it's a single model. You can create as many objects of that class as you want. However, each object is completely independent of another object. It has no access, no information for that. That's why, for example, if I have a car, if I create a Volvo, Audi, Toyota, these are three independent objects. They all have same properties because they are all instances of the same class, but they are not correlated to each other. They are not corresponding with each other. They are not able to share, transfer, view, process each other's data directly, at least. Okay, because each of this data is independently shared with them. Hence, car independently shares data with the Volvo, car independently shares data with Audi, car independently shares with others. So this is how we basically try to understand this, the relation between a class and object. Class defines the data, objects use that data. Each class contains data in form of variables, parameters, and methods. When we create an object, it becomes an instance of that class having access to those methods and variables. There can be multiple objects of the same class. Each object is independent of each other, means they cannot interact with each other. They can only use the data of their parent class, their parent data or the prototype data. Okay. So a class is a template for an object and an object is an instance of a class. When individual objects are created, they inherit all the variables and methods of the class. Right? Understand? Perfect. So this becomes the basics of object-oriented language. Classes and objects. Now let's go and talk a little bit more about how classes are created in C#, how objects are created in C#, and how we use them. Okay, let's begin. So now we have classes and objects. In previous section, we learned about the basic concepts of object-oriented language. Everything in C# is associated with a class and object, along with its attributes and methods. So for example, in real life, a car is an object. The car has attributes such as weight, color, and methods such as drive and brake. Okay, so a class like object constructor or a blueprint for creating an object. So class is considered as an object constructor, means it can be considered as a constructor that builds an object. It's like the main prototype design using which objects are constructed, or it can be considered as a blueprint. It is the metadata, whatever you like to call it. But class is there primarily defining the data, and when we create an object of it, we are able to use that data. So it becomes, an inspiration kind of a thing, a holy relation. A class without an object is useless. An object without a class cannot be created. So as I said, this is it's like a very close relation that needs to be established. So when we create a class in C#, you use the word class, and we have been doing this continuously. So I hope you already understand this, that every time we need to create a class, we create a class. provided it a name, recommendedly with a capital letter, but that's not mandatory. Make sure the name is a single word, does not contain space. If you are using two words, use underscore, not the minus sign or any other special characters. Second, the class name cannot be same as the variable name. It has to be different. So a variable is declared directly inside a class. It is often referred to as a field or attribute. It is referring to this thing here, string, color red. So now this thing is something we have not done yet. In previous examples, always we created variables inside a method, more commonly main method. Here we are creating a variable directly inside the class body, outside of any method. This is known as a class variable. Okay, often referred to as a field or an attribute. Means now this is a data that is belonging to a particular car, such as, hey, this car needs to be red color, or any other color for that matter we can choose. It is not required, but it is a good practice to start with an upper letter case naming your classes. We already talked about this, and then a common C# file and the class matches it. So, and when you save this file, you save your file with the same name as your class name. Now, we have been using online editors, so we are not worried that much about saving your application, but do know that every application for this online has the same namespace. Okay, it's just how the online editors are working. If you are using VS Code, so make sure you save your file same as your class name. So your file name is going to be same as your class name recommended, and then make sure you use a .cs extension. Okay, so we use .cs extension to save the file, and we use the same name as your class name. I hope that's just make a little bit more sense. Okay, now how do we create an object? So object is created from a class. Obviously, we talked about this. We have already created the class name car, and we have previous examples. We've created many cars. So now let's see how we create an object. So to create an object of a car is specify the class name. You need to specify the name followed by the object name, and then use the new keyword. So for example, we say car variable name. That's it. So this is what basically does. Just like any other variable we have created so far, integer, character, boolean, float or double, the process is same. But because integer, again, as I said, was a predefined data type, so that's why we use integer here. Character, byte, float, short, long, double, all these data types are predefined. They've been built in the system. So we use that type here. But because now we are creating an object of my own class, right? This is something my custom. So I'm going to use my custom name here. And then I'm going to give a variable name object. Okay, so this name again has to be the same name as your class name. This class or any other class, you can create an object for that matter. Because this C is capital, I have to make sure that I follow the same caps lock capital letter rule. So C goes here. Variable name, again following the same standard rules, is equals to. Now we use two other things as well. This time we have used something called new. We have not talked about this previously. Okay, so the new is basically a keyword. It's a reserved word used by C# alone. So technically you cannot use the new as a variable name. You should not use new as your own custom method name, or you cannot use new as a car name as well. So we need to be a little bit careful with respect to that. Okay. What new signifies is that you're creating a new object. This new will let the system know that I'm creating an object. So this new is actually the key part here that tells our system that, hey boss, I'm creating a new object. Okay, so this new is quite important in this matter. Then we use something called car with round brackets. Now why does this start here? This is actually referring to a constructor. Okay, like I said, an object is a representation of a class. So when we create an object, we are referring to all the methods of that class. So within that, we have something called a constructor, which is responsible for building this object. Consider that, right? So this is a constructor. It's not a method because it has the same signature. So we always confuse that this is a method. Be very, very careful of that. This is known as a constructor because it has the same name as the class name. Here you cannot declare a method with the same name as a class name. Okay, I will define the difference between constructors and methods in the next section. So bear with me a little bit, and we're going to talk more about this in constructors. But this is actually a constructor. So it's calling our class's own constructor and telling it that, hey, I want to create a new object and save that object information inside this variable, which will become of type car, right? So this is how we basically try to read it. that call a constructor. It's just like a builder who's going to create a new object of the and assign it to this my object variable, which will be of type car. Okay, so now this is an object. We do not call this as a variable. Okay, we do not say this is a variable. We refer to this as an object because we differentiate variable as integer x is equals to 10. Now we say this is a variable. Why? Because it holds one single direct value. So that's why it's known as a variable. We call this as an object, even though they follow the same structure, but we call this as an object because it does not contain a single value. In fact, it contains all the data and methods that we will declare in this class. Okay, so currently it has this data, so it will have access to this data. Then any other data you create inside this class, any other methods you create in this class, this will have access to all of that information. Okay, because it becomes instance of that class, it is representing that class, is an entity of that class. So that's why, because it contains a huge amount of data, it's not a variable. A variable, whenever we use this word, it's always meaning an integer data type or a standard data type or primitive data type having a variable containing a single value at moment. Object meaning it's a variable of a class containing or accessing all the methods and functions and attributes of that class. Understand? Hopefully you do that. So how do we know this constructor? We have not created it. By default, whenever we have a car class, there is a default constructor injected into this code by the C# compiler. And this has been done by the good people of Microsoft and .NET. So we don't need to worry about that. Obviously, we will talk about the constructors and creating our own constructors and customizing this later on. But for now, assume that there is a constructor that is responsible for creating an object of new object and then assigning it to this variable here. Obviously, constructor has exactly a different purpose as well, but it's easier to understand this way. Okay, so as I said, we will talk about constructor a little bit more later on, so don't worry about that. So now note that we use the dot syntax to access the variables. So now what we are doing here is we are using my object. I would say, hey, there's a my object here. Dot is a connection operator, connector that connects an object with the data of that class. So my object is my object. Dot color is actually this variable here, which belongs to this class. It is outside of any method. So I am inside my public static void main method. Inside this method, I am accessing my class's data. How do I doing this? By using this object, using the connection operator, and then we are referring to the variable name that has been done. So it is printing the value inside this color string variable using my object. Same mechanism we have already used with the console.write-ln. However, we did not create an object of console class because this method has been declared as static. So we are directly using the class name and calling it here. Okay. Okay. So I hope you understand these basic things, and we want to talk a little bit more about multiple objects. And so we're going to now talk more about multiple objects. I'm going to explain how, well, basically the idea is very simple. You can create multiple objects. And then when you do create multiple objects, each object has its own representations. So how do we create multiple objects? Well, it's quite simple. Just like any other variable, you can declare multiple objects as well. So in this case, we have again class car. So we create the car as a data type, defining it that this is going to be my class. We give it a variable name, which is going to be, for example, my object1 is equals to, again, we use the same new keyword, letting it know that we're creating a new object. And then we call the constructor car bracket star bracket close. So this becomes object1. Similarly, to create the second object, we use the same signature, just make sure you change the variable name, because two objects cannot have a same name, similar to two variables cannot have a same name. So now we have two objects, as simple as that. Then when we use color and color, it's going to object1 is going to go and read the color value and print the color value. And then object2 again will have access to the same color variable. So this is what we mean, that each object will have its entity, its instance of all the methods from the same class. So both objects are able to access the color method. However, do note that both objects work completely independently of each other. So if you use object1.color to change the value here, from object 1, it will not affect the object 2 color. And if you change the value to object 2 color, it will not affect object 1 either. So they are completely behaving independently. However, they are referring to their own parent prototype class methods. So you can use multiple objects of a class and access it in another class. This is often used for a better organization of class. So it's not only that you can use the object within the same class. So in this case, car is there. Inside the car, we have a static void main method. Inside the void main method, we create car and car. This is creating objects within the same class. However, you can access and create objects in another class as well. So for example, now we have class car. Okay, it contains public static void, doesn't contain public static void main. It only has a string variable called color red. And then we create another class, for example, called program. Now we say public static void main, create an object of class car, obj is equal to new car. Again, the same process, nothing changed. So what now this is going to do is that we have a file, or we have a class called car. It's a separate file, it's a separate class. It's saved as program2.cs. Then we have another file called program.cs. This again is separate. So we have two different files. The only thing to ensure that you save them in the same folder location. So they need to be in the same folder to be able to access. Then we say car.object1 and use the car object. So this will create object of this class. So now we have two classes, each working independently. So in this case, we create a car object in program.cs. And if I go into program2.cs, we have a class called car. So there are two different files. So I'm able to access and create object of car in one class, whereas the object's definition or the prototype is actually saved in another class. So that is also permissible. That is why we are able to use console as well. Console is a class that has been defined in the system and it's built somewhere else in this library, but we are able to use it here. Same goes for math. Okay, so when we use math dot functions, we use math that has been defined by the system, and we are able to use it in our own custom class. So you can create, access other objects and other methods from one class to another, but there is certain restrictions that you can apply, which is called access modifiers. Talk about this later on. Okay, so did you notice that the public keyword, now here's the key thing, as I said, the access modifier. So this public keyword here is actually ensuring that you can use this method or this data type or data type, because this goes for method as well as data type. You using it public, ensuring that you can use this method outside of this class in another class. So there is a way of restricting certain code, that whether its visibility is available or not. In this case, I am able to use this color property in a different class by using the object. So this is called a public accessibility. I can restrict that as well. So this public keyword is what we call access modifier, which specifies that the color variable or field of car is accessible for other classes as well, such as in this case program. So you will learn more about them in access modifiers. Okay, so this is how generally you can create multiple classes, multiple objects, as well as multiple classes. Okay, now let's move on to talking about class members. Class members means that data that can be member of a class, or when we say each class contains methods and fields or the data, it is a prototype. So what type of data can be put inside a class? Technically, we say there is only two types of data. One is known as data types, string color, integer max speed, belonging to a class body, not inside a method, and then we declare our own custom methods. So class technically contains only two type of data. One is called methods, second is called data type. That's it. You cannot write console.write line directly inside the my class body. This is a statement that executes and performs certain tasks. It has to be inside a method. So if you write console.write line directly inside the math class, it will create error, because hey, this is a statement that needs to be executed. A statement cannot go inside the class. It only needs either data type declaration or a method declaration. That's it. You cannot even call a method directly in a class. To call a method, you again need to make sure it is called inside another method. That is why we always use public static void main. So every program we have done up till this point uses void main, which is a method known as a default method, a mandatory method. At least one method has to exist in your classes. You can have multiple classes in your program. So if you're building in complex apps, you end up creating even hundreds of custom classes. But amongst this, one has to have this static method. So in this case, there is no public static main method, because this only is used to define the data. So class public variable has been created, only defining the data. To use it, we need to call this object. Again, this is a statement. It has to be done inside a method. Similarly, this again prints a line. This is a statement. It has to be inside a method. You cannot use either of these statements outside of the main method directly inside the class. So this is what we basically mean, that the class members technically are only two: data types and method names. That's it. So you declare and initialize a variable, and then you create a method or declare a method. Calling a method inside a class is also not allowed. Okay. Fields. In previous chapter, you learned that variables inside a class are called fields, and that you can access them by creating an object of a class and by using the dot. So the following example will create an object of car class with the name myObject, and then it will try to print the value of field color and max speed. So here's how we do this. Again, string color red. So we declare one variable inside the class. Integer max speed 200. Again, another variable inside the class. Then we declare a method. So it has to be main method. Inside this, we create an object. Again, this object is a statement, has to be done inside a method. You cannot do this directly. Oh, I think you can do this, sorry. You can create an object here as well, because this is again a variable declaration type. So this object creation can go inside here as well. Anyway, so at this point, we created a method here. We created an object here, and then we use console.writeLine myObject.color. So myObject.color will access this variable and print its value. MyObject, again, this will use this thing here. So you can use the fields, you can use the data types, data variables, and inside the class and access it. You can create an object inside a class variable and access it. Now, this is known as a class variable. By class variable means that the visibility of this variables will be across the entire methods. So if this class contains 10 methods, these variables will be accessible by all 10 methods, exactly like this. So all 10 variables will be able to use it. All 10 methods will be able to use this variable. I'm fumbling today. Okay. So this is basically what we need to understand, that we have data. This can be used by object and by simply using the object name dot color values. Okay. So this object has access to my class data. You can also leave the fields blank and modify them and when creating the object. So we can say that we have string color, string max. So we just declare the variable, we don't have initialized it. We create static void main, we create car object, and we give it a value, and then we can use this value. Okay, so if I come back here, same thing. So string color is max speed. We create an object, but because they don't contain default values, I say my object dot color. So I am able to change the value of here. Now note what happens if I just be a lazy guy and copy the entire code, come back here, paste it, and this time let me create object 2, and I change it to, for example, green, and then I change the speed to 100. And this time I again use the same thing. Okay. Now what I'm doing is I created an object, new car. I set its color and speed to red and 200. I printed its values. My object dot car or dot color, my object dot speed. So using the object, you are able to change the parameter, and you are also able to change, print or use the parameter. So both parameters, both variables have been changed, and then I print this value. Then I created another object, my object to new car. Again, same syntax. We say, okay, my object to and my object to. So using this my object to, I change the color to green, and I change the max speed to 100. Now I use console.writeLine, but I'm still printing the old object. Oh, I want to see that if I change the color using object 2, will it affect this object 1 or not? So if you hit run, you see it's printing red 200, red 200. Even though we have already changed this color to green and 100, but I'm still getting red and 200, red and 200, because I'm still printing object here, right? Why this color is not reflected with here. Just like I mentioned a few moments ago, every object has an independent copy of its class data. So every object is behaving independently. Each object is not concerned with other object of the same class. So when I have object 1, I change its value to red, and I have object number 2, I change its value to green. But this green will not affect this and this red will not affect this, because they two are independent copies of this string variable. That's the key thing. That's what object oriented means, and this is what object principle allows us to do. So that each object has a different representation and an independent representation of its class object. So now you can assume that if I have a student class and I say student name, student roll number, then I can create 20 objects of the same class. So there are 20 students in the class. Each student object will be independent of each other. So once I have a student 1 can be John, student 2 can be Ali, student 3 can be Ibrahim, student 4 can be any other name, for example. Each object will be independent using the same data of a class as a prototype, same method, same functions, but they all will have independent copies of their class. So once you change data from object 2, it will not affect object 1. And if you change data from object 1, it will not affect object 2, because they are independent. And regardless of how many objects you create, each object will have its own independent copies. So now if you come here and if you try to print object 2, which we just changed, and we run the code, you will see that now it will print green and 100, because now we are printing object 2. So object 2 has its own values. You can again come back here and you can see control C, you come here control V, and I can say, for example, red 2, and let's just make it 250, and then I again use object number 2 to print it, and I can create as many objects as I want, no problem. Each object will still be independent of each other. So now we have green, green, green. Object 2 is still green. Okay, object 2 max speed is still green, even though we have changed it here, but we have changed it for object 1, not object 2. So now if you print object 1 values, control C and control V, hit the run, you will notice that object 1 will now be red 2 and 250. At this point it should be red and 200, because at this point the value is red and 200. Okay, so first we can in fact say this one, right? Object 1 red and 200. So initially it's red and 200, then we changed object 2 to green and 100, so green and 100 is there. Then again we use object 1 and change its value to red 200, but we are still printing object 2, so object 2 still is green and 100. It's not changed at all. Okay, so if you want, you can put the constant here, for example brackets, and I can say object dash 1 and hit plus, object dash 1 color, color, and then let's just be a little bit lazy, instead of typing it again and again, control C, let me hit V, and then I can say instead of color SPEED, speed. Okay, and then this can be, for example, control V, make it object 2, control V, make it object 2, and then we come back here, control V, make it object 1, and then again just copy this whole thing, control C, and let's just be lazy, so make it object 2, control V, make it 2, control V, and hit run again. So we get a nice representation of what's happening. So object 1 color red, red, object 2 color green, green. So if you also need new line, you can do \n. Remember we talked about this is wonderful thing, \n, and then if you come here \n. So using \n, it will add a new line to it. So without using right line again and again, I can add a new line to make my output more readable and understandable. So object 1 is red 20, object 2 is green, 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 and object 1 now becomes red 2 and 250. So object 1 is independent of object 2, object 2 is independent of object 1, and you can create as many objects as you like. Okay, and then you have a data methods here. This is especially useful when creating multiple objects of one class. So if you have multiple objects of the same class, this becomes useful because each object is independent of each other. In this case, we have string model, string color, string year, integer year, static void main, I say car Ford, then I say car Opel, two different cars,
Ford.model Mustang red and 196, and then Opel has a model Astra white and 205. So see this, both objects are independent of each other, both objects have their own values, and when you print this data, both objects will print their own relevant data, just like we did right now. Okay, so I hope this makes sense and things more easy to understand. Object methods. Okay, so now moving on further, we talk more about methods. Previously we've been talked about class members, so this becomes a class members. Okay, class variables, okay, that we are accessing, or fields as we call them. So this becomes a field that we are using it. Now it's going to say, hey, let's just talk more about methods. So you learned about C# methods already. Methods normally belong to a class, and they define how object of a class behaves. So this is how we define in terms of object-oriented definition. Okay, in methods we define the definition of methods as a pure single entity method. But when we look at in form of objects and class and within the boundaries of OOP, we say that the methods normally belong to a class. So every method must be inside a class, and class can only contain methods and the data types or the fields, and they define how object behaves. So they will define what operations an object can perform. What are the things that we want to do with an object? So just like the fields, just like the variables that we create, you can access method with the dot syntax. However, note that the method must be public, and remember that we must use the name of the method following by the parentheses. So in this case, again, we have a class car, string color and speed, two fields have been created. Then we declare public void full throttle. So do note we are using public keyword here. Public keyword here means that this is an access modifier. It's like granting it an access permission that yes, objects of this car class, even within this or outside this, can use this method without any hassle. We have given them the rights that this method can be accessed outside the class or within the class. There is other access modifiers such as private, protected as well. Okay. So we say public, you can use it publicly. Void, again, we have talked about this. Return type, we don't need it. So I declare a method with around parentheses. It just prints some statement here. So when I want to access this method, I say car, my object, create a new object. We say my object, this one, dot full throttle. So now we are referring to this method here. Again, exactly same as console.writeLn, math.functions, or any multiple other various examples we have done. So this here we are actually referring directly a class name because this has been created as a static. However, in this case, we have created an object dot full throttle. So full throttle is the method name that's been declared inside the car class, and we are accessing it here. Simple. So why did we declare it as public, not as a static like the examples we have done in previous chapter? The reason is simple. Static method can be accessed without creating of an object. So we talked about this. I'm declaring the methods as static, so we don't need to create an object. When we declare a method as a static, it means that now this method does not need an object. You can directly use a class name dot this method name. And this is what's happening with this method, console.writeLn. So writeLn or simply write method are declared as statics. That is why we are able to use the class name dot the function name or the method name. Okay, static has that superpower. In other words, it just makes your method super accessible. So you can just say class name dot method and you can use it. Otherwise, there is no other way of using this method. So for currently, because these are not static, the fields and the method, I cannot use them except by creating an object. There's no other way. To use these two things together, we need to create an object and use the object name dot and the method or the field name. That's the only way of doing it. But if we define it as a static, now we give them a superpower. Now we don't need the object. We can directly use the class name and call this guy, and it will execute. Similar to the programs that we did in method as well. Don't worry, we will be doing some more tasks regarding methods and classes and objects later on. So I'm just trying to cover through basics, and then I will go and do around 7 to 8 different real world examples where we create multiple methods, create objects, use methods, change values, and do basic operations so we understand how things are working. Okay, so that will hopefully easily simplify various different things and create more understanding. But again, the examples are here. You can follow along and you can use this. Using multiple classes. Now, again, this is quite important to understand. Remember from the last chapter, we used multiple classes for better organization. One for fields and methods, and other for execution. This is recommended approach, as I said. So in this case, now we have a class car. So we declared string variable, we declare color variable, we make it year. But because now this needs to be accessed by an object probably created in another class, in such which will be a separate file, we make sure we make them public. Okay, so we make sure then we make them public. Then we create a new file. We write a brand new code. We create a new class name. We have a static method inside it. Inside this method, now I create a car for new car. So it will create an object of this car class in a separate file. Ford, again, the variable name, dot model, color, year. We give it 3 different properties. This object will have these values. Then we create another object, again of this same class, having different properties, and we can use this object and its parameters in a similar manner. So if you check out this code, basically now you will have 2 different files. One file here, second file here. One is called program.cs, second is called program2.cs. Program2.cs only contains class. Okay, so this is typically how we say a class contains data and methods, or fields and methods. That's it. Then this becomes my prototype. To access this prototype, we need to create an object so that we can use these methods and variables. We can create that object within the same class, or we can create in a completely new file having a new class name. Just ensuring the namespace is same. That's one thing. This namespace ensures that both the class belong to the same namespace structure, namespace package, like a namespace folder. Okay, so by specifying namespace same will ensure that this program runs smoothly and there's no error with it, and they both belong to a same project folder, in other words, or library, in other words. And then we just simply create a class, simple as that. Okay, so now the idea becomes, the more complex programs we write, we try to have multiple class structure, so which defines the prototypes, which defines the basic data. Then whenever we need to use that class, we create objects of that class, set values for that object, and then execute it. Understand? Perfecto mundo. Okay, so public keyword is called an access modifier, which specifies that the fields of car are accessible for other classes as well, such as in this case the program class. So you will learn more about these access modifiers later on or some future. Okay. Finally, let's talk about constructors. Now, what do we mean by constructors? We discussed briefly in the last section, last section. Constructors is a special method that is used to initialize the object. Okay, just like saying it constructs your object. Technically, we use the word initialize your object. You do note that when we talked about variables, we said that this is called declaration and initialization. This is declaration and initialization, right? I have used these words. So it means we are initializing a variable with a value. Understand? So in this case, this is called variable declaration only. We have talked about this phenomena previously as well. Meaning that I have variable that has been declared here, but it has been initialized here. It has been initialized here. It has been assigned a new value here. Okay. So when we go inside our constructors, constructors are used to initialize your objects. Note there is no value given to the object. So what should be the value of this? It does not contain a value because it does not contain a single value. It contains the data of a class. It represents data of a class, which is again multiple variables having multiple values and methods, multiple methods. So what should be the initialization parameter for this object? So that is why we use something called a constructor, which is used internally to initialize your object. So now through this constructor, we construct the object initializing it with some values, if you put it way. The advantage of constructor is that it is called when an object of a class is created. Only then the constructor is only executed once. It's not written here for some reason, and it's only executed when the object of this class is created. So at this line, the constructor is called only when this new object has been constructed and executed once in its lifetime. For every object, the constructor is executed. Previously, we have not created the constructor because internally a default constructor is injected within our code by the system, right? So that's why we don't worry about the default constructor or worry about constructor at all when we start learning. Because again, the good people of this .NET and developers knew that as soon as the people working, they don't want to learn about constructors right away. They just want to create objects. So to simplify, there is internally a default constructor. Second, not every single time you would require to work on the constructor yourself. So that is why internally there's a default constructor already present in our system. However, you can override it and create your own constructor, just like now. We're going to show you. So it says, we have a class car, we create a variable called model, then we declare something called public and car, parenthesis. This is the syntax of a constructor. Again, the code can be anything. The internal block is something block, again, we know defines the block of code containing multiple statements that are part of the main function or method. The main syntax is here. We set it to public because the variable or the object can be created anywhere in the same class or somewhere else. So we have to ensure that this is accessible. Second, there is no return type because by default it initializes an object, and so it will always return an object. So you cannot return something else. It always will return an object and assign it to this object variable. So that is why the constructor has no return type. Second reason is that's one key point that differentiates a constructor from a method. Okay, a method has a return type, a constructor has a no return type. That is how we identify. Otherwise, the syntax wise, it seems quite same. The third key feature is the constructor name has to be same as of a class name. Same letters, same alphabet. If you change it, starts to complain. Well, it won't complain, it will assume that it's a method. Okay, so if I come back here, let's view this code and let me just kill some of the previous windows before my system crashes. So many windows already open. Okay, I think I will leave the class example away. So now we have class, we have a public string model, which is a field, and we created a constructor. So if you use or change it to car2, legally allowed. Problem is, it will generate error that now it thinks it's not a constructor, it's a method name. So in C# will assume that, hey, you're creating a method, man. If this is a method, it needs a return type. So that will be the error. And if you give it a return type, now perfect, no problem. Because now it's not a constructor, it's a method. For a constructor, it has to have a same name as your class name. If name is different, it's no longer a constructor, it's a method. But if you forsakenly do use the same name and you forget to remove void, again that will bring a problem, because that's why it will get confused. So how we identify a method from a constructor? 2 points. First point, there's no return type. A method has a return type. Second, the constructor name is always same as a class name. A method name is different from the class name. Usually that's a standard practice. Okay. So now what we have done is we have created the constructor, public class car without any arguments. We gave it some values. So now we come here, car, Ford, new car, and notice what will happen, that when you execute this code, it prints Mustang. However, we are printing model here, and because the model value has been set here in the constructor. So constructor once initialize the objects, the code you use is exactly same as a method. Okay, so whatever code you can write inside a method, you can write inside a constructor as well. No problem with that. You can declare variables, you can print statements, you can do everything within it. So I can have this statement right here, control C. I can even say print and I can say, for example, let me just use this value, and I can say constructor CALLED called. And if I run the code again, it says constructor called. Okay, and then it's printing here. Why the constructor call statement is first? Because we created an object. So main method is with the execution point. This methods get executed, it creates an object. When object is created, the constructor is called and the constructor is called. Hence it will assign the value model to this variable, model variable to the Mustang. Then it's going to print this statement. So this statement in form of output gets printed first. Then the control will go from this point to this point, and the for dot model is used to print value inside write-ln method. Okay, so constructor becomes here. What if I don't use the constructor? Control X, perfectly legal, because now default constructor is already there. I talked about it. But if you use the constructor, now actually this is what we call constructor overriding. Okay, why overriding? Because a default or overloading, sorry, let's just use the word overloading. Why overloading? Because remember, in methods we talked about method overloading. Okay, this means that the constructor having same name, different number of arguments. So this is already declared. So since the constructor is already declared default, we are creating a new second version, an overriding version. In fact, this is overriding word. Okay, sorry about that again. Overriding in my understanding. Okay, because overloading is different. Sorry, overriding means that the public default constructor is already there, and we are actually replacing it and using our own method. Okay, so we are overriding the previous default constructor. If you don't use it, the default constructor is used. However, when you use the car, you are overriding the previous car default with your own custom thing. So the word is actually overriding. Overloading means that we can declare and we can do method overloading, just like method overloading. I can have integer x here. This is again perfectly allowed. Or in this case, let's just use, for example, a string mod, and I can say, listen, this model value should be equal to mod here. This is perfectly okay. What now it means is constructor called with model. Okay. So what this is now meaning, or this is what it's trying to do, is that now I have an overloaded constructor. Okay, so this is constructor overloading. Just like method overloading, where having same name but different number of arguments. We talked about this in method overloading. Method having same name but different number of arguments. Same applies with the constructor as well. So a constructor can be overloaded. Okay, overloading means a constructor having same name, and constructor has to have same name because the names come from class. So this car default without any arguments, you can overload it and you can provide it an argument. So now what we're going to do is we're going to say, hey, if I create car, this is also perfectly legal, it's going to call this constructor automatically. And let's be a little bit more lazy, copy this entire code, paste it, and this time I'm going to say, for example, this method, and let's just change this to ty, and let's be lazy, not write the full name, and I write ty. Now if I run the code, if everything is okay, it creates a constructor called with a model and Toyota is printed. Okay, so constructor called with a model is this one. So when you use constructor without without any arguments, the default constructor is called. If you provided an argument, now this overloaded constructor is called, that takes a string argument. Okay, and then there can be as many arguments as you want. So if this contains 3 arguments, you would have to use constructor that needs 3 arguments. Understand? So same overloading principle that we discussed in the method overloading is also applied in constructor overloading. So note the constructor name must match the class name. It cannot contain the return type, blah, 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 things already discussed. All classes have constructors by default. If you do not create a class constructor yourself, C# will create one for you. However, then you are not able to set initial values for the fields. Okay, so if it is created by default, you cannot initialize within the constructor the default value like we have done here. Okay, so to do this and to print that statement that hey, constructor called, object created, and so on and so forth, we actually need to override it and define our own functions. Okay, so constructor parameters, same thing. I think I already talked about this anyway. So you can give constructor parameters. So you can say public car having a string name. I already talked about this. And then when you create the constructor, you give it a value. So now it is going to use this value, pass it to this variable here inside the bracket. This value then be used here to rephrase, assign this value. So this is another workaround way of initializing a variable while the constructor or while the object is created. And then when you print it, it prints the same value. Okay, makes sense? I hope it does. We'll try to do a few examples later on so that you understand how things are unfolding here. Okay, so you can have these parameters as you want. You can have as many parameters as you want, sorry. So you can have like a string model, color, year. So I create a constructor that has string model color, and model year. And then I initialize these variables with this variable. So now what's happening is that model name, whenever I create, I will assign here, and this model name is used here to assign value to this model, which is actually this variable here. So actually I want to assign value to this. So to assign a value to it, I have left it on the object creation. So when we create an object new, we call a constructor with 3 arguments, constructor with the 3 arguments. Do note that here you can create a constructor without any arguments as well. If you do, it will call the default constructor. Okay, that's always there. So if you don't provide any argument, the default constructor will be called. No problem with that. But to initialize the variable's value, the default constructor is not useful. So we created our own constructor. So this is what we call overriding. So we say Mustang, comma red, comma 169. So what's happening now is this value will be assigned to this string variable name here, model name, which will again inside the block, this model name will now contain this Mustang value because we just assigned this and passed it through as a reference. Okay, so then this model value will again be assigned to this model variable, and this, which is basically this string variable. So now when I use for.model, it's going to print the model that I just created, red 169 Mustang. Okay, so it just understand the logic of how data is being passed, how data is being used, how data is being initialized. So if I copy this whole code again, I create another object, and this time instead of Mustang, I can say, for example, BMD, and then I can say, for example, blue, and then let me just say, for example, 2004, so 24, hit run. It gives us error. A local variable name Ford is already defined in the scope. So basically meaning that we have created 2 variables called Ford, not allowed. So let me just change this to BMX. And then instead of all of this thing, I'm going to use BMX, and Ford I don't like, so I can say BMX. And then again, Ford I don't like, I'll say can BMX. So now I change the variable names and values. So because this variable needs to access the color, this variable needs to access year, this object again needs to use the model. So once you update it, now we have different values. So object 1 is red, 1969 Mustang. Object 2 is blue, 2024 BMX. So both independent objects, both setting, both calling the same constructor, passing it a value based on that. So when I give it BMX, as a create as a create new object, initialize it with this constructor having these parameters. So these parameters will be going assigned to this variable value. Okay, then this value will be assigned to this model. Okay, so what we are doing is we are passing data from one point to another, from another point to another, and assigning it to a third point. So this is called pass by value, which means that we are passing value from one point to another. So the value BMX is being passed from this point assigned into this model variable, Now this is the container, but this is a temporary container. Then from this temporary container, we assign it to the main container model. Hence, when we use the BMX object, we use this model parameter to fetch the updated value, and it's going to come to us. I hope it makes sense. It's not too overcomplicating things. Okay. So constructors save time. Just like, for example, sorry, this step, just like other models, constructors can be overloaded. We just explained this concept already. So I think that covers it. It says constructors save time. Without constructors, this is how we write. We write Ford model, Ford color, Ford year, but and then open model, open color. So see this, what's happening now is that we are repeating multiple lines of code for each object. This is what we did previously as well. Okay, so we created one object with a default constructor. Then to initialize its value, we gave these parameters separately. However, if you use constructors, see this how short the code is, because now we said create a Ford object car, and then inside its arguments we directly pass three values. So instead of using these three separate lines, we just use these three values, and value object has been initialized with those particular values. So it simplifies and makes things a lot easier. Okay, if you understand it. So I hope up till this point it's quite clear. For now, I will end this session as well as this whole series of C# here. Next, I will be doing a couple of examples of classes and methods and objects, and try to cover as many things as we did within few of those examples. Okay, so do stick around. See you in next class.
Okay, the guys, so this concludes our day number 11 session. And in this, we talked about the C# oops, and we talked about various different things as much as we can in this, using W3Schools website as a reference. So I hope you found it interesting. This was a wonderful journey in 10 to 11 days. Try to cover as many essential topics of C# as we could. Okay, I know many things are still remaining, but it actually now depends up to you. I want to see how many of you actually want to learn extra topics, so I can make a video for that. And if nobody is like interested, it's no point making things that nobody watches, right? So I want to see how many people reach to the end of day number 11 and they are still interested in learning the next part of this course, so I can make them, and I will keep posted on that. Okay, there are a few other things that I will be making randomly about C#. Some example programs, I will be working on them, so you can follow along. I'm still working on creating the lab manual, so I will hopefully post that very soon. As soon as I complete, in the description you can find that. So do watch the whole course. Let me know in your comments what you liked about this course, what other things you want to learn, and what other things you want to know about C# or any other technology there is. Okay, so thank you very much, those of you who have watched it, liked it, and give me wonderful comments. Those who still haven't, please don't forget to do that. My name is Dr. Zeeshan Bhatti. This is signing off from C#. See you in next course.